Welcome to the course ASP.NET Core Deep Dive, where you're going to master ASP.NET Core like a pro and take your .NET skills to the next level. This in-depth course is designed for developers eager to completely understand ASP.NET Core and unlock the full potential of .NET. With hands-on assignments, real-world scenarios, and step-by-step explanations, you will be transformed into an ASP.NET Core expert. Let's take a look at the curriculum of this course. In this first section, you're going to explore the fundamental concepts of ASP.NET Core, including its anatomy and structure, and follow a step-by-step guidance to create your first ASP.NET Core app. This section sets the stage for your journey into the modern web development. You will experience in-depth explanations of HTTP, which is the basic knowledge for any web development framework. ASP.NET Core is fundamentally based on middleware pipeline. In this section, you're going to master middleware pipeline from understanding its theory to implementing custom middleware components. Learn to create built-in middlewares as well as branching pipelines effectively. Notice that for almost each section, you will have assignment to practice what you have learned. And after that, we have several sections focusing on helping you master minimal APIs. Here, you're going to delve deep into the world of minimal APIs, covering everything from routing, model binding, model validations, and producing results. We're going to also learn about standardizing the API result, as well as implementing CRUD operations. After minimal API, you're going to delve into the model view controller framework, starting with controllers routing techniques, model binding and model validations for controllers, and also producing results. You will also explore creating reserve views, managing layouts, and componentizing in MVC as well. After MVC, we're going to uncover the power of reserve page and understand how they differ from MVC. Learn to build dynamic applications with features like route matching, model binding, and validations. Create reusable components. And then you will have an employees management course project for you to put together everything that you have learned so far about reserve pages. You also have a chance to learn tech helpers to simplify complex scenarios, create interactive views, componentize your apps with partial views, and JavaScript. Filter pipeline is another advanced topic, and we're going to cover that for minimal API, MVC, and reserve pages. You're going to use filter pipelines to extract a lot of logic out of MVC controllers, minimal API endpoints, and reserve page models to simplify the development, make everything makes more sense and more efficient. Since you have learned minimal API, you're going to also learn how to consume the minimal API. And after that, you will also learn how to create web API with controllers. In this section, you are going to learn to master the art of documenting and versioning of APIs using OpenAPI and Swagger. You also have a chance to learn to simplify data management with Entity Framework Core, discover how to create database contexts, configure connections, run migrations, and implement repositories for efficient data handling in your applications. After we talk about configurations, logins, and exception handlings, we're coming to the last sections for this course. We're going to learn about securing our web applications as well as securing our web API. Here, we're going to master authentication and authorization principles, learn how to protect APIs with JSON Web Token authentications, enable HTTPS, and everything else that is essential for creating a secure web application as well as web API. And that's everything this course covers. It contains comprehensive explanations as well as many assignments for you to practice. Feel free to check out the landing page, and I really hope to see you in the course. In this video, let's learn about what is ASP.NET Core. ASP.NET Core is a web development framework that helps developers to create web applications. Therefore, first of all, in order to understand it completely, we need to understand what a web application is. A web application is fundamentally a network communication program that has two parts, a client and a server. The client sends a request to the server, and the server replies a response. In the case of web development, typically a client is a browser, and the server is usually called a web server, and this is where a web application is hosted. Because it is a network communication program, the messages that are sent back and forth between the browser and the web server have to follow certain rules. Just like when you communicate between two people, they need to use certain language that follows certain grammar. You can try to send something like ABC to the web server, and the web server is going to receive it. It is just that the web server won't be able to understand it. Therefore, it won't understand what you want the server to do. The rules that communication messages must follow in network communication programs are called protocols. In the case of web applications, the protocol is called the HTTP protocol. The message that is sent from the browser to the server is called a HTTP request. And the message that comes back from the web server to the browser is usually called a HTTP response. Now, we have mentioned that a web development framework like ASP.NET Core helps developers to create this web application. So let's break it down a little bit. A web development framework needs to help developer to understand the HTTP request based on the HTTP protocol. So therefore, the first step is to understand the request. And after it understands the request, it will need to execute the actual business logic. Every web application is created for a purpose, and usually it fulfills a business purpose, and we call that business logic. So this is the core part, right? We need to be able to execute the business logic once we understand what the request wants us to do. And finally, we need to work on produce the result and put it into the HTTP response so that it can be sent back to the browser to be displayed within the browser. So the third step to produce results. ASP.NET Core provides us a framework to complete all of these three different tasks. Although we as developers should focus our energy in implementing the actual business logic here, we should also know how ASP.NET Core works, because the other two parts are not done automatically for us. We need to understand how they work, we need to be able to configure them, we need to be able to use them properly. ASP.NET Core provides this framework, and we need to fill in the blanks. That is why we have this course for you to help you dive deep into the ASP.NET Core framework. In this video, we're going to learn about the ASP.NET Core anatomy, and we are going to learn about it by breaking down this diagram that we talked about in the previous video. So let's borrow that over here. So we need to break down this diagram. The first task that a web development framework like ASP.NET Core needs to perform is to understand the request. Usually, a HTTP request comes in as a string. In order to understand the request, firstly, it needs to translate the HTTP request into a .NET object. And in ASP.NET Core, we call that object HttpContext. So translate request that corresponds first to this first task. Once the HTTP request is translated into the HttpContext object, the object contains all the information that the request has. Once we have this context object, we can pass this object to other parts of the framework. And developers can also access this object directly when necessary. So therefore, the first thing ASP.NET Core does is to translate the HTTP request to an object. Now we can talk about the execution of the business logic here. But before we do that, let's establish a terminology here. When we are executing the business logic, there are different things involved, but eventually there's going to be a final function that contains the business logic, at least contains the business logic indirectly. And that final function is called endpoint handler. The reason why it's called endpoint handler is because an endpoint in ASP.NET Core is basically a unit that handles a request. So therefore, the final function that actually executes our business logic, which in turn handles the request, is called the endpoint handler. So once we have that terminology established, now we can think about how we are going to execute business logic. Right? In a real-world application, real-world web application, you are going to have lots of business logic to be executed Therefore, there's not going to be just one single endpoint handler. There's going to be many endpoint handlers. Then the question is, which endpoint handler should be triggered once a request is received? The functionality that maps a request to an endpoint handler is called routing. So the second thing ASP.NET Core does is to find out which endpoint handler needs to be executed, and this is called routing. Now that we know which endpoint handler needs to be executed, we need to determine whether the request actually has permission to access the endpoint handler or not. And that functionality is what we call authentication and authorization. If the request has permission to access the endpoint handler, we can then try to trigger the endpoint handler. But sometimes the endpoint handler contains some parameters as primitive types or complex types. Therefore, we need to extract the information from the HttpContext object, bind that information to our parameters in the endpoint handler. And that binding process is called model binding. So the next part in our NET MAUI is model binding, which binds the data from the HttpContext to the parameters of our endpoint. Now, through model binding, we have the data that we need to be passed. Before we actually execute the logic, we need to validate the data. Sometimes the data passed to the endpoint handler is invalid. Sometimes it is malicious. Therefore, we need to validate the data to make sure the data is usable. And that process is called model validation. Model binding means that we're going to have the data within the model. Now we need to validate the model. That's why it's called model validation. So here, model validation. After validation, we have the data. Finally have everything to execute the endpoint handler. The endpoint handler is where developers actually implement the business logic. It all boils down to one single function. But it doesn't mean that every time we just create a simple function. In ASP.NET Core, we have different options. For example, we can choose to use MVC. We can use Razor Pages. Or if you just want to use a simple function, you can use the minimal API endpoint handlers. And of course, if you really have a small application, but you want to use ASP.NET Core to complete the functionality of your application, then you can just stick to the middleware pipeline, which we're going to cover very soon in our course. I put middleware pipeline here. It doesn't mean that MVC or Razor Pages or minimum API, they don't use minimum. In fact, middleware pipeline is the base of all of the other options, but you don't actually have to use MVC or Razor Pages or minimum API endpoints. You can just use this variable, which is our middleware pipeline. But that's really for a tiny application that you don't actually need all three options. But we have these three options for creating our applications to implement our endpoint handlers. Now, typically, the endpoints, which contains the business logic, will contact a backend database. So I'm going to put the database here, and I'm going to put a rectangle here. So this rectangle contains all of them, but you have to know that the relationship here is basically this or this or this or this. So one of them. And typically, it contacts a database to get the data and prepare the data to be used in our algorithm within our business logic. So once we have the final data, we need to think about how to produce the results. And that's our final step. I'm just going to say the result. But it doesn't mean that we have to produce result manually. Whether we're producing HTML as a typical web application, or we're producing JSON or XML as in Web API, or produce any results, we don't have to do that manually because ASP.NET Core provides us with different mechanisms for helping developers to produce the result. Okay? We don't have to do it manually. So these are most parts of ASP.NET Core. Of course, there are different things that help developers to complete the web application, for example, configurations, environment setup, dependency injections. So all of these come together as parts of ASP.NET Core. We need to learn every single part of this, and we need to dive deep. Once we know how this works and how to configure them, how to work with them, how to fill in the blanks, then we master ASP.NET Core. And whenever there's problems, we know how to troubleshoot and where to troubleshoot. That's the purpose of this course. So out of all of these steps here, only the first one are not done in middleware pipeline. Every single one of this are actually produced through the middleware pipeline. As you can see, I used one single arrow points one by one by one by one. So what does it mean? It means that once the request is translated into HttpContext object, this context object is actually being passed to the next one, and to the last one, right? So this is actually looks like a pipeline, and we actually call it the middleware pipeline. So let me reorganize the diagram a little bit, and I'm going to put a rectangle to include all of this except the first one. So what we have here, this is our middleware pipeline, which is part of our web in ASP.NET Core. So I'm going to call this line, and I'm going to use this bracket here to indicate what I'm referring to. So middleware pipeline refers to everything within this rectangle. And each one of these functionalities are actually performed by the middleware component. So you can call this middleware component. Okay. Some of them are performed by one component. This one is actually performed by two components. And model binding and model validation, they don't have their own components, but they happen within some other components. Nevertheless, all of these are actually executed within their own component or some other components, and we call this type of component the middleware components. And it makes sense to call them middleware components because middleware pipeline executes the middleware components one by one by one. So that's our middleware, which encompasses everything except the first one. So then the question comes, who is responsible to translate the request to HTTP context? That is our HTTP server. And in ASP.NET Core, the HTTP server that we are using is called the Castro server. So this diagram is a very detailed breakdown. So let's draw another diagram, which is actually a high-level diagram. Okay, first of all, we're going to have our browser here. The browser sends a HTTP request to the web server. Now the web server consists of our HTTP server, which is our Castro server. So I'm going to just call it Castro server. This Castro server is responsible to listen to the request. So once it sees the request, it's going to translate the HTTP request into the HttpContext object, and then it's going to work with our web application. So our web application is here. So how does it pass the request, which is the HttpContext object, to our web application? And then our web application actually contains the middleware pipeline, which is displayed right here. So let's do it differently. Let's just put our web application label up here, and then I'm going to draw a pipeline here. So this represents our middleware pipeline. Request object, which is our HttpContext object, is passed into the middleware pipeline, and then our middleware pipeline executes typically many different middleware components, one by one by one. Here I'm just drawing 3 different components, but eventually the HttpContext object is filled with data, usually filled with the HTTP response. And that HTTP response is returned back to the browser, and now browser is able to display the result. So you can see that from high level, we have browser talk to the Castro server. And the cache server talks to our web application. And web application uses the middleware pipeline to execute different middleware components. And then the HTTP response is produced and passed back to the browser. So our ASP.NET Core development framework contains both the cache server as well as the web application. So that's the high level. And the detailed diagram is right here. Right? The HTTP request comes to be translated to HttpContext and then goes through routing, authentication, authorization, model binding, model validation, and it uses one of these technologies here to execute the endpoint database, usually context. It doesn't have to, right? And produce the result. And this result will be put into the HTTP response, right? So I think we have a missing line here, which is like this. And once the HTTP response comes back to the browser, then it's going to be displayed right here in the browser. That's a typical web application, which displays the everything in the web page. Sometimes you use ASP.NET Core to create a web API. For example, in this case, we have minimal API. The consumer, which is the client, may not be a browser. And we're going to cover all of that in our course. But in this lesson, you learn about the high-level structure of ASP.NET Core. We have browser, we have cache server, and we have web application. And we also broke it down into different parts. The cache server translates into the HttpContext object, and then the web application performs all of these functionalities through something that is called the middleware pipeline. And that's the anatomy of ASP.NET Core. Now let's take a look at the version of my Visual Studio. I'm using Visual Studio 2026, but I'm using the Insider channel because the preview versions are only available through the Insider channel. So if you're following along before .NET 11 is released, you're going to have to use the Insider channel. Once it's released after November, you can use the actual Visual Studio 2026 to follow along. Now let's try to create a project. So we can go ahead and try to create a project like this, but if it is the first time you use Visual Studio, it's going to look something like this. So you can go ahead and try to click on the continue without code. Once you do that, you basically come back to what I just showed you, right? But you don't have to do that. You can come over here again and try to click on this, create a new project. And then over here, you can play with the filters if you like to lock it to C#. And here we can say this is a web. You can do it this way, or you can clear all of the filters and come back and just type in something like ASP.NET Core. And this gives you all of the Visual Studio templates that starts with or contains ASP.NET Core, right? And if you scroll down, right, usually I put in a filter, at least the language filter, right, so that I don't accidentally select like F# or something else. Right? Now, I'm going to scroll down to find the ASP.NET Core empty template. The other templates are pretty good for creating projects, but for learning purposes, those projects are too noisy. It contains too many other things. We're going to use ASP.NET Core empty project template to learn everything from scratch. So select this one and click on the next button. And here, we're going to call this project name web app. And then the solution name, I'm going to call it my first web app. You can see the project name and the solution name can be different because one solution can contain multiple projects. We're going to talk about that soon. Click on the next button. Here in the framework, we're going to select .NET 11 preview. By the time you follow this course, .NET 11 might have already been released. And at that time, you won't see the parentheses preview like this. You might just see .NET 11. So for now, I have to use the preview version. So I'm going to select .NET 11 preview and uncheck the configure for HTTPS because later we're going to add HTTPS manually. And do not check the enable container support because we're not going to cover containers in this course. Now we're ready to click on the create button and let's close this. All right, if this is the first time you use Visual Studio to create a web application, let's talk about this. We have the solution and we have the project under it. So remember, this is the project name that I just give it, and this is the solution name, my first web app. So a solution can contain either 0 project or 1 project or more than 1 project. Here in the solution, we have just 1 project. But if you go to solution here and click on add, you can add a new project in it, and then it will show 2 projects under the solution. Anyways, I just want to show you that the hierarchy. A solution can contain projects. Currently, we only have this web application, 1 single project. Let's open this up, and you can see this program.cs file. So this program.cs file is the same as a console application, right? So a web application now looks like a console application. And in fact, it is actually a console application, but it's just a special type of console application. Let's go to program.cs file. Open it up, and you can see 4 lines of code. Before I explain what these 4 lines of code do, let's review our diagram that we talked about in the previous video when we talk about ASP.NET Core anatomy. So let's scroll down to this overview diagram here. You can see that for a web application, we have a Castro server, and then we have the web application right here. So the Castro server listens for requests to come and forward that request. Of course, it converts the request to forward that object to the web application. The web application uses the middleware pipeline here, process the request, and generates the response. Pass back to the Castro server. The Castro server forward that response to the browser for display. So this is the overview structure. And I want you to pay attention that we have this Castro server and we have this web application. Now let's go back to our Visual Studio here. The first line of code actually sets up and create the Castro server. And that's what the first line does. Of course, it generates this builder object. And then when the builder object calls the build method, which is the second line, if you hover the mouse over it, you can see that it actually creates or returns this web application instance. So this app object here is the web application. So now you know that this one sets up and creates the Castro server, which corresponds to the Castro server right here. And then the second line generates an instance of the web application, which corresponds to this rectangle right here. Now the third line is actually a middleware pipeline component. Right, we're going to talk about this later, but this one corresponds to the middleware pipeline component, which corresponds to this part, this middleware pipeline right here. And in this case, we only have 1 middleware component. Although in the diagram we have several, but in here we only see 1. Because this is the simplest web application you can create. And then we have this app.Run. Obviously, this runs the web application as well as it starts the Castro server. Right? It runs the web application in an infinite loop, makes the Castro server listens to the incoming HTTP request. As soon as it receives the incoming request, it's going to convert that request to the HttpContext object, which we're going to cover in perhaps the next video, at least in the future videos. And then that HTTP context object is going to be passed into the middleware pipeline component. Right? In here, we have only 1 component. We're not using that HTTP context yet, but in the future videos, we're going to cover that. It is very important to notice that these 4 lines of code are not executed in sequence. The middleware component is only configured there, but it's only executed when the Castro server receives a request. So it doesn't actually run in sequence. And you can see that with these 4 different lines of code. We're running our server. We're waiting for the request to come in. We process the request, which simply just returns hello world. And then it's going to come back and listen to that HTTP request to come in again. So let's actually run this application and see how it works. All right, you can see that the browser started, displays hello world in the browser. Now it also starts this console app, and this proves that it is actually console app, but it tells you that it's now listening on this domain and this port, and it's waiting for requests to come in. Let me enlarge the font size. You can see that it's listening to localhost 5276 and waiting for the request to come in. Once the request comes in to the root directory, it basically just spit out a string, hello world with exclamation mark. And then it comes back to listen to the port again. So this is how it works. Now, obviously, we talked about a lot of different things in our anatomy here, routing, authentication, authorization, model binding, model validation, and how we handle this request. This is the endpoint handler here, different types of endpoint handlers, and then it produced results. In our first application here, it doesn't reflect all of that because it's the simplest application you can have, right? But at least it shows a simple routing mechanism here. It maps the root to this function, right? This is a lambda expression that represents a delegate to a function. And this function simply just returns a string here. So it shows the routing mechanism, which is part of the routing middleware. Although it doesn't show the routing middleware, it actually by default wraps this code with a routing middleware. And then you can see we have this endpoint handler, right? And this is the minimal API type of endpoint handler here, right? We're going to talk about all of this. If it doesn't actually make sense to you right now, you probably don't know what a minimal API if you haven't used ASP.NET Core before, but I'm just providing you with the information, and we're going to dive deep into each one of this in the future videos or future sections. And then it produced results. In this case, it produced a string results. So you can see out of all those features, we can see this has one middleware component. We can see a basic routing mechanism that maps root to this lambda expression, which is this endpoint, right? And then you can see this endpoint handler here that simply returns a string. And then you can see it basically produces a string result and put it into the HTTP response. So it covers all of those features or parts in our diagram right here. Now, between the builder and the build, we can actually configure the Castro server as well as the web application, right? So for example, you can say builder.webhost. Here you can configure some parts of Castro server, or you can say builder.environment. You can configure the environment of the application, and you can say builder.services. Now you can add services to the application, which we're going to talk about in the future as well. And you can use configuration to configure the application as well. So all of these we're going to talk about in the future. In this video, we have seen the basic structure of a web application that starts a Castro server, builds a web application, add a middleware pipeline component, maps from the root to a function, endpoint handler, and it listens infinitely to a specific port for more requests to come. So I would like you to go back and familiarize yourself with this diagram and map this to this simple 4 lines of code. In this section, we are going to talk about the HTTP protocol. If you're familiar with this topic, feel free to skip this chapter. If you want to learn everything from scratch, I recommend you to go through this chapter. As I mentioned before, the interaction between the client and the server starts with a HTTP request and ends with a HTTP response. And the HTTP request will actually go through the entire pipeline. And each one of the middleware component is actually responsible to create or add information to the response. So for the entire pipeline, the entire process, we are dealing with the HTTP protocol. That's why we dedicate an entire section for understanding the HTTP protocol. If you are familiar with it, you can skip this. But if you do want to understand everything from scratch, I recommend you to spend some time in this section. Okay, the first lesson in this section is going to be related to the HTTP request. The HTTP request is used by the client to provide requirements, the server. So that's the purpose of HTTP. Throughout this chapter, I recommend you to keep this purpose in mind. For the HTTP request, it's responsible to provide information, and that information is used as requirements from the browser to the server in order to ask for some information. The browser, which is the client, contacts the web server, which is the server, for specific purpose. And that requirement is provided within this HTTP request. And it needs to clearly state what information is needed, in what format. Now let's talk about the protocol. The HTTP request, you can consider it as a string that is passed from the client to the server. And let's talk about the syntax here. On the first line, it needs to provide the method. And then there's a space, followed by the URL, and another space, followed by the version of the protocol, a version of the HTTP protocol. That's the first line. That first line finishes right here. And this first line is called the request line. The method represents the action that the client wants to take on the server. The URL represents the location where the action should take place. So those are two parts of the important information here. And then it changed to the second line. The second line is actually optional. It could be 0 or many HTTP headers. A HTTP header is a key value pair that's separated by colon. So for example, accept colon text HTML. So I'm basically saying to the server that I prefer the response in HTML format. I can provide other headers, or I can just have one header. In fact, I can have 0 header. So let's say that I provide another header and I want the natural language to be in English. Let's say this is actually accept language, and then I'm going to say EN-US. Okay, so I accept the natural language to be in English. So after I provide headers, you can actually add more headers here, but if you don't have any more headers, then you need to have an empty line here. And then after that, this is the body part. The body part is the information that is going to be transferred to the server side. Again, we provide the server with some data, some information to process. So this is the basic format. Right? So you can have a lot of stuff in the body part. Again, we have 3 different parts in this HTTP request. The first line, which is the request line. And starting from the second line until the empty space are the HTTP headers. And the line after the empty space, empty line, is the body. So all of these should be considered as a requirement sent to the server, and then the server will take a look at the requirements and return proper response. So that's the purpose and the syntax of HTTP request. So let's have an example. For a normal request sent through the browser, it's usually a GET request. And then this URL here is a relative URL. Right? So it's based on a certain domain. And that domain is actually provided in the header. So a certain URL, for example, if it's just slash, this indicates that I'm trying to get some resource from the root. And then the version by default, the version here is HTTP 1.1. And now it comes to the HTTP headers, which is a key value pair. And I'm telling the server to give me HTML content. And I'm telling the server that I accept English language. And the body usually in GET request is, we don't provide any body to the server for GET requests because it's not necessary. Body is usually used for the post or patch or put request. We're going to talk about that later. Right now, let's just focus on simple GET request. Okay, so this format of string follows the syntax right here. Okay, we have the method here, which indicates the action that the server needs to take. Means that the client is trying to get some information, or you can see the client is trying to retrieve some information from the server. And from which location? From the root. And what is the version of the protocol? And then it provides more requirements, right? The client provides more requirements. I prefer HTML and I prefer English language. And for GET request, again, there's no body. Body is empty. All right, let's take a real world example. This is the application that we created last time. This basically comes up comes out from the Visual Studio template. And if we run this web application, we're going to see this in the browser. Now, if I press F12, this is going to show up. This is called the developer tool. Press F12 to go to the developer tool, or you can go over here and then go to more tools and then go to developer tools. Okay. Now, when you see the developer tool, click on the network tab and you can see this red button here. It says stop recording network log, right? So what this means is that currently the developer tool is trying to capture all of the network traffic. Although there's nothing here, it's because we have just started this developer tool. So this web page is rendered already. Therefore, you couldn't see anything. But in order to see some results in the network tab here, you just need to keep this running, right? Don't click on this button to stop it. So keep the recording going and then refresh this page. Now we can see something here. So it says localhost. This means that the network tab recorded one request sent to the server. And we're going to talk about the status, the document initiator later. But right now you can see that this is one request. And if we click on this, then we see more information right here. Usually in your developer tool, by default, you're going to see this as well. But we may talk about this later. In order to provide you with bigger screen, I choose to hide it. Okay, and then I'm going to enlarge font a little bit so that you can see clearly. This screen, if this is the first time you see it, it could be a little bit confusing here. You can see headers, and then you can see response, and then under headers, you can see response headers and request headers. Right? We're going to talk about HTTP response later, so therefore just collapse it. Right? Just collapse this one so that you don't see the response headers. And then scroll down to request headers here. And then you see this raw here, and just click on this raw here. And now you see the actual raw HTTP request. And this follows the HTTP request syntax, right? You see the method here, and you see the path right here, which is the URL, and then the default HTTP version, and then a whole bunch of headers. You can tell this is a header because it is a key invalid pair. This actually goes to here. And then another key separated by colon and value. Key, value. Now, some of the most commonly used headers, first of all, is the host, because this is the relative path. So this host provides actually the domain plus the port. Right? If the port doesn't exist, it doesn't mean there's no port. Web application by default runs on port 80. So if you want to run it on a special port, you need to specify that in your application. And we're going to talk about this port specification later. Right now, this web application is configured to run on 5276, and the domain name is localhost. So the whole thing is the host. This indicates the address of the web application. And then this path, which is the URL, indicates a relative URL that is relative to the host. And then you can see what is the encoding that is required by the browser, what is the language required by the browser, and what is the cache control required by the browser, and what is the browser. Right? The browser says, I am Mozilla 5.0. So all of these information can be used by the server to make decisions to come up with the right response. Let's say you just want to come up with a response randomly without looking at what language the browser prefers, and then you come up with German. Then the client, which is the users, will not be able to understand it. Right? So it's important to take a look at the requirements from the HTTP request and then make correct decisions about what you should put in the response. Okay, that's everything I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one. In this video, we're going to run our code and we're going to see the HTTP request in the HttpContext object. In this diagram, you have seen that the Castro server is responsible to do something. So the Castro server is
the HTTP server. So one of its responsibility is to translate the HTTP request, which is a string, right? You can consider that as a string. So Castro server needs to convert the string into a object. And in the ASP.NET Core, the type of that object is the HTTP context. We scroll up here to this detailed diagram here. You can see that this step is the first step. This is performed by the Castro server, which is to translate the request to HTTP context. And we're going to see that in this video. So let's go to Visual Studio. Here, we talk about this one. This is the only visible middleware component here. But this one does not use a HTTP context. So we need to change to use a different methods. In the web application instance here, there's different methods. One of them is called run. And this run has different signatures here, different overloads. This one takes a delegate, and we're going to use this one. The delegate, we can use a lambda expression to do it, but then it takes a HTTP context as a parameter, which means that the Castro server was able to convert the HTTP request into this context object before this delegate is even executed. Because it was able to do that before, so when this delegate is triggered, it's able to pass this context object to this delegate. And we can use the context within the delegate. So if we see context, then you can see that we can access the request object right here. And in the request object, let's actually go back to our diagram first. In here, you can see that this is the syntax, the method, and we have URL, we have version, and we have headers, and we have body. This is the different parts. This is the anatomy of our HTTP request. So keep that in mind. First one is method, second one is URL. So let's go over here. We should be able to find all of that in our request object here. Otherwise, Castro server didn't do its job well. So let's do request dot. And then you can see this path. This path actually corresponds to the URL. And then you can see we have a method. So this method corresponds to the method in the HTTP request. And after the method and the path, we see the headers. Okay, so the headers is actually a dictionary. So this dictionary contains a key value pair. And after that, you can see we have body. Now, of course, if we scroll down, we can see content length, content type. So these are commonly used headers. That's why they have a specific property. But you can actually find the content length and content type inside the headers dictionary as well, okay? As well as cookies. Form as well. Form is actually inside the body. We're going to talk about that later. Okay, so you can see all of this. So what I want to do in this video is I'm going to output all of this, the path, the method, headers onto the page. So in order to do that, we're going to actually use the HTTP response object. We haven't talked about that, but we can start using it. We're going to say context dot the response dot, and then we can say write async. So this is going to output data to the response object. And then when the response is sent to the browser is then able to display the result in the browser. So in this case, we are going to write some string. And let's say the method is, and then we use string interpolation here. Let's say context.request.method, and we're gonna do a character return, okay? And I'm gonna write next line. So here, I'm gonna say the URL is, and again, I'm gonna say context.request.path. And then we're gonna write all of the headers. So for the headers, I'm gonna do a for each loop. So I'm gonna say key in headers dot keys, and then I'm going to say headers. So, but before that, I'm going to just write something like this. I'm gonna say headers, and then I'm gonna add a character return again. So here, I'm gonna output all of the headers. And I'm going to say context.request. So first part is the key. So I don't need to get it from there. I can just use the key from right here. And then I'm going to say headers and then use the key as the index here. All right, so we're outputting all of that. And of course, the body is always empty in this case. Now you see this red squiggly line. That's because we're using the async method without using async and then await keyword. So we can add that in front of, and I'm gonna say await, and await. All right, so the red squiggly line is gone. And let's try to run this. Okay, so we got our result here. The method is a get method. The URL is /, which indicates this is the root. Okay, and then We don't have any headers. And then we have headers here, date, server, transform, encoding, but the value is not output correctly. And the reason why it's not displayed correctly is because we are using response.headers instead of request.headers. So we have to loop through request headers because that's what we want. So I'm gonna say request.headers.keys, and then here we are using request object correctly. That's why we were not able to see the headers. So let's run it again, and we should be able to see all of headers here. So again, method is get, URL is the root. And we have all of the headers. So for accept, this is the value. For connection, this is the value. For host, this is the value. And this is the user agent, accepting encoding, accepted natural language, and all of the rest of the headers that the browser sent to the server. When we use the run method, we don't care about the mapping. All of the requests will go through this run method, right? Go through this middleware component that is created by this run method. So for example, instead of just go to root, I can go to any place. For example, I can go to employees, although I don't have it yet. But when I go to employees, it's going to still run the same thing. Right? This is going to be triggered. So we're going to talk about basic routing in future lessons. But right now, you notice that no matter which URL you are going, I can go to any valid URLs and I'm going to get the same result. That's because if you send a request to the server, this middleware component is going to be used here. And then all of the code is being run. And we're just outputting using the response object, okay, the right async method in the response object. Okay, so in this lesson, you've learned to actually see the different parts of the HTTP request in the HttpContext object. We have our method, we have our path, we have our headers. And of course, we have our HTTP request body, but the body is empty. And we're going to talk about the body when we talk about the post method, the put method, and the patch method in future lessons. Okay, this is all I'm going to talk about in this video. If any questions, please let me know. If not, I will see you in this video. Let's learn about the HTTP GET method. Sometimes the method in HTTP protocol is also called verb. So the HTTP GET method sometimes is called HTTP GET verb. And the purpose of this HTTP GET method is to retrieve information from the server. So we have this application that we wrote previously. And if we run this application again, we get this result. So you can see that the purpose here is to see what is the method, what is the URL, right, and what are the headers. So this is the seeing purpose. Right? We're getting the information from the server and displayed in the browser. So we have to be clear about the purpose first. Right? That's the purpose of the GET method. Again, let's run this in developer tool. Let's go to this request. And then let's click on this raw and we can see the actual raw HTTP request here. We have this GET method. We have this / as the path, which is the URL. So the combination between the method and the URL is typically used for routing purpose. And if you still remember what I meant by routing, right? I mentioned in one of the first videos that routing is the action of mapping from the HTTP request to a particular endpoint handler. So in this video, let's use the method and in combination with the URL to actually do something. Let's jump back to Visual Studio. We already mentioned that this middleware will be the middleware that any request will be route to. Right? Any request will execute this particular delegate function here. Now, I can have some decision making based on the information provided in the HTTP request. So for example here, I can do some basic routing. If context.request.path, which is the URL, right? If that starts with root, so if it's the root, then we can do this. And if we want to do another if statement here, So if it starts with /employees, we want to output all of the employees. Right now, I don't have an employee list. So I'm going to just write this. I'm going to say employee list. So this decision is based on the path. But where is the decision making based on the method? Do something like this. Context.request.method. So if this method is the get method, then we are going to perform the following actions. We're going to decide whether we're going to execute this or execute this based on the path. You can see that we're making decisions based on the combination of the method and the path. All right, let's execute this. And by default, we're hitting the root. And that's why we're seeing this. But if I go to employees, then I see this employee list. Currently it's hard-coded, right? And if I go to anywhere else, I get nothing, right? I get nothing because anywhere else means that there's nothing in the response, Now to code a proper employee list, let's create some in-memory repository. I'm gonna copy and paste some code so that you don't have to watch me writing it. First of all, I'm gonna define an employee class, and I'm gonna paste it right here. So the employee class has simple 4 different properties: ID, name, position, and salary. And then I have this constructor defined in order to help me to initialize the employee. Right? And then I can define the in-memory data store. And I'm going to call it repository. So I'm going to copy and paste this right here. So this is a static class. And it has a static private member here. And this is basically storing the list of employees. And by default, I have 3 different employees instantiated. And then I have a public method here to help me to get all of the employees. So very simple in-memory data store defined right here in the program.cs file. Okay, so then I can come over here. So instead of using this hard-coded employee list, I can then get the employee first. So employees by using the in-memory data store here, right? The employee repository for some reason. Oh, okay, so it has some spelling mistakes here. So employee, coming over here and paste this over here. Okay, so then I can call this public method here, get employees, and this is a static method. So it's gonna give me all of the employees. Now I can do for each. So for each employee in employees, then over here, I'm going to output all of the employees. So I'm gonna copy this and paste it over here. And then I'm gonna remove this part, and then replace this key with employee.name. And I'm also going to output the position. So employee.position. And then let me delete this line. We don't need it anymore. Okay, so this is a relatively useful example here. If you hit the default root location, root path, then we are spitting out all of the headers, okay, basically the anatomy of the HTTP request for learning purpose. If you're hitting the employees URL here, and if this is a get method, then we're calling the get employees public method in the in-memory data store here. And then we get all of the employees. We're going to spit out all of the employees in the response so that they can be displayed in the browser. All right, let's run this and see what's happening. Okay, let me close the previous windows here or tabs here. And then let me go to employees. Now you can see John Doe is an engineer, Jane Smith is a manager, and Sam Brown is a technician. So in this video, what you learned is that the purpose of the get method is to retrieve information, or you can say retrieve data from the server side, right? Whether we're hitting the root URL to display all of the information about the anatomy of the HTTP request, or we're actually retrieving data from the data store, the in-memory data store about the employees. We're getting information from the server. So that's the purpose of the get method. And secondly, what you learn is by simply using combination between the method and the URL, you can implement a very basic routing, and you can call this endpoint. So this is actually the endpoint handling, right? And this is also another endpoint handling, right? And it's just that we are not calling this properly. And we're going to talk about organizing this when we talk about minimal API. Right? Minimal API will have similar problems. We have different ways to organize those logic. Right here, these logics are endpoint handling, but they look very messy because everything is together. Anyways, we covered the get method, and we're going to talk about the post method in the next video. In this video, we're going to talk about the HTTP post method. First of all, the purpose of the HTTP post method is to create new resources on the server, right? Which is different from the get. Get is to get information, retrieve information from the server. The post method is to create new resources on the server. So for creating new resources on the server, of course, we need to provide information from the client to the server, right? Provide the information about the resources that need to be created on the server. And typically, those information is provided by the HTTP body, right? The body part of the HTTP protocol. So let's jump into Visual Studio and let's create this basic routing in order to route to the correct endpoint handler. Okay, so previously we were checking whether the method is get. So let's actually close this. And then coming over here, we can say else if, or we can change to use switch. But let's continue to use if statement. So here, if the method is post, then I can decide something else. Over here, I want to check which location. So after checking the method, we want to check on which location this action needs to be taken. So therefore, I'm going to use another if statement. And I'm going to say context.request.your.path. If this starts with employees. So notice that I'm using the same location to get, right? So here /employees, here /employees. So location is the same, but the difference is that the method is different. This one is the post method, and this one is the get method. So when we use a post method, we end up on a different endpoint handling business. Here. So here we want to add a new employee to the in-memory data store, which is this list here. But first of all, we need to get the information that is posted over through the request. And that is usually in the body, as I mentioned. So in this case, I want the client to post JSON string over to the server. So therefore, I assume that everything is in the body, and I need to parse that to a AsJSON. So let's access the body object in the request over here. So I'm going to say request.body. And now you notice, if you hover the mouse over, you notice this is actually a stream. This is not a string. So you need to read it as a stream. So what we can do is we can declare a reader. So I'm going to say using var reader equals new stream reader. And then here I can put in the stream, which I'm going to move this over to here. And now we can use the reader dot read to the end, read to end async here. And I can use a await keyword. So now this one returns a string over here. Okay, so this one returns a task string, but when you use await keyword, it takes result out from the reader. So I'm going to say var body equals that. Okay. And everything after the wait keyword is a continuation. So I have another course regarding the multithreading and asynchronous programming that help you to understand async and wait as well as traditional multithreading programming. Okay, let's continue. So once we have the body, which is in a string format, we need to deserialize that into the employee object. Right? So what we can do is we can say JSON serializer, right? And then we can say deserialize, and we can provide the type, which is employee. And then should do is to deserialize the body string. This should return me a employee. And I'm gonna say employee. This is a new employee. This employee needs to be added to this particular list. So therefore, let's go down to the in-memory data store here. Let's add another method to help us to add. So this is going to be a static method for sure. And then I'm going to say add employee, and I'm going to provide the employee over here. Here I'm going to say employees.add employee. Okay, that's it. Let's go up here and let's use the employees repository. So employees repository dot add employee, and then I provide the employee right here. This will added employee repository. So it has a green squiggly line here because this could be null, right? So therefore here I can modify that to add a question mark. And then we can say if and only if employee is not null, then we're going to actually add an employee to the list. And then when we scroll up here, you can see green squiggly line is gone, and we're able to add the employee into the in-memory data store without any problems. So again, this is a simple routing, which is done by a combination between the method and the path, the URL. And then we are deserializing the JSON from the body, and we add that to our in-memory data store. All right. So we want to give it a try, but we can't because we cannot send a post request from the browser, right? So how do we do that? Either we create a form somehow to test this, or we use a third-party tool. So in this video, let's use Postman. So you can go to Google here, bring up a browser instance here, and then I'm gonna say Postman, and now you can see the Postman right here, right? Click on it, download it if you haven't downloaded, and install it. And once you install it, you can launch it from here. You can see Postman, and I'm gonna just run Postman. When Postman is launched for the first time, it asks you to log in, but logging in is optional. I currently log in with my Google account. Therefore, all of the previous requests that I created is listed right here. You don't have to log in, but if you don't log in, then you don't see your previous request. So now I can create a new collection, and I can call it blank collection. And then I'm going to change the collection name to ASP.NET Core Deep Dive. Okay, it shows up right here. Now I can open it up, and then I can click on this and say add a request. And when I do that, it shows me this window. When it shows me this window, you see that this is actually very similar to the HTTP request syntax. First, you need to provide a method. Secondly, you need to provide a URL, and then you can provide headers down here. And the header is in the key value pair. So this is almost exactly the same as the syntax of the HTTP request. And in this case, we are not creating a get method, we're creating a post method. Open up this drop down, and then you can see all of the options right here. And in this case, we're creating a post method. And which URL are we targeting? Let's go over here. We can run it to see it. So let's run the application, and it is running right here. And we can copy this and go to Postman, paste it right here. Now, we don't need to specify any headers, but we do need to go to body, and we need to specify the JSON body. To specify the JSON body, we can click on raw, and then you can specify the format. So in this case, we are posting JSON, okay? Typically, when you submit a form, it's this one, form data. But in our case, we're expecting JSON, therefore we're gonna say raw and specify the format here. So JSON is basically key value pair, and it's surrounded by a curly brace here. So we're expecting the employee object, which corresponds to this one. So ID, name, position, and salary. And I have to use double quotes, okay? And then a colon, and then a double quote to provide the data. Well, for ID, it is an integer, so I don't have to have double quote, right? But let's go over here. We can see that existing ID is 123. Let's avoid using existing ID. I'm going to say 4, and then I'm going to say comma, okay? And now the second one is name, right? And I'm going to say my own name, Frank Liu, and the position, I'm going to say software developer, and salary, I'm going to give myself a big number. Let's say $1 million a year. How about that? Well, I cannot make a lot of money. In reality, I'm going to make a lot of money here in Postman. All right, so we have our data prepared and we have our application running. Okay, now I actually want to run this in debug mode. First of all, let's set a breakpoint right here and run it. And the first request is a GET request. It's not going to come to this breakpoint, but let's use the Postman to click on the send button. First of all, let's click on save button to save that to our collection here, right? And we can give it a name, right? We can say new employee, or let's say add employee, okay? And then click on the save button again and click on the send button. So once we do that, you can see that it recognizes this is a post request, and then hover the mouse over its path. So this is the wrong location, right? So let's continue. It's not gonna actually execute our code. So this is the wrong location. We have to say employees in order to actually hit our breakpoint, actually execute our endpoint handling logic. So click on send button again. Now let's do F10. Now you can see that the if statement works here. We're going into this endpoint handling logic here. And then we're going to read the body and try to read everything into this body variable here. And if we open this, you can see that we actually have the JSON in our variable. Now we deserialize it into a employee object, and you can see everything is properly deserialized. And then let's run it. Okay, so you can see from the Postman here, right? The top part is the request, and the bottom part, the bottom half part, is the response. We're going to talk about the response later. For now, at least you notice a green sign here. It indicates that we have a success, right? This particular post request comes back as a success. Now we have this guy running. Let's go to employees and see whether we can see the new employee, and we do. We have Frank right here. This is the one that we just added, right? We can try to add another one. Actually, let's remove the breakpoint. We don't want to see it again. We know that it works. So instead of Frank Liu, let's add something else. Change the next ID, and let's do this one, the Tom Anderson. And this guy, instead of $1 million, let's give it 100,000. That's not a bad salary anyways. And let's click on send. All right, we got a success here. And if we run the employees get, right, we can get Tom Anderson back. All right, that's the end of this lesson. In this lesson, you learn to use the post request method. And in order to actually post something, we installed Postman and we learned to use Postman. We select the method, we specify the URL, and we specify the body to post the JSON information. And what we did in our Visual Studio here is that we use a basic routing, right? A combination between the method and the path, which is the URL. And then we execute our endpoint handling logic here. We use stream reader to read information, and then we deserialize it and we add it to the repository. Right? In fact, you can try to also create a GET request here. You do this, add a new request to here, get the same thing, employees. This is to get all the employees, right? And we don't have to specify the headers unless we need to specifically specify something. So if I click on the send button, then I get all of the employees back. Well, because I restarted the application, therefore I don't have Frank, I don't have Tom, I only have the initial 3 different employees, but you can see that we are able to use Postman to send different type of request. Okay, that's everything we want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one. In this video, let's talk about HTTP put. Now, first of all, the purpose of HTTP put is to update existing resources on the server. Again, let's jump into Visual Studio and let's perform the basic routing. In the past, we have the basic routing to tell what type of method is being used and then which location is being hit, right? So same here, we have our post and the location. And for HTTP put, we're going to use the same thing. Let's copy and paste it over here. And we're going to say put here. Okay? So if the method is put and if the location is employees, then we need to update existing employee. So here we're going to do the same thing, right? Because for HTTP put, things will be posted back. Okay? Since information about the existing employee will have to come from the client, and that is in the HTTP body. Therefore, here we need to get the body out from the request object within the context object. And then we use the reader, read the body, use the serializer to deserialize the body into the employee object. And then here, instead of calling add employee, we will need to call the update employee, although we don't have the method yet. We don't have the update method for the employee yet, but we can write it first. Now let's scroll down over here and let's add the method. So here, public static. And then for this one, I'm going to use a boolean and I'm going to say update employee, and I need to pass in the employee information here. So again here, I'm going to say if employee is not now, then I'm going to do something. First of all, I'm going to test whether this existing employee actually exists or not. Okay. So I can do something like var employee or employee like this equals employees, which is the in-memory data store. And I'm going to say first or default. I'm going to look for that based on the ID. Right? So this one equals employee.id. So if this one is not now, then I'm going to update it. I'm going to say employee.name equals employee.name. Right? emp.position equals employee.position, and employee, right? emp.salary equals employee.salary. You can use a mapper like an auto mapper, but we only have 3 different fields here, so I'm just manually mapping between them. Now here I'm going to just return true, and if we don't have an employee that corresponds to this, or if the employee is null, then it's going to fall over here and we're going to return false. Okay, now we can scroll up here, and then when we update it, we're going to get a result. And after that, we're going to test the result. If it's a true, then we can say context.response.write async, and we can say employee, maybe say updated successfully, and we add a wait keyword here. Otherwise, we can say something like employee not found. And later when we talk about status code, we're going to distinguish between these different status. Right now, we're not touching status yet, right? Everything, even when we have this problem, we are going to return success status, which is HTTP 200. Like I said, we're going to talk about that status code. That belongs to the HTTP response. All right, let's give it a test with Postman. First of all, let's run the application. Okay, the application builds well, and the default homepage is showing all of this information. Let's go to Postman here, and let's add another request here. So click this, add request, and here, this is the new request. And we're gonna say update employee, and over here, we can choose the proper method here, which is put. And let's go one of the previous one, and let's copy the location. It's the same location, right? Just different methods. Okay, let's go to body. Now, before we go to body, let's go to add employee and let's copy an existing one, right? And let's go over here, date, and go to body, go to raw, and the default is JSON, and that's what we are going to use. So let's paste this over here. Before we actually test it through the put method, let's go to employees and click on send. So let's get existing employee, which is just 1, 2, and 3, right? Those are 1, 2, 3. So in order to update one of them, let's say we're going to update the last one, right? So let's go to update employee. So we're going to change the ID to 3. And then the name is going to stay as Tom Anderson, software developer. This is 100K salary. All right. So let's click on this and try to see whether we are able to opt. All right. It says 200 OK, but it says employee not found. Well, it's because we have this ID 35. I wasn't changing this properly. So now let's change it to 3 and send again. Now it says employee updated successfully. And now let's go back to employees and click on send. Now we can see that the last one changed to Tom Anderson, software developer. We can also test it through the browser for the get. So you can see that the last one is updated to Tom Anderson. All right, that's everything I want to show you in this video for HTTP put. Again, our main focus is, first of all, the purpose of HTTP put is to update existing resources on the server. Secondly, we are using simple routing, okay? A combination between the method and the location. Okay, that's everything I want to show you in this video. If you have any questions, please let me know. If not, I will see you in the next one. In this video, let's learn about query string. We have covered the HTTP get, post, and HTTP put, these verbs. The next one naturally goes to the HTTP delete. But for delete to work, we don't have enough information if we just base on URL and the HTTP method. So if we say delete, we perform deletion based on this location, then the natural question comes is, which employee do you want to delete? So that information can come from different resources. It can come from the URL, it can come from the HTTP header, it can even come from the body. But HTTP query string is an option to pass this type of information. So what is a query string? A query string is actually part of the URL itself, and it starts with a question mark, and then it's a key value pair again. Right? So the key value pair is separated by equal sign. So for example, I say ID equals 1, right? So this provides us with the information about the employee. So if I say I want to perform the delete action based on this particular URL, then we know exactly which employee we're trying to perform the deletion, right? So we're hitting this employee's endpoint, but we're providing this ID. So we know exactly that employee ID number 1 needs to be deleted. Same thing with a get method. For example, if we want to get a particular employee instead of all of the employees, we can use the same URL, but this time the HTTP method is different. Anyways, the way to provide a query string key value pair is to start with a question mark after the regular URL is provided. And then you provide the variable name, the equal sign, and the value. If you want to provide multiple key value pair here, for example, ID equals 1, and at the same time, name equals Frank, you can use a ampersand here. Ampersand, and then another key value pair separated by, okay, once we have this URL coming to the Castro server, this URL is again converted by the Castro server to the HttpContext object. It will specifically stay inside the HTTP request object in the context. So let's take a look. Over here, for now, I temporarily comment out all of this code that we used, or let me actually delete them for now. And then let's use the context. So context.request. And then you see that we actually have a query object here, right? We have this query object here, which is a query collection. It is actually a dictionary, right? So you can treat it as a dictionary. And we also have a query string here. So what we can do here is, first of all, we can use await context.response.write async, and we can write out the query string object like this. It doesn't like it, so we can convert it to string. Now, if we do this and run the application, we'll see what happens. Okay, so I have this, and if I want to say, I want to go to employees, and the ID is number 2, and I hit enter, you can see that the raw query string is already provided to us as ID equals to 2. And then if I provide name equals to Frank, then have this raw query string just like that. Okay, so the raw query string is not very useful to us. We want to see the separate key and pair values. So to do that, we can use the query dictionary here. It has contains keys. Okay? So if we look at the keys, then we can use a for each loop. We can say key in keys. And now we can output the key value pair here by saying key is, and then we can provide the value by saying context.request.query. We provide the key here. Then we can have a character return just like that. And if we run it, we can see the key value pair that is separated and display on each line. All right. Let's try that. Employees. So here we don't have anything. If I just say employees without the query string, now, if I say ID2, then ID2 is output to the page. And if I add an ampersand and name equals Frank, then I have name equals Frank over here. If I add another one, I say position equals manager, display right here. Okay, so now we have an additional way, which is use part of the URL, pass the information to the server, so that the server can have additional information to process. And this particular way of passing information to the server is called query string. One thing that you have to be very careful about is that when you use query string to pass information from the client to the server, do not pass any sensitive information, because the query string is part of the URL, which will be kept in the browser history. So anyone who has access to the computer, they would be able to see the URL and see your sensitive information. So if you decide to use the query string to pass information from the client to the server, be careful not to include any sensitive information in the query string. And that's everything I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one. In this video, we're going to learn about the HTTP delete method. First of all, the purpose of the HTTP delete method is to delete existing resources on the server. Now, if we look at the simple routing method, right, the routing mechanism that we used in the previous HTTP verbs, we're combining the verb itself, which is also called the method itself, along with the location, which is the URL. We combine them together. The simple routing doesn't work in this case because we don't know exactly which employee we want to delete, unless you want to delete everything. Usually this is not a requirement. We don't want to delete everything. Right? If we want to delete everything, we go to the database, we delete from there as a manual process. From the application point of view, we want to specify which employee to delete. That's why we learned the query string in the previous video. So here, instead of just use the URL like this, we can add a query string. We can say we want to delete employee number 3. All right, so let's jump into Visual Studio and let's use this type of routing to locate our endpoint handling logic. Let's go back, scroll up to here, and we can copy this and this, paste it over here, complete curly braces. It's back to its position. Now, the method we're looking for is delete, right? So if it's HTTP delete, and if we are targeting this employee's location here, then what we can do is we can look for the query string. So if context.request.query, and we have this contains keys method, right? So if contains the ID as the key, then we can continue. Otherwise, we're not going to delete anything. We're not going to do anything. So if it contains the ID, then first of all, we want to get the ID. So we're going to say var ID equals context.request.query. So we can get this ID, and this is going to be a string value. Now we need to parse this string value to an integer. So we're going to say int, we can use try parse, and we're going to parse the ID, and we're going to let it come out into an integer variable. And we're going to declare that as employee ID, or you can call it anything else. And this has to be wrapped up with a if statement like this. And over here, we can use the employee ID. So we're going to say employee repository, and we're going to delete employee, and we're going to provide the employee ID right here. Although we don't have the method yet, I'm going to create it later. This is going to return a result just like update. So I'm going to have result like this, and then we can test the result. So if the result is successful, then we can scroll up over here and we can copy this and paste it over here. So if it's successful, then we can say employee is deleted successfully. Otherwise, we can say something else. We can say employee is not found. Again, we're going to handle the different status code later, right? Then we can scroll down and copy this, okay? Scroll down to the repository class over here, and we're going to implement this static method for this. It's going to be a boolean and a returning boolean, and the parameter here is going to be an integer. We pass in the ID just like this, and we're going to get the employee first. So employees.first or default, we can say x goes to x.id equals ID, and if employee is not now, this is when we can remove it from the collection. So employees.remove, and we can just remove the employee object like this. And over here, we're going to return true. Otherwise, I'm going to return false. And this implements our endpoint handling logic right here. And let's give it a try. So run the application. All right, application is running. Let's bring this over here and let's hit the get endpoint first. And we have these 3 different employees in our data store by default. And let's go to Postman over here. We need to add another one, and I'm going to add another request, and this is going to be called delete employee. I'm going to change this to delete, and we are going to hit this same endpoint, the same URL. All right, now we're going to pass in the ID from the query string over here. Let's say we're going to delete the middle one, which is ID number 2. And you can see that Postman is able to parse this into a parameter list right here on the screen. So you can add it here, or you can add it here. You can even disable this like this and add it back just like that. And let's save it first and try to send it to the application. All right. It says employee is deleted successfully. Let's try another one. Let's try to delete number 20, which doesn't exist. And then we send that, we get employee not found. So you can see that the endpoint handling logic is working perfectly. And let's try to run this get endpoint page again. Refresh that, and you can see that the second one is deleted. Go to this get over here. You can see that this is from the previous testing. The second one is Jane Smith. And if I send it again, you can see Jane Smith is gone, right? We only have 1 and 2. This used to be the third one. Now it becomes the second one. So you can see that the deletion works. And what we really learned from this video is that we have this delete method. It is used for deleting purpose, right? Deleting resources on the server. And we learned to use query string to actually identify the particular resource to be deleted. And that's everything I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one. In this video, let's learn about HTTP request headers. We have talked about HTTP request headers in one of the first videos, but in this video, let's talk more about it because this is actually a very important topic. Now, what is the purpose of a HTTP request header? Well, HTTP request header provides additional information to the servers in order to help the server to respond to the HTTP request. Now, you may ask why we cannot just provide all the information we need in the URL, because it's part of the information that has to be provided to the server anyways, right? Just add all of that. Since we learned the query string, we just provide all of the information information through the query string. Why we cannot do that? For several reasons. First of all, the URL itself has a length limitation. Right? If you want to provide all the information to it, it's not possible. Although the length limitation is quite long, I don't remember off the top of my head, 2000 characters, but there's a length limitation, so keep that in mind. Secondly, it's actually let's actually run the application and let's try to remember what type of headers we generated by the browser. Okay, so let's just run it and let's come over here and take a look at this developer tool. So F12, open up developer tool and then refresh it. Let's come over here and highlight the request that we want to examine. Okay. And in the headers tab over here, scroll down to request headers. And if we check this, we can see the raw headers like this. If we don't check it, we can see it in this format. So this format seems to be better. You can see that by default, it has so many different headers that is generated by the browser. Same with Postman. So go to Postman over here, go to a simple GET request. You can see we have headers and we have 7 different headers. Click on this. This is by default. By default, you don't see those headers because those headers is actually automatically generated. It says auto-generated headers. Okay, so all of these are actually sent to the server. Although you didn't specify that in Postman, it's automatically generated. From the browser, it's even more than that. Okay, we don't want to have all of this in the URL. The URL should be developer or the user specified, not automatically generated. We don't want to pollute the URL. Now, another more important reason why we don't want to put everything into the URL is because of safety concern. You know, when you navigate through the URL, whether it's going over here or going over here, you can see that the browser actually keeps the history of what URL I have specified before. So for example, if you want to provide some kind of authentication information or authorization information, when you put it in the URL, that means everybody who can access the computer and access this particular browser instance, they will be able to see your sensitive information through the URL. So for safety concern, we don't want to put everything in the URL. And one of the other places we can put is, of course, you can put it in the body, which is the same thing in terms of security, but header is usually what we use for authentication and authorization purpose. And in this video, let's actually do a very simple authentication. Now we have this delete logic over here. If the ID is in the query string and we are successfully being able to convert that into an integer, then we trigger the deletion method. But not everyone's supposed to be able to delete. So let's add a little bit of the authorization logic over here. So what the logic is, let's come up with a scenario. So when a delete request comes to the server, it has to contain a authorization header. Right? HTTP request header that is called authorization, and the authorization header's value has to be a hard-coded value. Let's just hard-code it for now. Right? We're learning it. We don't want to come up with a very complicated case, so let's just hard-code it. Okay, so let's go to our Postman over here and let's come up with that scenario over here. Okay, let's go to delete request over here and let's click on headers. In the headers, we can say authorization. So this is the authorization header. Click on that and the value. Let's say we're just going to hardcode Frank by name. So when authorization header contains a specific string, that's when you allow the user to execute the deletion. Okay, so let's jump back to implement that logic. So we're going to access the header by saying context.request.headers. See, this is also a dictionary. And here we can use square bracket and I'm going to say authorization. Hover the mouse over that. This also gives us a string value. And we can compare that with the hard-coded string. So if headers equal Frank, then we are going to execute this. Otherwise, we are going to return something. So we're going to copy this and we're going to say you are not authorized. You are not authorized. Let's just say this. You are not authorized to delete. Okay. And let's run. All right. It is running. And let's go to Postman over here. And first of all, let's use a different value. Let's try that. Okay. Try to delete employee number one, which we know that exists, right? Because for now, actually, let's go to get employees and run it again. And we see 3 different ones because we restarted the application, right? So we know that we have 3 different employees by default. This one is 1, this is 2, and this is 3. So let's go to the employee and let's try to delete the first one. And we're providing Frank1111, like a random value, and click on send button. Now you see that the result says you are not authorized to delete. Although it says 200 okay here, we're going to deal with the status code later. It's not supposed to be okay, right? Because the person's not authorized. Now, if we change it to the correct value, then click on send button, then it says employee is deleted successfully. This 200 okay is fine. Now, let's go to get employees, click on send, and you can see the first one is indeed deleted, okay? So this is why you want to use the header, right? We have the authorization header and we use the header. It is not in the URL. It's not polluting the URL, first of all. Secondly, it is for safety concern. We don't want to put our super secret value in the URL for everybody to see. And that's everything I want to talk about in this video. If any questions, please let me know. If not, I will see you in the next one. When we were learning about the HTTP methods, we have been creating a simple routing logic in the code. In this video, let's refactor our code. The reason why we need to refactor our code is because our logic, the routing logic, is based on the combination between method and the location, right? So if we look at the syntax here, we were using the method first and then the URL, which represents the location. But in actual routing in ASP.NET Core, the logic is reversed. It first tries to see which location the request goes to, and then it tries to see which method should be performed against that location. So it's reversed. So let's take a look at a diagram here. So we have a browser and we have a server. When a request goes from the browser to the server, it first needs to be routed to the endpoint handler, right? We talk about that sequence. So let's say we have this routing mechanism. It needs to identify the request to see it goes to this particular location or it goes to the other location. But this doesn't determine the endpoint handler. It needs to use the verbs. Okay, so if the request should go to the /employees location, then we look at the verb, or we can call it method, to determine which endpoint handling logic needs to be hit. Or we can say which endpoint handler needs to be hit. Same thing with the /positions. So we need to route the request to the /positions location. Then we look at the verb to see which endpoint handler needs to be triggered for this particular location. Okay, let's try to implement this logic by refactoring our existing code. Let's jump back into Visual Studio. Scroll up, and we see that if we collapse this, you can see that we are using our method at the first level. This is not so good because, as I mentioned over here, you could have different locations. Right? You can have employees, you can have positions, you can have departments, you can have many different locations. And to use location on the first level more sense than using. So let's refactor the code. Let's copy this and extract that outside here. So far, we're only dealing with 2 locations. The first one is the root, and the second one is the employees. We didn't care about the root. When the request comes to the root, we didn't need to take care of whether it's a get, post, or put and delete. We have been distinguishing that under the employees location. So we can keep the code over here. But for this, we will need to take care of checking the method. So let's copy this and paste it directly in here. Okay. So if we're hitting employees, and if it's a get method, then what are we going to do? We're going to execute this logic, right? So we can delete this part. And we need to delete this because we're already on the employee's location. So let's remove this, and delete this line, highlight it, and then Control KF to format it. Same thing with the post. Let's delete this, delete that, and let's Control KF to format it. The put, same thing. Let's refactor the code properly. Last but not least, the delete one, and then let's delete this. So from this refactored code, if we collapse everything, so we can see how many locations we have in our code. We have the root to take care of, we have the employees to take care of. So it's a better organization of our code. We know what type of business logic we're dealing with, right? We're dealing with root, we're dealing with employees. Departments, we know we're dealing with departments. If we have positions, we know we're dealing with positions. So this is better for writing the rest of the code. And let's give it a test to make sure everything still works. Let's run the code, and it is running. We're hitting our root, no problems with that. And getting our default employees. And let's go over to our postman over here. The get endpoints, when we run it, we have the default one. At the add one, we can add number 4, Tom Anderson, and we added that. Let's make sure to execute the get endpoint again, making sure that Tom Anderson is added. Update employee, update third one. So let's say we give Tom Anderson a raise. So we're gonna have 150K for Tom Anderson. Click on send, and let's try to execute the get endpoint again. Tom Anderson number 3. We updated number 3 to Tom Anderson. So at least we see the changes, right? And last but not least, we try to delete number 4. And let's click on the send button. So employees deleted. Let's go back to get employees. Click on send, and we have all of 3 employees. We know that we have updated the third one to Tom Anderson. Let's refresh. We have Tom Anderson updated. All right. So that's our refactored code based on the location first, and then we try to distinguish the HTTP verbs, or you can call it the HTTP methods, at the second level. That's everything I want to talk about in this video. If you have any questions, please let me know. If not, I will see you in the next one. In this video, let's learn about HTTP response syntax. We have been dealing with HTTP requests so far, so let's move on to HTTP response. So first of all, we need to know the purpose of HTTP response. And for that, let's take a look at this diagram first. We talk about the HTTP request, and the purpose of that is for the browser, which is the client, to provide requirement, the web server, requirement about what the client wants. Right? What the client wants. Now, the HTTP response is the opposite. The purpose of HTTP response is for the server to provide information to the client in order to help the client to use, right? Because the server serves data, information to the browser. Now the browser needs to take that response and render that somehow in the browser. So how? That's the question. Therefore, in the response, there are not only the content that needs to be rendered in the browser, but also some extra information that provided to the browser to help the browser to render that. So first of all, let's understand the syntax of the response. Let's go to this HTTP request syntax and let's copy this, because the syntax is actually very similar between the two. So let's copy that and paste it over here. This particular one currently is for HTTP request, and for HTTP response, it's very simple. Remember, there's 3 different sections in the HTTP request. Right? The first one is the request line, and then starting from the second line is the headers, and we have 1 header for each line. After a character return, we have the second one, and then we have more, then another character return, and then a header key and header value, just like that. So similarly, we have our response line in the first line, and instead of method, we're having different things. So we have the version first. And then after that, we have the status code. And after the status code, I have to mention that there is a space right here. From here to here, there's space between the version and status code. And there's another space here. And then we have our status description. Okay, so it looks like this. We have our version first, then we have our status code, and after another space, we have our status description. And after that, it's exactly the same as HTTP request. We have a bunch of headers, 0 or many. And after the headers, we have a empty line here. And after that, we have our body. The body contains the content that needs to be rendered in the browser in the case of regular web application, right? And then the headers describes the content in order to help the browser to render the content in the browser properly, right? So in that case, we don't have the accept headers, accept language in the headers anymore. We have different things. For example, we have a date header, a common header, right? And let's say today is October 7th, 2024. And there's going to be time as well, right? And after the day, we have server. So in this case, we're using Castro server. And then after that, we have another key value pair. It could be, let's say, content type. And let's say in this case, it's text/HTML. And then we could have content length that describes how many characters are in the body for the content. Let's say 150, right? So on and so forth. We could have many headers for the server to describe the body. And then we have the bodies, right? And let's say hello world is what is written in the body. So this is the example of the HTTP response. So again, 3 different parts. We have the first one is the response line right here. After that, we have 0 or many different headers. Again, it's key value pair separated by colon. After that, we have our third part, which is the body. The body has an empty line right over here that separates the body from the headers. All right, so let's actually have our web application running right here, and let's observe the developer tool just like what we did for the request. So F12, bring up the developer tool. Now we have to refresh this in order to see it. We refresh that and click on the request that we want to see. Now, again, like I mentioned, this is a little bit confusing. We have our headers over here, and it contains both the response headers as well as the request headers. Let's collapse everything and focus our energy on the response headers. Open it up and check this. Now we see the raw format. Of course, it doesn't contain a body yet. So we can observe the first line, right? This is the response line. It contains a version and then a space, status code, which is HTTP 200. We're going to talk about the status code later. Another space right here, and then the status description. So that means that HTTP 200 means, okay, everything is successful. We have our actual date and time. We have our server. So this is a header, key value pair, another header, key value pair, another header, value pair. Now let's go to our response tab. So this response is not a full response, but it's only the body part. Right? It contains the body of, and you can see that this corresponds to what is being rendered in the browser window. So you can see these are the commonly used headers. We have date, server, encoding, right? It all helps the browser to render. And some other headers that are very common are content type, content length, set cookie. Some of them we're gonna cover in the next video when we talk about the HTTP context object, which contains the response object within it. In this video, this is everything about. Just remember the basic syntax of our HTTP response, and the purpose of HTTP response is to help the browser to render. Okay, that's everything I want to talk about in this video. If you have any questions, please let me know. If not, I will see you in the next one. In this video, we're going to learn about the HTTP response in the HTTP context object. In the previous video, we learned the basic syntax of the HTTP response protocol. The HTTP response. It has 3 different parts. Let's review. It has the request line that contains the version, status code, and status description. And then same as the HTTP request, we have several lines of response headers. It may or may not. It could be 0, right? So from 0 to many different headers. And then after a space, we have our third part, which is the body. So in this video, let's jump into Visual Studio and observe all of these different parts in the HttpContext object. So let's go to our Visual Studio here and let's comment out the code that we had for our previous lessons. And let's focus our energy on the context object.response. And first of all, we see the status code right here. And you can see that the type of that is an integer. And then you can see we have headers. And this is similar to the request headers. It's a dictionary. You can access it. And you can see the body. The body, however, is a stream, right? We mentioned that previously. And in order to write to it, you can simply just say response.write like this. You cannot directly put stuff into it because it's a stream. Now there's very common response headers that you can directly access, for example, content type, right? You can specify the different content types, depends on the format of the body. All right, so let's delete this and let's uncomment the existing code, and we're gonna use the HTTP response in our existing code. First of all, some of this code needs to actually return status code. For example, post here. When post is success, right? When we successfully post it back as a response, when we successfully process the HTTP post request, the response that goes back, it should be in a different status code other than HTTP 200, because HTTP 200 is okay, and that is usually for the GET request. Okay, so if we don't specify anything, this is gonna return as HTTP 200 okay. We can specifically specify that by saying context.response.status code, and we can specify it. But if we don't, then that's by default. For post, when we successfully add resource to the server, instead of using 200, we should say 201, and this represents that resource is successfully created. And when we successfully modify something, usually the status code should be 204, which is no content. Right? And we can do that right here. Instead of doing it here, we should actually do it here like this. We specify that and then just return. And we're going to talk about different status code in the next video. Here, let's just play with it for a little bit. We have 201 for the post. We have 204 for the put. And let's run this and let's observe the result. All right, we have our application running right over here. And if we go to our postman here and go to get employees, click on send, we get our default 3 different employees and we have 200. So this time we specifically specified the status code as 200 and we got it. All right, so let's try the HTTP post here. Let's add the third one, Tom Anderson, and click on send. Now we can see that we got 201 and the status description is created. It's created. So this is the response. So we can observe the response in Postman here at the bottom part, right? The bottom half of the screen. You can actually move this up and down, right? And you can observe the cookies. We didn't set the cookies, right? You can observe the headers, and content length is 0. The server is Castro. Date is this. So body has nothing in it. We didn't write anything here, and therefore there's nothing in it. But we can see the status code is 201, right? And we can do the same thing with update employee here. We're gonna update the third employee. Well, we're gonna call it with a different name and give it a different salary here. And let's click on that. Now we still get 200, and that's a little bit weird here. So let's go back to our code over here, and I see the problem. So when we write to the response. Remember, this is a stream. So when we write it, it means that the response is already going back to the client from the server. So therefore, we have to move this line up. We need to specify the status code first before we write to the response. And we run this again, we should be able to see information displays correctly here. So again, we're going to update the third employee to Tom Anderson, and we have the correct status code coming back. 204, no content. So that's how to access the status code from the response object here in the HTTP context. Now we can think about writing HTML in the browser, because in the past we have been writing pure text. So let's take a look at this root URL handling logic here. We write with character returns. So this is incorrect, or I mean not incorrect, but it's not proper way to write to the browser. The browser displays HTML naturally, so we should specify HTML instead of just pure text. So then how do we do that? So before we write any response, we need to specify the content type in the header. So over here, we can say context.response.headers, and then we can say content type. And we can specify that as text / okay. So if we do this, we want these texts to display in a different way, right? So instead of use character return, let's remove the character returns. Let's use a line break here in HTML, right? In this case, the headers should be bolded. We can use HTML to do that. And then the key, we can also bold it with HTML. And the last character return, we can use BR, that, okay? Maybe we can do even something differently here. So we can use an ordered list. Okay, so here we're gonna write UL. We don't need the $sign in this case. So this is an order list. And after we write the key value pair here, we can have the closing UL tag here. And then over here, we can specify the item, li element. At the very end here, instead of using line break, we can use the closing li element. Okay, so this changed the display dramatically. Instead of writing pure text, we are actually writing proper HTML. So let's run the application and observe the result. All right, so we have our result right here. You can see that everything displays properly. We have headers highlighted. We have the key highlighted, right? And we have all of the headers displays as an ordered list. So this looks much better than the pure text. Now, if we go to F12 to see the developer tool here, and let's refresh the browser and highlight this. Now let's take a look at the headers. Okay, response headers. We have content type right here. Specify this ourselves in the code. Of course, we can go ahead and change all of these to HTML instead of pure text. But I don't want to waste time in the video. I'm going to do that offline, and in the source code that I attached in this video, you are going to see the changes. Okay, that's everything I want to show you in this video. If you have any questions, please let me know. If not, I will see you in the next one. In this video, let's learn about HTTP response status code. There are different status code. Specifically, we have 5 different categories. We have 100s, 200, 300, 400, 500. 100s is not very common, but it's for informational response. Okay? So 100 represents informational response. 200s represents successful responses. 300s represents redirectional responses. But 400s represent client, if something is wrong from the client side. 500s represents server errors. So something is wrong from the server side. So let's take a look at 200s. We have actually covered 200 OK, and in the code, we know that we're responding with 200 OK from get if everything is OK. So here in post, we're responding with 201, which is created, 201 created. So it says the request has been fulfilled and new resource has been created on the server. So 201. And then put, we are responding with 204 is if everything is successful. And the description here says 204 no content. The server successfully processed request, but there's nothing to return, right? Although we are here returning something to the client just for demonstration purpose. And for delete, usually if everything is successful, we are returning 200. Okay, so because in this case, if we don't do anything, it returns 200, so we don't do anything. And then 400s, it's client error. So let's cover 400 first. And then we're going to go back and talk about 300s. So 400, the most famous one is for not found. So in our case, if we run our application, let's run it. You can see that we have this. And if we go to any URL, let's say, we haven't used this URL before, it just returns a blank page because we are using the run middleware. We're processing every single request. So this is not actually correct way to do it. Let's collapse everything. And what I want to do here is at the very end here of the if statement, if it doesn't fall into any of the previous branches, then over here, I want to give it 404, which stands for not found. So the resource on the server is not found, and this is the accurate status code. Now, if I run it and then I go to /000, now you can see the error page properly. It says this localhost page cannot be found. And other client errors, 400 bad request. So the server could not understand the request due to invalid syntax. For example, if we are processing the post method here and we can't actually deserialize it, or if after we deserialize this employee is null, then let's say that if the employee here is null, what are we going to do? We're going to say 400 because information provided by the client is invalid. And in this case, we can write some information if we want. If not, we can just return back. Okay, let's run this and let's go to add employee here. Let's say that if I remove this information and just click on send, then we got an exception. It says it doesn't contain any tokens. So we need to do a try catch. But before that, let's add a empty JSON here and click on send. It says employee added successfully. So apparently this check isn't working very well. We can add and if employee.id, at least we need to have an ID, right? So if employee.id is not end, but or if employee.id is less than 0, then we can return status code 400. So just some condition in order to see the status code. So again, go back over here and click on the send button. Now we see the bad request coming back. And of course, over here, we can do a try catch and move this, a curly braces, and then we can catch an exception. Inside here, we can again return a 400 response here. If we want, we can write some information back. Looks like we need to move this also into the try catch over here. And if we want to write information about exception over here like this, and let's run it again. Now let's go to Postman. Let's remove this. So this is going to trigger the same exception we have seen before and click on send button. Now we got the 400 bad request and we got all of the stack from the exception object out, and we can see the information in the exception. That's 400. And then we have 401 unauthorized is right over here in the delete one, right? If we don't have this condition satisfied, we just spitting this out. But by spitting this out, we do see this error message in the page, but the status code is still 200. So that's incorrect. So for example, if I go over here and I send this request, and you can see that it says employee is deleted successfully. But if I change this from Frank to Frank1, Now I'm going to change the ID to number 2 and click on send again. It says you are not authorized to delete, but the status code is incorrect. It is 200 OK. So what is supposed to happen is that we need to change status code. Status code to 401 before we write this response. And of course, we take the opportunity to fix this. So status code of not found should be 404. And this is 200, so we don't have to do anything. Okay, let's run the application again. Let's go to Postman and go to get. Let's make sure that we have 3 different employees over here. So John, Jane, and Sam. And let's go to delete. Still, we're specifying the wrong authorization key. And let's click on the send button. Now we see the same message, but we got the correct status code 401. So that's our 401 unauthorized. So we covered all of these 3 different things. Now let's talk about the 500. 500 means that the data that comes from the client, but something is wrong with the server-side code. For example, there is a bug in our system. It should trigger 500s. For example, by default, if there's any exception that is thrown in our code here, right here, it's going to cause a HTTP 500 error. In order to trigger that, let's just throw an exception no matter what. So let's say test exception. Let's bypass all of the code and let's click on run. Okay, so this is supposed to be triggered if we go to the employees location, right? Employees URL here. So let's go to employees. And you can see this proper error handling page, right? And if we go to the Postman here, get employees and click on send, we see 500 internal error. So the status code of 500 is automatically set if there is an exception, and it spits out the exception for you. And from here, ASP.NET Core has a default error page stack, and you can see that on line 28 we have this throw new exception, which is causing everything to crash. And we can go to the different ones to see what is the query string, what are the cookies, what are the headers. So this is the headers of the HTTP request and the routing, and this provides enough information for developers to troubleshoot. Of course, in production environment, we don't want to have this type of error page show up. We can customize that. We can talk about that later. So by default, if we don't do anything, ASP.NET Core already covers this exception handling thing. And why is that? How come ASP.NET Core can handle the exception and throw the HTTP 500? That's because here, although we only have this many lines of code, right? So everything ends here. This is our custom class. Everything ends here in our program.cs. So although everything is very simple, it looks like we only have one middleware. But as I mentioned before, this middleware pipeline is actually wrapped by the exception handling. So although we didn't specify the exception handling middleware, but it is right there in the pipeline. And we're going to talk about that when we talk about the middleware pipeline in the next section. That covers our 500s. And let's now look at the 300s. So 300s is redirectional message, redirectional status code. And let's take a look at some examples of, for example, 301 moved permanently. So the drawing software that I'm using right now is from a certain URL. So let's go to browser and let's try to use draw.io. So this draw.io is the URL that I always remember. But if I hit enter, notice that it's redirected to app.diagrams.net. And if I go to the developer tool by pressing on 12 and try to use the network tab to capture the traffic, refresh button. Now if I go up, so I cannot do this, keep the network tab and then type in the URL, hit enter. Now scroll all the way up here and you can see the first one is draw.io and the status code is 301. So click on this, go to headers and go to response header. Now look at this response header location. It points to app.diagrams.net. And then let's close this, go to the second one. The request URL is from app.diagrams.net. So this is the same as the location header. So what is actually happening right now? Well, draw.io is permanently discarded. And whenever you go to this draw.io, it moves you to app.diagrams.net. So in order to do this automatic redirect, when you go to draw.io, the server returns a 301 status code, and at the same time, it populates the location header. And when the browser receives this response, it sees, okay, so the status is 301, then it goes to the location header, finds the new URL, and automatically sends the second request that goes to the new URL. When this new URL is sent to the server, now it returns 200, okay. So this is moved permanently. So in the same way, 302 represents the resource is temporarily relocated at a different URL. So for example, if I go to this code here and go over here, so else if, so I'm going to test this, right, the path. And if this equals to /red, so redirection, then I'm going to say context.response.redirect. And I'm going to redirect to employees. So this will trigger 302. All right, so let's give it a try. Let's bring up our developer tool and let's refresh, not refreshing, but enter the path, the URL. So redirection, now it goes back to employees. And if we look at our network tab over here, the first one, redirection, the status code is 302. And let's go in here and look at our response headers. Location points to /employees. So in the same way, when the browser receives 302, it looks at the location header and then generates another request to the server. And that request goes to employees, the second one. So that's our 302 found. And 304 not modified means that there's some resources is cached on the browser. So it's not modified yet. Therefore, the browser is not go to the server to get the resource again. It just uses the cached copy. Okay, that covers all of our response status code. If you have any questions, please let me know. If not, I will see you in the next one. All right, we have our first assignment, which is to display a particular employee's information. So far in our application that is created with this run method, we are able to respond to the get method. And for this get method, we just simply get all of the employees and list them out in an unordered list. So what if we have another requirement, which is to retrieve the information for a particular employee? How do we know which employee? We can supply that as a query string and then retrieve the information from our in-memory data store and display that in our web page as HTML. So that's our first assignment. I hope you can go back and work on that yourself. The tip is that you can use this if statement here and apply another if statement to try to see whether we have the query string supplied or not and respond to that result accordingly. Currently, this is our endpoint handling logic for get all of the employees and display all of the employees' information. We will have to have another endpoint handling logic that is separated by the if-else statement. And that is for displaying the particular employee's information. So try to go back and work on that yourself. You can determine how much information should be displayed for that particular employee. And you can determine in what format you want to display that employee's information. Okay, I will see you in the next video where I'm going to show my solution to this assignment. See you in the next one. In this video, let's work on this assignment. We're trying to supply a employee ID in the URL as part of the query string, and then we grab that and we make decision based on whether we have a employee ID or not. Let's go ahead and work on that. Jump back to Visual Studio here. And first of all, we need to get the employee ID from the query string. We already have similar logic in the delete method over here. So therefore, what we can do is we can copy and paste this logic under the get method. So if we have a employee ID over here, that means we're getting a particular employee information, right? Otherwise, we're getting all of the employees. So let's move this logic inside the curly braces over here, and let's implement getting a particular employee. Since we have the comment over here, we add another comment here to distinguish them. So get all of the employees full. And in order to get a particular employee, again, we're going to use the employees repository, and we're going to say get employee by ID, specify the employee ID. Now we don't have the method, as I mentioned before. I usually like to use this type of coding habit. It's almost like test-driven development. You create something and you see the red squiggly line, and then you try to get rid of that red squiggly line. I need to implement this get employee ID because I know that red squiggly line here. So scroll down and go to employee repository over here. At the very top, this is where we implement our get methods. We can have our public static method, and we're going to return get employee by ID and provide the ID right here, and then try to return by using link. So employees first or default, or x goes to x.id equals ID. Now this could return something that doesn't exist. Therefore here we can add a question mark to get rid of the green squiggly line. Now we have our method implemented. We scroll up to the top, and we have our get employee by ID, and we can say now this employee again could be null. So if employee is not null, we don't have to use this. We can say is not null. I like to use this, which is clearer than the explanation mark followed by a equal sign. So if employee is not null, then we are going to work on it, right? We're going to work on displaying it. Otherwise, we are going to display a message. So we have something similar here, right? We can copy this, paste it here. So what's the status code should be? It should be 404, right? Because 404 is not found. I have something wrong with my keyboard, so let me fix that. 404, not found, and we can say employee not found. If we found employee, then we can display the employee information. And the question is, in what format should we display it? We can display it in the HTML table, we can display it in an order list. So for simplicity, I'm just going to display it in a regular HTML with line breaks. So I'm going to say write async, and then I'm going to use string interpolation. Now here I'm going to say name is employee.name. We can add a line break like this. Then we copy and paste it twice. And for the second one, we're going to show the position. And for the third one, we're going to show the salary. I'm going to change the label here. So position, that's it. Here we don't have to do anything with the status code, because that way it returns status code 200, which means everything is okay. All right, so that's the implementation. So here we have two endpoint handling logic here. One is this, the other one is. So the code is getting a lot more than we want to have to manage in one file. So it's best to break it down into classes in order to organize the code. And we are going to have a lecture in the future about organizing logic. For now, we are okay with this format. Let's try to run the application to see whether we can get a particular employee information based on the ID. All right, so let's go to /employees. This is gonna give us all of the employees. And let's try to get the first one, which is ID number 1. ID number 1 is John Doe. John Doe is an engineer. So we have name John Doe, position engineer, salary is 60,000, and we have problems with this. So we're not actually showing HTML, we're showing pure text. So before we go any further, we have to fix this problem. And in order to fix that, specify content type. That has to be text HTML. This should fix our problem. Let's run it again. Let's go to employees, ID number 2. And we have Jane Smith, positions manager, salary is And that's my implementation of this assignment. If you have any questions, please let me know. If not, I will see you in the next one. In this new section, we're going to learn about middleware pipeline. And in this first video lesson, we're going to talk about middleware pipeline theory. So let's first of all take a look at the diagram that we have used in previous lectures right here. So we have browser, and then we have our web server. The browser sends HTTP request, and the web server returns back the HTTP response. And inside the web server, we have two major components. We have the Castro server, which is used as the HTTP server. It's part of our application, but the actual application is the second part here. So the HTTP server listens to the request and translate that into a C# object, which is HttpContext object. And then the context object is then sent to the actual web application. The actual web application is fundamentally running on a middleware pipeline, which consists of many middleware components. And once this context object goes through the middleware pipeline, it comes out still as a HTTP context, but now it contains the full response. The Castro server is then forwards that HTTP response for the browser to display. Now, why do we need middleware pipeline? Let's think from the other angle. If we don't have the middleware pipeline, what it means is that we are going to have everything coupled together. All of the functionalities that a web application will need to perform has to be coupled together into one single component. So what are those functionalities? We have talked about that in the second lesson, where we have routing, authentication, authorization, model binding, model validation, and one of these endpoint handling technologies and producing results. So all of them plus your custom codes. Well, your main custom codes will be hooked inside one of this, but if you have additional logic that needs to be processed as a cross-cutting concern, then it's going to act as one of these. So all of them will be executed inside one component if we don't have an architecture to help us to process these functionalities separately. So in order to come up with a proper architecture, ASP.NET Core comes up with a middleware pipeline, right, which follows like a pipeline design pattern, where we have the HTTP context object goes through the middleware components in order to decouple those functionalities. So this is the general picture. Let's take a look in details what a middleware pipeline really is. Scroll down, I have already drawn this picture. Okay, so now this middleware pipeline becomes sideways, and it really reflects how middleware pipeline works. So this itself is a middleware pipeline. You can see that I say web application. That's because web application is based on fundamental. So the HTTP context object is fed to the first middleware in the middleware pipeline. The first middleware processes the request, and then it modifies the context object. It forwards that context to the second middleware. The second middleware processes some other functionalities, and it does the same thing. It modifies the HTTP context object. And then it goes through many other possible middlewares, dotted line, to indicate that there could be the last middleware. And after that, you can see that it doesn't actually directly forward the text object back to the Castro server from the last component. It returns back to the previous component. And then HTTP context is then forward to the previous component, all the way to the first one. We'll then forward that context object back to Castro server. Castro server will extract the HTTP response, forward that back to the browser. Now, you already know why we have this middleware pipeline pattern. A middleware pipeline consists of one or many different middleware components, which is being shown here. And each middleware component takes care of usually one single functionality. That follows the single responsibility principle, so that all of the functionalities are decoupled with each other, and it's good for scalability and maintainability. So what you need to pay attention here is the fact that the context object here is being forwarded from one middleware to the next, and then it actually returns all the way to the browser. And how is this our next topic? So how is this implemented? This all boils down to function calls. So let's say we have function 1, right? And then passing the context object. And after that, it has its body. Let's turn this around. So the bracket here represents the body of the function, which is the body of the function 1. And then in order to trigger the next middleware component, it calls function 2 of middleware component 2. So basically, function 1 calls function 2, and then calls function 3, 4, all the way to, let's say, function X is the last one. Now, when the last function returns, it returns back to the previous function, and then all the way to function 2. Now, when function 2 returns, of course, it returns to its caller, which is function 1. So this is how the middleware pipeline works. It basically works as a series of function calls. Right? Function 1 calls function 2, calls function 3, all the way to the last function. And then when the last function returns, it returns back to the previous one, to the previous one, to the previous one, and then to the first one. And that return value is forward cast to server here. So that's how the middleware pipeline is implemented. It implements as function calls. Because it implements as function calls, you can see that these functions can be called regularly from one to the next one to the next one. But if one of them decides to say, I don't want to call the next one, right? For example, function 2 doesn't want to call function 3 anymore. Then it directly just returns back. And this behavior is called short-circuiting. And this behavior is called short-circuiting. And the reason why it's called short-circuiting is obviously without the short-circuiting, next middleware be called. And the middleware components in the entire pipeline should be triggered one by one. Here, function 2 short-circuits the entire pipeline so that it ends early. Everything returns back from function 2 to function 1 to Castro server. That's why this behavior is called short-circuiting. And the middleware here, middleware number 2, is called a short-circuiting middleware, and most of the time is actually called the terminal middleware because this one terminates forwarding of. Okay, so you have two types of middleware: regular middleware and a terminal short circuits the entire pipeline. And that's basically everything I want to cover in this video. Right? We talked about why we have the middleware pipeline, because without it, everything will be coupled together. With it, we can effectively separate the functionality and decouple them. And each middleware component performs its own responsibility, and the entire architecture follows the single responsibility principle. And how the middleware pipeline is implemented as function calls. So one function call, another one call, another one, and then when it returns, it's back to the previous one, all the way to the first one. Last but not least, we have a short-circuiting behavior here. So one of these functions, which means one of the middleware, can decide to short-circuit everything, returns from that middleware. And we call that middleware the terminal middleware. And that's everything I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one. There are many methods to help us to create middleware components. In this video, let's learn to use the app.Use method to create middleware components. With the app.Use method, we can create a regular middleware component or a terminal middleware component. Let's jump into Visual Studio and start creating a web application with middleware pipeline. We're going to create a new project, and we're going to select the ASP.NET Core empty project template. Click on Next. And over here, we're going to call it Learn Middleware Pipeline. And here, we're going to just call it Web App. Click on Next. We're going to uncheck Configure for HTTPS. And we're going to continue selecting .NET 11 Preview. Again, by the time you're watching this video, .NET 11 might have already been launched. You can just select .NET 11. Now click on the Create button. Let's go to Solution. Now let's go to program.cs. And we're familiar with this 4 lines of code. So in order to create a middleware, we're going to use line number 4. Okay, and we're going to say app.Use. We have used app.Run before. App.Run, we are going to talk about app.Run later. For this video, we're going to use app.Use. This app.Use also takes a delegate. But as you can see, it takes a delegate with 2 different parameters. The first one is the context object, the HTTP context. And the next one is actually the delegate that can help us to trigger the next middleware. So it goes like this. If we hover the mouse over the first one, you can see the type of the first one is HTTP context. And we hover mouse over the next parameter, it's of the type request delegate. Now, of course, this way of creating the Lambda expression, we omitted the type. If you want to add it, add a type, you can add it right here, just like this. So this app.use method is helping us to create our first middleware. So inside this app.use, we're creating our logic inside the first middleware. And for demonstration purpose, I'm going to just say context.response.write. So you're familiar with this. And we are going to say middleware 1. So middleware number 1. And this is before, right? And then again, this is write async, right? So in order to call it with the await keyword so that we can continue after the write async properly, we have to use the async keyword, and then we can use await. So this way, the code after this is a continuation of the async method here. Otherwise, without the await keyword, this is going to run asynchronously. So which means that potentially the next line could run first. So we don't want that to happen. We want this write async to happen before the next middleware is triggered. So now we can trigger the next middleware by just calling the next delegate. And next delegate requires 1 parameter, which is the context. Here you see how we forward the context object to the next middleware component. So very easy, we just forward this. And the next method is actually a async method. So therefore, we're going to use await. And now, once we finish this, what's the await keyword? The rest is again a continuation of this async method. So in order to do something here, we're going to simply write out some text again. So this is after calling. So you see that this is a middleware. The use is helping us to create this middleware. So this middleware is essentially a function that triggers the next middleware's function. Therefore, before we trigger the function, we can do some processing. And after we trigger that function, we can do some finalizing processing too, right? So, of course, before we trigger the next middleware, our processing is purely based on the context object that is passed into this middleware. After we trigger this next middleware, our processing can be based on the context object again, but this context object is most likely already modified by the rest of the middleware already. Okay, so we have some more information in the context object. Of course, I'm not showing in this code. I'm simply just writing out the async. But it's very likely that our next middleware or the next one, right? Basically, the rest of the middleware component could have already modified the context object. And therefore, our logic after triggering the middleware here can be based on those modifications in the context object. Okay, so this is our first middleware. So let's have some comments here. I'm going to say this is middleware number 1. And then we can have, let's add another 2 middleware components here. So this is middleware number 2, and this is before calling middleware number 2. And this is after calling middleware number 2. We're going to paste this again. We're going to create the third one. So middleware number 3, and this is before calling middleware number 3, and this is after calling number 3. Okay, so let's run our application in debug mode, and let's see how this works. Well, before we run this, I have to emphasize again, this code, right? Code over here, let me minimize this. These lines of code are not actually run in sequence. This is run first, this is run secondly, but these codes represents the code for creating middlewares. The lambda expression inside will not be executed until requests are received. So it's going to run, but the lambda expression will only be executed when request is received. Right here, we just basically run the Castro server as well as the web application and listen for the request to come in. As soon as the request comes in, then the request will be forwarded into the middleware components inside, one by one by one. In this particular pipeline, everything is connected, right? There's no terminal middleware. We didn't create a terminal middleware, so requests will be forwarded into the first middleware, and then the second middleware, and the third middleware, and then it returns back. So that's our expectation. Let's set a breakpoint inside here, inside our first middleware, the second middleware, and the third middleware. Also, let's set a breakpoint over here. And then let's run our application. As you can see, our first breakpoint that is triggered is app.Run. So as I mentioned, these lines of code, right, inside the lambda expression will only be triggered when we receive a request. At this moment, we haven't received a request, therefore app.Run will run first. That's why I put a breakpoint here, right? Let's actually remove the breakpoint and just run normally. Now, the first lambda expression is triggered. That's because the browser is launched and a request is sent to the server. And if I just step over this, now you can see that we're going to trigger the next middleware. And if I go here, you see, we jump into the next middleware before we go to the next line, right? We jumped into here, and then we're going to trigger this. And now we're going to trigger the next middleware, which is middleware number 3. So F10 again, and we go into middleware number 3. And well, we don't have the next middleware anymore, right? So the next middleware is not there. Therefore, nothing is going to be triggered. Here, it's going to execute a write to the response, and then this lambda expression is going to be finished. So once it's finished, guess where it's going to return? It's going to return back to the previous function where this function is actually called. Let's do F10 again. You see it comes to line number 22, and this is middleware number 2. We just finished calling this function. That's why this line is triggered now. So I'm going to do this, and then it's going to return back to middleware number 1. It's going to go to this line because we just finished calling the next function, right? And then we're going to click on this continue button. Now, of course, we're going to come in as the second request, which is the favorite icon. So we can ignore this. We don't need to worry about the favorite icon thing. Let's continue and removing all of these breakpoints, and let's observe the result. So we have all of these results all connect together, so it's not very clear. So let's actually add line breaks over here, and let's run it again without debug this time. All right, so you can see that we have first middleware before calling next, and then next is called, so therefore second middleware is executed, right? And then third middleware executed. And after the last middleware, which is the third middleware executes, there's no next middleware anymore. Therefore, you see this, right? And then it returns back to the second middleware. Therefore, you see this. And then you see this. And then after that, it returns to the Castro server. Castro server forwards that response to this browser. Therefore, you can see the output right here. So we have used the app.Use method and created 3 different middlewares, middleware 1, 2, and 3. And all 3 of them are regular middlewares, which means that one middleware will forward the context object to the next one, and then to the next one. So these are all regular middlewares. But app.Use method can actually also create terminal middleware. For example, if we want to make middleware number 2 a terminal middleware, which means that we're going to short circuit the pipeline, we can simply just comment out this line. When we comment out this line, it just means that we don't want to call the next middleware anymore, and this short circuits the pipeline. And that makes middleware number 2 a terminal middleware. Now we can do it this way by just avoid calling the next request delegate. At this point, I just want to mention that if you want to create a middleware with the use method, but if you don't want to use the type, like you can do this, right? You can do it this way. There's no compilation error. However, when you do it this way, you will have to call the next delegate. So if I just comment out this, you can see the right squiggly line. So if you want to create a terminal middleware without calling the next method, the next delegate, then you should specify the parameter type here, right? Just like this. And then you just avoid calling next delegate, and everything will return from middleware number 2, right? Middleware number 2 will return back to middleware number 1, and then everything goes back to the Castro server. All right, let's give it a try and see what happens if we do it this way. Right? We short circuit the pipeline from middleware number 2. Let's run the application without debug, and we should be able to see a different response browser. Okay, let's see. So we have middleware number 1 before calling, middleware number 2 before calling, and then because we are not forwarding that to the next middleware, which is middleware number 3, therefore we don't see middleware number 3 on the browser. We see the after calling of middleware number 2, and then it goes to middleware number 1. So this is how you can create a terminal middleware with the use method. Just avoid calling the next delegate, and just remember to specify the type of the parameter. All right, that is basically what I want to show you in this video. Just remember that the middleware is actually implemented by functions, and in these middlewares they're implemented by lambda expressions. You can definitely create a separate function and call it within here, separate function that takes these 2 type of parameters as parameters, and then you can just use it directly inside the use method. But here we're using inline lambda expression for creating a middleware. And you also observed how the middleware are calling the next one, and then it returns back, right? Just like function calls, right? So this function calls then this function, and then the second function calls the third function. And when the third function returns, it returns back to the second function. And when the second function returns, it returns back to the first function. So this is how the middlewares are connected together. And also you have seen how we create a short circuiting middleware, is also called terminal middleware, by just avoid calling the next delegate. In this video, let's learn to use app.Run to create a middleware component. We actually have used app.Run before, but let's review this. We have already learned how to use app.Use to create middleware components, and to use app.Run is different. Okay, so we use to create a regular middleware component or a short circuiting. So the use method creates both type of middleware component. However, the run method, it does not take the next request delegate. Therefore, it always creates a terminal middleware, which is short circuiting middleware. So let's take the context and let's output something from here. here we're gonna say async, and then I'm gonna say middleware number 2 processed. So we are going to run in debug mode. I'm gonna set a breakpoint here, a breakpoint here, and then a breakpoint here. Expecting that this breakpoint is not going to be hit because this is a terminal middleware, which is going to return everything from this middleware back to the previous one, and then back to Castro server. So let's run in debug mode and see whether my prediction is correct or not. Okay, browser is launched and the breakpoint is hit. Let's go step over and step over again. You can see that middleware number 2 is executing right now. And then if I step over again, it comes to line number 11, execute. All right, so you can see middleware number 1 goes to middleware number 2, and then middleware number 2 does not forward the context object to the third middleware. So directly returns back to middleware number 1 and executes the after calling logic. So that's why I'm saying that app.Run is a method that helps us to always create terminal middleware. Right? By now, you have to be very clear that the middleware that is presented early in the file is executed first, and then this one should be executed, and then this one should be executed. So all of these are only executed when a request is received. So because the order of writing this in the file matters, therefore this terminal middleware stops the entire pipeline right here. So everything that is written after this, so all of the middleware components that is written after the terminal middleware will not be executed. In this case, middleware number 3 didn't execute. And that's everything I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one. In this video, we're going to learn about using app.Map to create branches in a pipeline. So far in our pipeline, we have one direction pipeline. For example, this pipeline consists of 4 different middleware components. The request is routed from middleware number 1 all the way to middleware number 4 and then returns back. So this is one direction. But sometimes we need to create branches from the pipeline. For example, at the place where middleware number 2 is, if certain conditions is matched, then instead of going to middleware number 2, we might need to go to a different branch. For example, if I call this middleware component number 5, and then I call the next one middleware component number 6, then when certain condition is met, the request need to be routed to middleware component number 5. And number 6 is the terminal middleware, and it returns back to number 5, and then it returns back to number 1, and all the way back to Castro server. So you can see that this is a different branch. If you consider this one as a branch, then this is another branch, right? So we have 2 branches. And the feature of this type of branch is that the second branch never rejoin to the main branch, right? Because the request goes from middleware number 1 to number 5 to number 6, and then goes back to number 5, goes back to number 1, and then goes back to the Castro server. Eventually, it will be forwarded back to the browser, right? It never goes from number 6 to number 2. It doesn't rejoin the main branch here. So this is when we use app.Map. In fact, there are 2 methods to do this. In this video, we're going to talk about app.Map. So let's jump into Visual Studio, try to create such branch in the pipeline. Okay, so this is the project that we worked with in the past video. And if we were to create a branch at the place where middleware number 2 is, we can create it before middleware number 2. Because if certain condition is met, we don't want the request to be forwarded to the rest of the middleware components. We want to branch out right here. That's why you want to add it before the second middleware here. Well, here we're using run. Because we're using run, so middleware number 3 is never going to be reached. So let's change this back, first of all, to make this an entire complete middleware pipeline from number 1 to number 3. So let's change this, and we're going to add next over here. And let's copy this and paste it over here and change this to number 2, change this to number 2. So now we have a complete middleware pipeline from middleware number 1, 2 to 3, and then returns back to 2 to 1. Okay, now we want to create a branch from middleware number 2. In other words, we want to skip middleware number 2. So what do? We use app.Map. And then this one, you can see that it takes a root pattern here. And the root pattern has different way to be provided. You can basically provide just a string in the very simplest form. Right? So for example, if I go to /employees, then we want to route the request to a complete different branch, and we can create that branch right here. So you can see that this is not a request delegate anymore, right? This is an action whose parameter is application builder. So therefore, we are going to say app builder, and then we are going to create a branch of the pipeline right inside this delegate here, right? So we can say app builder dot, and then you can use the use method to create a middleware component. You can use the run method to create a middleware component. So let's try to use the use method to create a middleware component. And because we're using use, we can just copy and paste. So let me copy this and paste it right here. And of course, we're going to change this to number 5 and this one to number 5 as well. And if we were to create another component inside this new branch, I'm going to just copy and paste this, and we're going to call this number 6, and this is number 6 as well. So now you notice that we created a new branch of the pipeline, which consists of 2 different middleware components, and they will be called one after another because we use the use method to create the middleware component. And this new branch will only be reached when the URL of the HTTP request goes to /employees, or at least starts with this. Then it will be routed to this new pipeline, and the rest of the components in the main pipeline will be skipped. So let's give it a try and see whether that works as I mentioned. Let's run the application. All right, so this is the application. Because I didn't go to employees, because default is the root path, right? The root path uses the main branch. So we're gonna from 1 to 2 to 3 and then returns all the way back. So this is the main branch. What if we go to /employees? And we can see that we're going to number 1 and then immediately branched to number 5. And then it calls the next middleware component function here, so which is number 6. And then it finishes calling number 6 and goes back to number 5, goes back to number 1. And now we see everything in the browser. So you can see that we completely skipped number 3 and number 4, which are in the main branch. What if I add something, 1111, for example? I hit enter, and you can see that now it goes to the main branch. And what if I do employee / position, let's say? Now you can see that it uses the new branch of the pipeline instead of the main branch. That's why I'm saying that the map method, it matches any valid path that starts with /employees, but it doesn't include the cases where you have this type of path. As long as if you finish the path with employees and then add another section or segment like this, or you can add as many as you want. Right? It's going to still map to /employees, and then you're going to use the new branch. And that's everything I want to cover in this video. If any questions, please let me know. If not, I will see you in the next one. In this video, we're going to learn about using MapWhen to branch a pipeline. Previously, we used the app.Map to branch pipeline, and we're branching pipeline conditionally. And the only condition we can use is the path of the request. But sometimes we want to create a branch based on a more complicated, more complex condition. And to do that, we need to get more information from the HttpContext object. So therefore, we need to have a method where we can have access to the HttpContext object in order to come up with a very complicated condition for us to create a new branch. And that method is MapWhen. So I can just show it right here. So MapWhen, and then let's add a bracket here so that you can see the condition here. So we have this condition function delegate, which takes a HTTP context and returns a boolean. So instead of using employees, we can use the context object here. And then this one has to return a boolean, so either true or false. So you can see that when I say return true, the red squiggly line here is gone. Right? Of course, we have to do something special here. So our condition is based on the context object. And of course, you look at the request object, and then you can use any information in the request object to make a decision. Right? For example, you can read the body of the request and make a decision based on that. You can read the path and make a decision based on that. You can use the method. In this video, let's use the query string here, right? So if we have a query string, which is the ID of the employee, then we're going to return true. So basically, we can even just remove this curly braces, and this is not contains, this is contains key. Okay, now you can see that we don't have the right squiggly line anymore. So what this means, so let me format this first of all. Select everything, Control KF, very well, formatted this manually. Okay, so we have two parameters of this MapWhen function. The first one is a function delegate, and it takes one parameter and returns a boolean. So this one returns based on whether the query string contains ID or not. If it contains ID, it's going to return true. Otherwise, it's going to return false. And only when this condition is true do we go into this branch. Right? So this branching mechanism is based on the condition that is provided from the first function delegate. If this function delegate returns true, it's going to branch out. Otherwise, it's going to stay in the main branch. So we can give it a try right now. Let's run the application. Okay, so the root URL goes to the main branch, which is 123.321. And if we go to employees like this, it's still falling into 123.321 because there's no ID provided in the query string. Now, if I provide a query string, then it's going to go into 156.651. So this is the separate branch. Of course, here I didn't specify that it has to go to employees. So therefore, even when I provide the ID as a query string on the root path, it's still going to the branch right here. So if you want to combine different conditions, of course, you can modify this delegate here and make it quite complicated, because you can even use a curly brace as I showed originally. Right? If you use a curly brace right here, then you can write as complicated logic as you want. So here, if we return this, and also our path needs to start with. So let's say context dot request dot path dot start with segments, and if we say employees, right, and then we also need to require the query string, the ID to be present. I can finish this with a semicolon here. So both conditions need to be satisfied. Okay, so both this condition that the path need to start with this employees segment, and also the query string need to contain ID. So only when these two conditions are met do we actually take the context object into the separate branch. So if we run this, then it will be different. We cannot say ID equals 1 or 2 or whatever. So this still goes to the main branch, right? So if we want to trigger the separate branch, we have to go to /employees ID equals whatever, let's say equals 10. Now we're going into the separate branch. So this is what I want to show you in this video, where we create a separate branch based on a more complex condition, and that is provided by the MapWhen function instead of the map. Okay, that's all I want to show you in this video. If any questions, please let me know. If not, I will see you in the next one. So far, we have been using map and MapWhen methods to create a branch of middleware pipeline. But there is actually another method, which is UseWhen. UseWhen is also a method to help us to branch out from an existing pipeline, but there is something special about this method. So let's grab the diagram over here. Okay, so with map or MapWhen, you are going to create a branch, and this branch is a complete separate branch. But sometimes we want this branch to rejoin back to the next middleware where it's branched out. For example, in this case, you might want this to rejoin back to middleware number 2 like this, right? So after middleware 6, it goes to middleware number 2, and then 3 and 4, and then everything returns back to 3, 2, and from number 2, it returns back to middleware number 6. So something like this. So if you want to create a rejoinable branch, number 5, number 6, then we can use the method UseWhen. So let's jump into Visual Studio and see how that is created. So before I do that, let me copy this diagram and paste it over to here. And let me recover this. All right. Now let's focus on creating a rejoinable branch like this, so that after this branch is executed, the request is forwarded to the original main branch. Let's jump into Visual Studio and try to do that. So here we have the MapWhen in the previous video to help us to create a completely separate branch. So instead of using MapWhen, we can use UseWhen. So let's go to this, and then we say UseWhen. All right, and then now you can see that we have a very similar signature here, or actually the same signature as MapWhen. So if I remove this and just change MapWhen to UseWhen, it's going to just work, but this time after this condition is met. So it works the same way as MapWhen in terms of the condition here. So if this condition is met, which means that this is going to return us true, then this branch of middleware pipeline will be executed. That means middleware component number 5 and 6 will be executed, but after that, so this next call, it's going to trigger middleware number 2 here, which means that it's rejoining just like the diagram here, number 5 and number 6. So after number 6, the middleware pipeline rejoins to middleware number 2. So this is a special type of branch, which is what I call a rejoinable branch. So use the UseWhen method to create a rejoinable branch. So let's run this application and see how it's rejoins from number 6 to number 2. Let's run. All right. So we have 1, 2, 3, 3, 2, 1. That's because the condition is not met. So if you remember, the condition is a combination of path as well as the ID query string. So if I hit enter now, you can see we go from 1 to 5. So we are picking up the separate branch here, right? And then we're going from 5 to 6. Now we're rejoining back to the main branch, which goes to number 2 and number 3. So this is the end of the entire pipeline. Right now it returns back to number 3, to number 2, now to number 6, number 5, number 1. So this is exactly what I showed you the diagram. So let's see where the diagram is right here. So 1, 5, 6, 2, 3. Well, on the diagram I have 4, but in the program I don't have 4, right? So it's 1, 5, 6, 2, 3, and then 2, 6, 5, 1. So if we go to this web application here, we have 1, 5, 6, 2, 3, and then 3, 2, 6, 5, 1. So exactly like that. So this is what I want to show you. If you want to create a rejoinable branch, then use the UseWhen method instead of MapWhen method. And that's everything I want to show you in this video. If you have any questions, please let me know. In this video, I want to talk about write to the response. We have been writing to the response for many times already using the context.response.write async. There's nothing wrong with it. I just want to point out something that we need to pay attention to. The thing that we need to pay attention to is that once we start calling, for example, in middleware number 1, we already started calling response.write async. Once we started calling this response.async, it's possible that the entire response object is being sent to the client side already, right, to the browser already. Therefore, you're going to encounter problems if afterwards you want to modify the response headers, right? Because the response is already being sent to the client. It doesn't make too much sense to write to the header afterwards. Actually, you have seen this previously when we try to modify the status code, right? So for example, if we try to do that again, response.status code, if we want to modify this, or if we just want to modify any headers, let's say I want to add a new header, like my header, and then I say my header content, just like this. Then if we run it, we're going to encounter problems because response.write already started sending headers to the client side. If you want to set headers, you need to put headers before. Let's run it and see the problem. You can see already that we are not actually getting back anything from the screen. And if we go to F12 and bring up the developer tool and go to consoles, you already can see errors, right? Fail to load resource, incomplete chunk encoding. And maybe let's refresh and see if we try to trigger it again. And you see, it gives us a 200 OK status code back, but we have also problems with this. And if we modify this so that the headers is before response.write, then we don't have any issues. Let's see this by running it again. All right, so you can see that immediately we see the result. And if on this page, we bring up the developer tools, F12, bring up the developer tool, we have, go to network tab and try to refresh on this page again and go to observe this request and response. We can take a look at the response header and we see our custom header here, my header with my header content. So no problem with this, no errors anymore. And we go to /employees with ID, then we go to 156651. So you can see that if you want to modify the headers, then, or actually any part of the response, then try to do that before response.write. Because once you started calling this, the response is already sending to the client side. Now you may ask, so you suggested us to put everything before response.write, right? Just don't modify response after response.write. But while you're writing to the body all the time, right? We're writing to the body, not only in the first middleware, but in the subsequent middlewares. Writing to the body is fine. You can write to the body in the same middleware and in different middlewares. But there's something I want to point out you need to pay attention to is one of the response header is called content length, right? So if there is a content length and you already specify the content length, for example, like this, and then you write to it in the following middlewares, then you may encounter problems because you might increase the length of the body. For example, here, if I say 250, and then I just keep writing to it in the middleware number 2, number 3, number 5, number 6, then it's possible that the content length is actually longer than this, or at least different than the content length in the header, and in some cases that could be an issue. So that's something you really need to pay attention to. And also something you need to pay attention to is that when you create a custom middleware like this, so remember in ASP.NET Core there are tons of built-in middlewares, which is helping us to create web applications with ease. We don't have to create middlewares from scratch all the time. We have tons of already created built-in middlewares. We can use them. But in some cases, we want to create a custom middleware to handle some specific scenario. And when we do that, we also need to be aware that it's possible that some of the built-in middlewares that is called after your custom middleware or before your custom middleware might be affected by your middleware. For example, if you're specifying a content length in your middleware, and then in the subsequent middlewares, in the built-in middlewares, the response body is being modified, then the length is modified. So your content length that you calculated in your custom middleware may not be right. So you need to really pay attention to this type of discrepancy. This is something I want to mention in this video. If you have any questions, please let me know. If not, I will see you in the next one. In this video, let's talk about some built-in middleware components. So we have been using different approaches to create middleware pipelines with some custom middleware components. That's not the only thing that ASP.NET Core as a framework offers developer to create an entire application. In fact, this shouldn't be the way, right? We only need to create custom middlewares when we have in very special cases. The reason why I still teach the middleware pipelines and middleware components in ASP.NET Core is, first of all, it is the base of the framework. The entire ASP.NET Core is based on middleware pipeline, this type of pattern, right? So I need to teach. Secondly, if you do have very special cases where you need to create a custom functionality that handles cross-cutting concerns. For example, you just want to create a very special logging mechanism that works within your application and you want to put it somewhere, then creating a custom middleware could be a really good choice. But in most cases, there are built-in middlewares that help you to do everything that a web application needs to do, right? So those functionalities I already mentioned in one of the first classes here. So we have routing mechanism, we have authentication, authorization, model binding validation. All of these, they have specific middlewares to help us. So if you search on middleware in ASP.NET Core, you will see this article in Microsoft, learn.microsoft.com, ASP.NET Core middleware. And if you scroll down, so there's middleware order. And this diagrams here shows us a typical built-in middleware we can use to create ASP.NET Core MVC applications or Razor Pages applications. And in fact, most of the middleware also apply to minimal API applications. And on this diagram here, you can see custom middleware that is placed right here. In fact, I think if you do have special cases, it's possible that you apply your custom middleware at any place. It doesn't have to be after authorization. It is just that in most cases, when you create custom middlewares, most likely it's going to be after the authorization and before the endpoint handler. It's most likely placed at this place. And then you see we have exception handlers, HSTS, HTTPS redirections. All of these are built-in middlewares. And it's very easy to add this to the pipeline. For example, if you want to add the HTTPS redirection or the routing or course, let's jump back into Visual Studio. And just after we build the application here, if I say app.Use HTTPS redirection, then it means that I'm putting this middleware right here, right? It's just one line of code. What about routing? So we can say just use routing, and we put the routing middleware right here. The custom logic is coded inside this function. So this is the extension method, right? Inside this method. So go over here to definition, and you can see that this is an extension method here, static class, static method, and applies to the application builder interface, right? And then there's logic over here if you want to look into that. Use routing. What about course? We also mentioned course. So we have the course middleware as well. So just one line of code. You can add the middleware right here, and then later I'm going to talk about configuring these middlewares. And that's all I want to mention in this video. So there's a certain order of this. In fact, this order follows the diagram that I presented right here. Routing, authentication, authorization, model binding, model validations. All of this is right here. You don't see model validation, but that's part of another pipeline, which also I'm going to talk about it when I talk about MVC or minimum API. So yeah, that's everything I want to cover in this video. If you have any questions, please let me know. In this video, let's learn about creating a custom middleware class. So first of all, what is the reason of creating custom middleware class? So if we look at our existing middleware that we have been creating so far, and you would be able to see that the code looks very messy. So I have this file and it contains how many? 6 middlewares, I believe. 6 middlewares. And they're all contained within the program.cs file. And you know what is the purpose of program.cs file? It is for configuring our Castro server, our web application, and to add middleware to the pipeline. Right? For example, one of the built-in middleware component is just as simple as specifying this. For example, use routing or use course, right? Use authentication. It is as simple as this. If we are adding the middleware and at the same time add all of the implementation logic of the middleware component, then it's really CRUDing this program.cs file. The implementation details need to be extracted and put it to somewhere else. And that's the purpose of why we have this. Let's delete all of these 3 lines, recover it back. There are different ways to organize the code and extract the implementation details into another file. For example, there's extension method. You can create an extension method. You can create a class based on convention, or you can create a custom middleware class that implements a interface. All of them are very similar, and they actually do the same thing. My favorite way of organizing the implementation details in different files is to use the custom middleware class. I don't think it makes sense to show you all 3 ways of organizing the implementation details. I think it makes sense to show you one of the ways. And my favorite way is to use custom middleware class. And why this is my favorite way, I have a reason for it. So this custom middleware class implements from the IMiddleware interface. And that makes the intent of this class very obvious. So if you were to follow the convention way, which is to create a class and just create it based on convention. So it's not, the intent of this class is not very obvious, right? It's not very obvious. And you have to know the convention. Whereas if you just implement an interface, you are forced to implement the method or methods that is specified within the interface. So your intent becomes very clear. And then when you use it, you just need to register the class as a service. So that's why I like using this approach. And to use this approach, you have 2 steps. The first one is to create a class which implements the interface. And the second step is to register class as a service. So let's jump into Visual Studio and try to do those 2 things. Let's jump into Visual Studio here and let's actually create a folder. Now that we are trying to organize our code, it does not make sense to put all of the files in the root folder. So if we are creating middlewares, then we can just say middleware components, create a folder like this, and then create a middleware class inside the folder. So I'm just going to call it my custom middleware. You can call it anything you want. The only thing you need to really pay attention to is you need to implement the IMiddleware. And once you do that, you see this light bulb here. You can click on this and then click on implement interface. An easier way to do this is to do control dot, and which does the same thing. And then I'm going to just hit enter, right? Because the implement interface is already highlighted. If this is not the one that I want to go, I'm just going to use my keyboard arrow keys to go down, and I go to the item that I need to do and then just hit enter. So once I hit enter, this method that is defined inside the interface is automatically implemented for me. Of course, the implementation details is not there, right? Because if I right click on this and pick definition, I can see that the definition of the IValidatableObject interface only has one method, which is the invoke async method. So here I can remove this. Now, if you observe the signature of this method, you can see this is basically the same thing as what we have in the Lambda expression. We have HttpContext and we have the request delegate for the next middleware, right? So we have the same thing here. And basically, if you just want to implement a middleware, you just put your logic right in here by following the same stuff that we have went through before. So for example, if I just copy this over to put it over here, and then I'm gonna just say my custom middleware, and I'm gonna remove the number, and over here I'm gonna say my custom middleware. I'm gonna remove the number too, and now I'm gonna add the async keyword. The async keyword enables us to call the await keyword. So if you want to use await keyword for a async function, then you need to use async keyword, because async keyword enables us to use the await keyword. And everything after the await keyword, like the line after the await keyword, is a continuation of this async method. Okay, so now we have 3 of them, and this is our implementation details of our my custom middleware. Of course, for your middleware, there's going to be way complicated logic here, but this is just for demonstration purpose. And so far, we have finished our first, which is to implement this logic, right? Which is to create a class that implements the interface. Now we can move on to the second step, which is to register the class as a service. Okay, so let's go to program.cs. And that's why I'm saying program.cs, the main purpose of this is to configure our application. Now it's time to configure our application. We need to let our application know that we have a custom middleware class ready for use. And how do we do that? We need to use the builder object. And we're going to say builder.services.add. There's different ways to add it. We can add transient, we can add singleton, we can add scope. And these are the lifetime management of the service, or I have to say maybe it's called lifespan management. But later, when we talk about dependency injection, we're going to go deeper into this. Right now, I'm going to just use transient, and I'm going to just put my class here, my custom middleware, and that's it. Right? So this is how I register it. And there is the third step, and the third step is just to use the middleware. So this is when we use the use method, right? And the use method, the run method, they are the method that help us to use the middleware. And for our purpose, for example, let's remove this UseWhen, right? And let's add our custom middleware between middleware number 1 and middleware number 2. And how do we do that? We're going to say app.Use, and this time we have a brand new method that is called useMiddleware. And then here, I just need to specify the name of my class. So when I do this, when I say use middleware and specify my class, and when the request is received and forwarded to here, ASP.NET Core is going to know that it needs to instantiate a middleware. And the name of that middleware class is my custom middleware. And then it goes into the services collection here to grab instance from there. And basically, how this works is that we specify the type. Right? We provided the type into the services collection. And when that type is needed to be instantiated, it goes into the services collection to see whether the type is already registered there. If it's already registered, it's going to instantiate. And there is a lifespan management factor there that we're going to go into when we talk about dependency injection. But so far, you just need to understand that we register the class type and put it into the collection. And then when we need it, right, ASP.NET will go into the services collection to grab the type. Only the type that is already registered with ASP.NET can be used. Okay, so here, before the class is used, it needs to be instantiated. Then it goes to the services collection and see that it's already registered, and then it instantiates the class and becomes an object, and then it triggers that middleware. How does it trigger the middleware? It calls the invoke async method. That's how it all works. And let's run this application and observe that the custom middleware is being used. All right, so now you can see that because we didn't create a branch, right? We didn't create a branch based on conditions. So all the path works, all the URL works. So of course the root URL also works, and you can see that the first middleware is triggered and the custom middleware is also triggered. And then it goes to the second, third, and then it comes back to the second, and then it comes back to the custom middleware. Then it returns to the first one. And after that, you know what is happening, right? Everything returned to the browser. And that's everything I want to cover in this video. You just need to remember that in order to create a custom middleware class, it's very simple, 2 steps. The first step, actually, you can say that there's 3 steps, right? The first step is to create the class that implements the interface. Which interface? The IValidatableObject interface. And just implement it as per normal. The second step is to register the middleware class as a service class. So it's stored in the service collection. And the third step is to use the middleware. And then you have to use middleware at the correct place. The order of placing these use methods or run method, it matters, right? You put it here or here, it makes a huge difference. And when you want to use your custom middleware, you just use middleware method and then provides the type. And your middleware will be used in the pipeline. That's everything I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one. This is an assignment video, and this is assignment number 2. We are going to create a custom exception handling middleware. I know that in ASP.NET Core, there is already a built-in exception handling middleware that we can use, but I'm going to ask you to create your own exception handling middleware that is similar to the built-in middleware. And the purpose of this, there are actually 2 purposes. The first one is that it's going to help us to practice what we have learned in this chapter, especially you need to create a separate class. So don't use the use method or the UseWhen method to create this. Use a separate class to implement this middleware component. The second purpose is to understand the ordering of the middleware components. So your own custom middleware, whether you place it in the first place or the second place, you know, the sort order of the middleware components is very important in relative to the other components. So the exception handling middleware, it needs to be placed at a specific location. So you need to figure out where is the best place to place this custom middleware. And go back and try to work on this yourself, and I'm going to see you in the next video. In terms of what is going to be displayed once an exception is handled, you can display as little as you want or as much as, but try to display it in a nice HTML format. And try to go back and work on this yourself. I will see you in the next one to provide my solution. Welcome back, and we're going to work together on this assignment. Try to create a custom exception handling middleware. So first of all, how do we handle an exception? And we all know in C# we need to use try catch to handle exception, right? We need to use try catch to include all of the code that is potentially going to throw exceptions. So far, you have learned that middleware pipeline is actually the foundation of ASP.NET Core. Everything in ASP.NET Core runs through the middleware pipeline, except the Castro server, which means that every single component here. So with this example, we have 1, 2, 3, 4 different middleware components in the pipeline. So potentially any of these middlewares or middleware components could throw an exception. So therefore, if you were to handle this, the easiest way to do it is to use a try catch and just include everything inside your try catch just like this, right? But our requirement for the assignment is to actually use a middleware component instead of just directly using try catch in the program.cs file. It doesn't make too much sense. Since we already have this middleware pipeline pattern here, we need to follow that pattern. We need to create a middleware, right? So therefore, we are going to create a middleware and based on the pipeline pattern. And as I have already pointed out in one of the first video in the section, the middleware pipeline, let me find the diagram there where we have the middleware pipeline theory here. And you have already seen this diagram where the middleware is actually a series of functions, right? The first middleware calls the second middleware, calls the last middleware, and then everything returns back. Because it's a series of function calls, which means that this first middleware calls the second middleware, and then calls the third one, and then calls the fourth one. And then when the fourth one returns, it's back to the previous one, and then returns back to the previous one, and then to the previous one. So you are very familiar with this already. So therefore, what we can do is we can create another middleware, and we can call it my custom exception handling middleware, or whatever name you want to give it. And where do you need to place it? This is very important. We need to place that middleware at the very beginning of the middleware pipeline. And when we do that, now let's just start writing the code. We're going to call it middleware, use middleware, and then I'm going to call it my custom exception handling middleware, or just call it my custom exception handler. And this middleware will have to be placed at the very beginning. Because when you place this middleware at the very beginning, that means this middleware is itself a function and is the first function that encompasses all of the others, right? The first function calls the second, and second calls the third, and all the way to the last. Which means the try catch in this first function is going to encompass all of the rest of the middleware, the entire pipeline, right? That's the theory. And now let's try to create it. So we have this class name already. Let's go to Solution Explorer and go to our middleware components here. This is where we place our custom middleware components. Let's just simply create a class, and then we're going to call this my custom exception handler, and go over here. Remember, there are 2 steps, or let's say 3 steps. Right? The first one is to let it implement the I middleware, do a control dot, or just simply go to the left hand side, click on this light bulb, and then click on this implement interface. Now we have this one implemented without any actual implementation. And here it's very simple. We're going to use a try catch to include all of the rest of the middleware in it. And how do we do that? We simply just call next and pass the context into it. Right? So when we do this, we are calling the next function. And then, of course, the next function is going to call the next one after it, and then all the way to the last middleware, and it all come back. Therefore, by using a try catch like this, you are actually including all of the middleware components in the entire middleware, right? And then here you can just say catch, and you're going to catch a generic exception because you don't know what type of exception is going to be thrown. So you're going to use this generic exception like this. And then here you can do your logging, you can do your displaying. Let's just do simple, okay? So of course, here the next is going to be possibly a async method. So we're gonna use async, and then over here we're gonna use a wait, and over here we're gonna use the context dot response dot write, right? And we're gonna write asynchronously with the await keyword like this. But first of all, we need to specify the content type. So we're gonna say context dot response dot content type. The content type is part of the header. You don't have to write it this way. You can write it like this, headers type. But because this is a very commonly used header, therefore there is a separate attribute for it, or a separate property for it. We're going to use text/HTML. So we're saying that we're going to write HTML in the response body. Okay, now we're going to write the response body. And what are we going to do? We're going to say, first of all, I'm going to use header or head number 2 to make it pretty big. I'm going to say this is a error, and what type of error is going to be expressed in the next line. Okay, so here I'm going to say the error was a interpolation. I'm going to say ax dot message. I'm going to just put the message right here. So this is top level message. This is not the inner message, right? Okay, so we have this and it shows the message. We can actually try to use it, although I want to provide more information to the user. But so far, we're already providing something, and I want to use this already in the program.cs file. I want to place it in the pipeline. And as I mentioned, we really need to place it right here. But this is not enough. Remember, we need to register it into the service collection, just like what we did for our custom middleware there. So let's copy and paste it. Now let's copy this class name and put it here. All right. So now we're ready to use this middleware, and we need to throw an exception somewhere, because right now we don't have any exceptions in this 4 different middlewares here. So let's try to throw an exception. Let's say we throw it directly. Maybe not directly. Maybe let's throw it a third middleware here, and let's just throw new, let's say application exception, and I'm going to say test or exception for testing, and that's it. And let's run this application now and see what happens. All right, we're looking at this page, right? This is the home page and nothing is happening. It's blank. And let's troubleshoot. Let's go to F12 and we look at this console tab here. We see this fail to load resource, and it looks pretty familiar. It looks pretty familiar. This is actually something I really want to show you. We have covered this, that once we start writing responses, the headers already go to the client side. So if we want to change the header, it doesn't work and it's going to cause problems. And that's exactly what's happening right now, because we're trying to use our middleware, although we placed it in the first place here. The problem with this is that if we go to the exception handler here, you can see that this catch is happening after the entire pipeline has been called, or at least after the exception is thrown, which means partially some of the components already executed. In our case, that's exactly the scenario. If we go to program.cs, we go over here. So middleware 2 throwing exception right here. That means the first 2 middlewares here already executed. And if we open it, we can see that response.write. So here means that even at line 15 in the first middleware, we already sent headers to the client. And what are we trying to do in our exception handler? We're trying to handle the exception right after this, which means a lot of the response.write have been called. And after that, we're trying to modify the header. So let's go to exception handler here. We're trying to modify the header right here. It doesn't work. We have to fix it. We're going to cut this and we're going to place it right here. And this is going to fix the problem because this is going to be the first line that is executed. And because this is the first middleware in the pipeline, so therefore it's not going to have the same problem anymore. And let's run it again. Let's see to see whether the problem is fixed or not. Okay, now we see our error and we see our top level error message, right? Exception message here. And here, this is written by the first middleware. Because we coded like this, so we wrote it to the response already, which means it's already sent to the client. And the exception is thrown afterwards. So therefore, we cannot undo what we already sent. Remember, the response body is a stream. So it's already went to the client. So therefore, we cannot remove this. Whatever that is already output should be output, right? It's already output. So our error messages start at the bottom, and there's nothing we can do about that. So I'm going to say error and then exception handling. So therefore, we can see that our exception handler already works, right? It caught the error. No matter where you throw the error, we already caught the error. The rest of the work is to just make it pretty. Right? We can change our exception handler here, for example, to add what are the query strings being used, what are the headers being used. Everything can be spelled out in this area. And when developers see this error message page, they are informed with enough information to troubleshoot, right? In this video, I'm not going to write the rest of the HTML. You can try to make this error handling page prettier. And that's everything I want to show you in this video. If you have any questions, please let me know. If not, I will see you in the next one. This is a new section. In this section, we're going to learn about routing in ASP.NET Core. In this first lesson, we need to understand endpoints for the purpose of understanding how routing works. First of all, we need to reiterate the concept of routing. When a request comes into a web application, which typically consists of many endpoints. Now, which endpoint should be used is the question. And that's why we need something that is called routing. Routing is the functionality that maps the request to a endpoint handler so that the endpoint handler can be used to handle the request. That's the concept of routing. Again, routing accepts the request and maps that request to one of the endpoint handlers in the web application. So that's the concept of routing. But first of all, in this lesson, we need to understand what is an endpoint and how it works, even how to create it. Because without understanding this part, we don't know how routing would work, right? We don't know how routing can be able to select an endpoint and try to execute it. So let's focus our energy on understanding endpoints in this video. So first of all, what is an endpoint? Here is the definition of an endpoint. An endpoint handles a request and returns a response. So there are two key parts in this definition. First of all, it handles requests. Only by using handling requests to define an endpoint is not enough. Because if we look at our middleware, any of the diagram would work. For example, this one, we have 3 middlewares in this middleware pipeline. Each one of them potentially can handle the request, right, in a different way. So just use the first part, which handles the request, to define a endpoint is not enough. We have to add a second part, which is returning a response, right? So a middleware that handles a request and returns response would be called an endpoint. Returning request indicates that this middleware is a terminal middleware. It prepares the response, and because it's terminal middleware, so it returns that response back to the browser. So that's two different key points defines the endpoint. It handles request and it returns a response. Now, what are the types of endpoints in the ASP.NET Core? First of all, of course, you can create your own custom middleware to be a terminal middleware and returns response. In fact, that's what we did when we learned ASP.NET Core middleware pipeline in the previous section. Right? A lot of them are terminal middleware that returns response. And by definition, they are endpoints. However, for a web application, usually it returns HTML. For a web API, it could return JSON or XML. And to manually construct HTML or JSON is a pain. Therefore, we need a framework to help us. And of course, we're learning ASP.NET Core, which is the framework that can help us to return the response, right? So those are the built-in endpoint handling middlewares. And if we look at one of the first diagram here, which is, I believe, here, you can see that we have this rectangle here, which includes all of these things. So this rectangle basically is the rectangle for endpoints. So we have 3 different built-in ways to return response, which means we have 3 different endpoint handling technology in the ASP.NET Core. We have IVC, which is used to return HTML as well as web API. We have Blazor pages, which is used to return HTML. Then we have minimal API, and this is usually only for constructing API, which usually returns JSON. Now we have middleware. This is for customize, right? So this is the customized middleware that we as developer can create ourselves to use as a endpoint. So we have these 4 different options in ASP.NET Core to work as an endpoint. Coming back to over here, we finished defining the endpoints, and we know that we have 4 different options in ASP.NET Core framework for us to create an endpoint. Then we can try to work on creating endpoints in this lesson. But first of all, we need to understand something else. It is what I call the identities of endpoints. So let's scroll up. We have, for example, these 3 different endpoints. And the endpoint must be able to identify itself, right? For example, how do I identify myself? If I go to any government agency, they would ask me to show my ID. So I use my ID, for example, driver's license, to identify myself. I need to be identify myself. If I cannot identify myself, the government agency would be thinking, okay, this person could be the same person as I am. They could not distinguish them, right? And then they wouldn't allow me to do anything in the government agency. Going through the airports, they wouldn't allow me to go through the borders. And in the same way, if endpoints cannot identify themselves, then routing functionality wouldn't be possible, because routing needs to know where to map the request. And to do that, first of all, they need to see the differences between the endpoints. So how do we identify endpoints? We actually have talked about that when we talk about the second chapter, which is the HTTP protocol and HttpContext, right? We talked about basic routing, which is a combination between method and the URL. In this chapter, we're going to actually expand on that, but the basic routing technology or the concept is still based on the combination of the HTTP method and the URL. So those 2 still identifies a endpoint. Now that we know the basic concept of identities and how to identify an endpoint, we can go ahead and try to create endpoints in ASP.NET Core. Of course, we don't want to use custom middleware anymore. We have finished those in the first few chapters. We need to use one of the built-in ways, and I'm going to choose the minimal API way for teaching purpose because it is the simplest working with ASP.NET Core. Let's create the project, and we're going to select the ASP.NET Core empty template. If it's not in your recent project template, you can go over here and search for it. Make sure here we select C#. Otherwise, we might accidentally select F# or something else. So we're going to search ASP.NET Core here. And then in the list, you're going to look for ASP.NET Core empty. I'm going to use the empty template. So for me, I'm going to select this one, click on next. And then here, we're going to call this one, the solution, learning routing. Another name for this word is routing. For me, it's easier to pronounce it as route instead of route. And I'm going to call this web app because we are still creating a web application. So click on next. And here we're going to select .NET 11. For me, it's preview. I'm
when you watch this video, it might be already .NET 11 released. So there's no parenthesis preview. And uncheck this one because we're going to add HTTPS to our solutions later. And keep everything else as default and click on the Create button.
Okay, let's close this. We don't need it. And let's go to program.cs. We see this one line here. We're going to talk about this later. For now, let's delete. What we need, the 8 in the ASP.NET Core. And the way to do that explicitly is to use app.Use endpoints. This, if you read the explanation here, it says as a endpoint middleware to the specified, basically to the middleware pipeline. So I'm going to use this, and then I'm going to delete this automatically generated code over here. And inside here, I'm going to say endpoints.map. Map what? Remember, we just talked about how to identify different type of endpoints. We use the combination of the HTTP method as well as the path. So here with minimum API type of technology, we have different methods. For example, map get, post, map put, or even patch here, map delete, map, basically almost everything that corresponds to the HTTP method. So let's try to create a endpoint to handle a GET request. And then the second part of the identity is the URL. URL is not just hard-coded as we talk about in the second chapter when we talk about HTTP protocol. It can be way more complicated, way more flexible than that. But for now, in this first lesson, let's still use hard-coded path. So we're going to say employee just like before, and then we have a handler here. Here are two different signatures. We're going to use the second one for now, which takes a HTTP context. And then we can say context.response.write async, and we can say get employees. Usually we call it with await keyword, and we add async keyword to enable that. Now you see the green squiggly lines. And if you hover the mouse over it, it says suggest using top level root registration instead of using use endpoints. What does that mean? So we have this method use endpoints for us to help developers to create endpoint handlers. And you can actually create different endpoint handlers inside it, right? So you can say I create one for get, one for post. Right, so here I'm going to say get employees. I'm going to say create an employee. Remember, the post method is to create a new resource. Right, so under use endpoints, you can create different endpoint handlers. But what it says is that suggests using top level root registration, which means this is not top level root registration. What is top level root registration? Remember that when the project is just created, what you saw is app.Map get. Remember this? So basically, we have this endpoints map get. You can basically do the same thing over here. See, when I did this, there's no green squiggly line. There is this thing here. It basically just says I have a spelling error. Employee, so gotta change that. Okay, and fix this spelling error too. Okay, so ASP.NET Core suggests you to do this. And basically, this is equivalent to this. When endpoint technology was just created in, I think, .NET 3 or ASP.NET Core 3, we have to say use endpoints, and then we have to say map get or map post inside this, just like this. I think since .NET 6, they removed the necessity to use this method. You can just directly use map get. But using it this way is equivalent to this. If you just write it like this, eventually the endpoint handlers are still put inside the use endpoints function. This is just an easier way to write this. But by doing this, it's not very clear what you're trying to do, right? The intention is not very clear. Therefore, for teaching purpose, I'm still going to write it like this. Use endpoints. That makes everything inside very clear. We know that this is an endpoint, this is an endpoint, right? By doing it like this, eventually when you create your own project, I suggest you to do it this way because it's easier, but intention is not very clear. It's not very good for teaching purpose or learning purpose. That's why I'm going to remove this. So we have created two endpoint handlers. one thing I want to emphasize here is that in order to create multiple endpoint handlers, you put endpoint handlers inside the use endpoints function here, like this. But do not use multiple use endpoints, right? So don't do something like this. Don't do something like this in order to try to create multiple endpoint handlers. Instead, put this inside use endpoints. So all the endpoint handlers should be inside the use endpoint function here. Okay, so let's create two more. One for put, the other one is for delete. So we have map put, and here we're going to say update an employee. We're not actually updating anything. We're not actually creating or getting anything. We're just returning the hard-coded string. But this is to demonstrate that you can create different endpoint handlers that maps to different HTTP method. Later, we're going to do actual work. But for now, let's just hard-code some string in the response body. So get, post, put, and last but not least, the delete method. I'm going to say delete an employee. And let's give it a try. So what you see is complains that it's unable to connect to the web server. And if we go to this, so basically this is the web server that is running. Let's enlarge the font, and you can see it says the endpoint routing middleware matches endpoints set up by endpoint middleware, and so must be added to the request execution pipeline before endpoint middleware. Okay, so basically these are the endpoint middleware, but we have so many of them. ASP.NET Core doesn't know which endpoint should be executed because we haven't done routing yet. And that's what we are going to talk about in the next video. In this video, we have learned all about endpoints. What is endpoint? How to identify endpoints and how to create endpoints. In the next video, we are going to talk about how to route one of these endpoints. That's everything I want to cover in this video. If you have any questions, please let me know. If not, I'll see you in the next one. In this video, we're going to talk about using the routing middleware component. In the previous video, we completed these endpoint handlers with the endpoints middleware component. But when we try to run it, it throws an exception because it says that we need to use the routing middleware. Let's go back to our diagram first. So this is the diagram that we talked about in the previous video. We have these endpoints just like in the diagram, right? But we didn't configure the routing middleware. So we're missing this part. Let's go into Visual Studio right now and try to just apply that routing middleware. And it's really, really easy. You can just say app.UseRouting, and that's it. That's our routing middleware here. Now, applying this is easy, and understanding it is another story, which is still easy, but we need to cover that. So let's go into this diagram again. So we have already placed the routing middleware in front of our endpoint middleware. So remember, this sequence is very important. We have learned middleware, and you know that where you place a middleware component is very important because middleware components are actually executed one after another. The order is very important. We always need to place the routing middleware before our endpoint middleware. So what does routing middleware do when we place that in front of our endpoint middleware? Remember in the previous video, we have talked about the identities of endpoints. Each endpoint has its own identity, and identity is supposed to be uniquely identify an endpoint. So that identity is roughly done by the combination of the method, right, the HTTP method, and the URL path. We will talk about the URL path later. It's not just the URL. The URL itself contains many parts. So I leave more than one part, not just the URL itself. But for now, we can just say that, okay, it's a combination between the method and the URL. So let me enlarge this font. So each endpoint has this combination, right? Because of that, how it works is that when ASP.NET Core executes the routing middleware, the code is already compiled, right, on the server. So it will be able to find or at least go through all of the middlewares and check each one of the middleware and find all of the endpoint handlers and check each one of its combination between method and URL, right? So this is what I call identity. It checks the identity and then try to find a matching between the request and the identity of an endpoint handler. Once it finds a matching, then it will record the information about this endpoint handler inside HttpContext object. This is what the routing middleware does. Right? All of that, what I talked about just now, is what the routing middleware does. It tries to match the request to the identities of the endpoint handlers. And then once it finds one, for example, number 2, then it will record the information of endpoint number 2 inside the HTTP context. And that's what is done by the routing middleware. And I'm going to show you right here. So let's go back to our web application. And then what I can do is that before the routing middleware runs and after routing middleware runs, I can show you. Okay, so here I can use the use method here. And then I'm going to try to show you what is inside that HTTP context. Okay, before I do that, I'm going to call the next method so that our routing middleware can be called in the next turn. So here I'm going to say await next, and I'm going to pass the context object into it. And then I'm going to copy and paste that right over here so that we can set a breakpoint in here as well as in here. And then we can see what differences the routing middleware does. What we anticipate is that the context object is going to be changed by the routing middleware so that the selected endpoint will be recorded in the context object. Let's run the application and observe what's going to happen. As you know, let's run through this without checking anything. So this is the application. We are loading the root path, but we don't have anything that corresponds to that path, right? So in our use endpoints, we don't have an endpoint that actually handles the root path. Everything handles the employee's path. That's why I run through that without checking anything. So let's go to /employees, and then we're going to check the context object. So what we are going to check is, so I'm going to do right click, and then I'm going to do quick watch. And then here we are going to look at this endpoint object. See, it's null, which means an endpoint is not selected yet. Remember the responsibility of the routing middleware? It is try to match the request to an endpoint and then select that endpoint and record that in the context object. So let's go ahead and just run to here. So I'm going to just continue. Now, again, we're going to examine the context object. And now if you look at this endpoint, you can see that an endpoint is no longer null. So something is there. So who did the job? The routing middleware did the job. It populated the endpoint object, right? It has a display name, and you can see that the display name is a combination of the HTTP method and the path. So that's what I say. This is the identity of the endpoint. Imagine that you have two endpoint handler that has the same identity. The routing middleware is going to throw exception because it doesn't know which endpoint to actually select. Right? Selecting an endpoint is not just about recording the name. It is also, you can see that it has a request delegate. So with this endpoint object here, ASP.NET Core can actually invoke the selected endpoint just by using this endpoint object because it contains the delegate, right? So if you have two endpoint handler that has the same identity, which means the method and the path are the same between the two, then the routing middleware is not going to be able to identify the request delegate. Therefore, it's going to fail, right? So context.endpoint is the object. Usually you would use a method. If you really want to get it in the code, what you need to do is to use the method getEndpoint, and it's going to give you the same thing. So we can try to do that right here in the immediate window here. We can say context.getEndpoint. And if you do that, it returns you everything like this, right? Which shows you that we have what we need. And if I continue, guess which endpoint here is going to be triggered? Or maybe I should use the word invoke. So which endpoint handler here is going to be invoked? It's going to be this particular one. Why is that? Because we're using a browser, and the browser launches a GET request, a HTTP GET request. So let's continue. All right, so we see get employees. And if we use our postman, let's go over here, then we can try to invoke the other endpoints. So let's say we go to add employee over here. And because we created a new application, so the port number is different. So what is the new port number? 5291. So let's copy and paste that into our postman. And you call it, and you can see that this breakpoint is again executed. I'm gonna remove the breakpoint, and we can see 200 OK over here, and it says create an employee, which means that we triggered our endpoint. So we're gonna do the same thing with update, which is the HTTP put. So we're going to send a request, and you can see update an employee. Okay. We also have a delete employee. It's not going to delete anything. It's just going to hit the endpoint method. It doesn't do anything except returning this message. Okay, so as you can see, we're able to use our routing middleware, and the routing middleware successfully selected the endpoint, this one by default for the browser, based on the identities of each. And you also learned how to access the endpoint object in the HTTP context object. And that's everything I want to cover in this video. Right? Remember that just because the HTTP context object contains the endpoint object, it enables all of the rest of the middlewares, built-in middlewares, as well as custom middlewares to have access to this endpoint. So for example, authentication and authorization is going to be based on the endpoint object. It has to know which endpoint that the user is trying to access before it tries to authorize, right? Because different endpoint has different permissions. So it has to know which endpoint is going to be executed. Then it can determine whether the user has permission to access the endpoint. So that's why you need to consider the ordering, right? You have to use the use routing method. Place the routing middleware at this place. Use this first, and then all of the other middleware that depends on the endpoint after this method, so that they have access to the endpoint object in the context object. And that's what I want to show you in this video. If you have any questions, please let me know. If not, I will see you in the next one. In this video, let's quickly cover this 404 not found middleware component that is used by default when a path is not, or let's say when a matching endpoint handler is not found. Let's go back to this previous diagram over here. I'm going to copy this and just borrow it over here. All right, so this is how it works. You knew how the routing middleware worked from the previous video. The routing middleware try to match the request to the endpoint handler based on the identity of, which is combination between method and URL, and then the endpoint middleware try to execute the endpoint handler. But what if the routing middleware fails to match the request to any of the endpoint? ASP.NET Core by default, although you don't see it in their code, right? You don't see any other middleware in the code, but by default, ASP.NET Core applies a few other middlewares. And one of them is this 404 Not Found Middleware, which means that when the routing middleware cannot find any of the endpoint handlers to be matched to or mapped to, then it's going to actually route the request to another middleware. That is the 404 Not Found. This middleware is going to generate a 404 Not Found dummy page. And this middleware is included in the pipeline by default. 404 Not Found middleware is also a type of endpoint handler, right? Because by definition, it handles the request, first of all. Secondly, it returns a response, and this response contains a special message, which is 404 Not Found. So we can actually see that if we try to execute the application. Let's try to execute it. And then at the beginning here, you see that we are targeting the root path. But because none of our endpoint handler handles the root path, therefore it goes to this branch, which is the 404 Not Found. This is also a terminal middleware, right? The endpoint handler as well, which returns a special response, and that is this page. It says this localhost page cannot be found. No web page was found for web address, this one, which goes to the root path, and then it displays the error code here. So you might think this is not a page, it's actually a page. And this page's response is generated by this dummy middleware here, the 404 Not Found middleware. So this is what I want to show you in this video very quickly. Thank you for watching. I will see you in the next one. In this video, let's learn about the required root parameters. So far in our application, and also when we learn about HTTP, we had these endpoints. And the path is really just /employees. And they're all the same. Now, when it comes to the delete method and try to get a particular employee information, we had to use query string. So let me show you what we used before. We use /employees with a question mark and ID equals to 1. So this is to say, give me the employee information, and which employee exactly? It's the employee with ID equals to number 1. So this helps us target a particular employee. This path can be used in the get method or with delete method. But in this video, we're going to learn something new. Instead of using query string, we're going to use something like this. So /employees /1. So this is the same thing. This is the same purpose. We're going to target employee number 1. But why? Right? You may ask why we have to do this when we already has a mechanism, which is query string. Well, it has many benefits when we use it this way. This is cleaner, right? The URL is cleaner this way. So if you compare this with this, of course, /employees /1 is much cleaner than the query string, right? And also, it's better for search engine optimization because search engines, they actually look at the URL and then they consider a URL with a query string like this. Let me show you. They typically consider this URL and this URL are duplicate URLs. They see these are duplicate URLs, so they kind of ignore some of the URLs. So if you use /employees /1, this is going to be completely different from /employees /2. So if you have a requirement to actually use search engine to index all of these individual employees information, then you need to actually use this approach. And this is called a root template, right? So this is a template and it's called root template. So try to use root template instead of the query string. It's also because it's cleaner, so user has a better user experience. So because we have this approach, then this part of the URL becomes a variable. That's why we call it a parameter. And in ASP.NET Core, in order to make this part a variable, we typically use something like this. right? So instead of saying question mark ID equals to something, we're going to say curly brace ID. So this is a template. This particular one is the template. And /employee/1 or /2 or /20, these are the specific value that match that template, right? So this is the template. And when we use curly brace, the part that is inside the curly brace, it becomes a variable of this path, and we call that a root parameter. And specifically, this is a required root parameter, which means that if you put something like this, so let's use the delete method because the delete method already exists. I don't have to add an additional one. If you say like this, then this ID here, or this part of the URL, is considered a required part. And let's make something clear. There's some terminology here. So first of all, this is called a root template. And the root template has different segments separated by slashes. A slash, and then this is the first segment, and this is the second segment. Okay, the segment that has curly braces are considered root parameters. And the segment that is hard-coded, like here, employees, these are hard-coded. This is called the literal segment. So again, this is the literal segment. And this is the root parameter, and is a required root parameter. So if we have something like this, so let's say /employees /position and /ID. So this means that this part is the literal segment of the root template. And then we have two root parameters, two required root parameters. First one is the position. Second one is the ID. So these are the terminologies that we need to be clear. And then we're going to talk about how to match a template. So a endpoint will be defined with a root. And when a request comes in, the URL in the request has to match the root template. That's one of the conditions in order to be mapped to this. And how to map to the root template? The literal part of the segment. So the literal segment has to match 100%, except that it's case insensitive, right? So whether it's a lower e or uppercase e, whether it's a lowercase m or uppercase m, it doesn't really matter, but the letters has to be exactly the same. E, M, P, L, O, Y, E, E. So the literal segment has to match 100%. And then you have to provide two segments of variables here. So it doesn't really matter what you provide here. It's going to match to this first segment. We don't have a constraint on this parameter yet. So let's say 1 and then 2. So this URL is going to match this root template because it has 3 different segments. The first one exactly match the literal part. The second match the position. The third one match the ID. But if you have something like this, this is not going to match this particular root template. And if you have something like this, it's going to match to this particular root template. However, if you have something more like this, again, it is not going to match to this root template. Okay, so let's revert this. So when we say /abc/1, this is going to map to this root template, right? And then the endpoint with this root template will be selected if the method also matches. And once we have a match, the root parameter values will be stored in the context object. Let's take a look. So we're going to have an example like this. So we're going to have /employees/ID with just one root parameter. And then we're going to try to use /employees/1, try to match to this root template. Okay, so we're going to define this root template just like this in the map delete method here. And then we're going to set a breakpoint right here. And I'm going to run the application. All right, the application is running. We're going to the dummy 404 not found page. That's normal. But what we are going to do is we're going to go to this postman over here, and then we're going to do slash, let's say slash 101, and then I'm going to click on send. So the breakpoint is triggered over here. Now, if we look at the context object over here, and then we're going into the request. Now we're looking at the request object, and there is a root values variable here, or let's say call it property. And you can see that it says count equals 1. And if we open this, you can see ID equals 101. So what I'm trying to show you here is that once a template is matched, then the parameter value along with the parameter name is going to be recorded in the request object. So again, this is the root template. A HTTP request was just sent to the server through Postman, and it is a HTTP delete method, right? So therefore, it matches this root template. Why it matches the root template? Because I specified /employee/101. So this root template is matched. And also because third, the HTTP method also matched. Therefore, this endpoint handler is invoked. And also when there is a match, as I mentioned, the root values property in the HttpContext.request object records, or let's say stores, the information about the parameter, the root parameter name and the root parameter value, so that our middleware is able to use that information. So let's change our code, try to reflect that. So instead of deleting an employee, I'm going to say delete the employee. Okay, and then I'm going to use string interpolation to specify which employee is going to be deleted. And here, let's remove the breakpoint, and I'm going to say context.request.root values. And let me minimize this here. Okay, so I don't need to determine whether root values ID actually exist, because this is a required. If it doesn't have a match, it's going to go to the 404 not found, right? So if there's no match, this endpoint handler is not actually going to be triggered. So I don't actually need to try to check whether this parameter and its value actually exist in the root values property here. I know it exists. So I'm going to run it, and I'm going to go to Postman, try to execute it again. So this time, maybe let's change to 102 and then click on send. All right, we got a 200 OK status code, and then I got a HTTP response body that shows me delete the employee 102. So this is the correct HTTP response body that I am expecting. Okay, so let's try something else. Let's try to go over here, and then if I say, okay, I'm going to remove this S, right? So let's try to see the literal segment to see that whether this can match, right? So if I click on send, so we got a 404 not found. So the literal segment has to match exactly. But the case doesn't really matter because we're using a lowercase e, but the template, okay, the template is also lowercase e. But if I try to use uppercase e here, I can still get a 200 OK response with the correct message over here, right? So the case is insensitive. But if I do something like this, right, and then click on send, you can see that we got a 404 not found, which means there's no match, okay? But if I add something here, add another required root parameter, and I'm going to call it position. Now, if I run it with debug mode, let's run it. Okay, and then go to here and click on send. Going back, pay attention here. We got two root parameter segments, and that is going to go into the context object. So quick watch, and then go to request, open it up, go to root values. You can see count equals to 2, and there's no surprise. We see position 102. ID ABC. Well, it's the reversed order, but that's because here first one is 102, second one is ABC, and that they're all mapped to this position correctly. So 102 mapped to position, ABC mapped to ID. All right, so in this video, you have learned the required root parameter concept, right? We have the root template concept first of all over here, and the root template has the literal part as well as a parameter part, variable part, and a required root parameter is specified with a curly brace and the name of the parameter inside it. And in order to map or match this root template, the literal part has to match exactly, and the parameter part doesn't really matter, but there has to be the same number of segments. We also talk about the differences between root parameter and query string. Root parameter is cleaner, it's better for SEO, search engine optimization, and it's user-friendly. So that's everything I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one. In this video, let's talk about required root parameters with default values. So previously, we talked about required root parameters. So for example, we have this root template that has a required parameter, which is size. So which means that in order to map or match this root template, you have to have a root path that is something like /categories/1 or /categories/media. So you have to provide the size segment. But what if you want to ignore that size segment but expect it to be populated with a default value? For example, if I just want to from the browser go to /categories, but then when I do that, I expect the server to take me to /categories/medium, which means that the medium, this word, is the default value of the size parameter. In that case, your root template has to be written differently. So you use curly braces as per normal, and then you say you provide the parameter name. Now you use equal sign, and then you provide the default value, which is medium in this case. So this is the syntax of providing a required parameter in the root template with a default value. Basically, it's just curly brace, parameter name equals parameter's default value. So let's give it a try in our application here. Let's create a different endpoint handler. So endpoints map to map get and /categories and size. So when I do this, you would definitely have to provide the size parameter value. But if I say size equals to medium, and then I'm going to say get categories in size, and then I provide the size value over here, then let's run the application and go to /categories. So run it first. All right. And then let's go to /categories. Now you can see that it doesn't actually redirect us to /categories/medium. It just uses medium as the default value immediately. But if you provide actual value here in the root path, then that actual value is going to be used. Change to small, then the value of that parameter becomes. So with default value, you can have your root template map to a path without providing that segment. That's the purpose. And also, you have flexibility of making more than one segment use a default value. For example, even the categories, I can say that the categories can be even provided. And let's say the default category is shirts. So imagine that we are creating a e-commerce or web application, and we need users to provide us with information in order to retrieve the product information from the backend database. So here we want the user to provide categories and then provide the size. With this /categories/size, we provide some default parameter here. And when we do that, guess what? The default root path will be mapped to this. Right? So let's give it a try. Now, you no longer see the 404 not found dummy page anymore. You're seeing this because the default path is matched to this, right? Because you're not providing anything, the first parameter, therefore it's going to use shirts. And then you're not providing anything to the second parameter, that's why it's using medium. So what you see here, right, is basically just /shirts/medium. This is what you got. Okay, so in order to make it more obvious, we're getting category. Which category? We're gonna spell out that category. So put this one here, and then here I'm gonna say degree. Yeah, let's change this to category, which makes more sense. Okay, so category and size. And we will be seeing category, both category, right? And this is equivalent to /shirts, right? Let's say we're gonna change the one to large, then this one becomes large. Let's say we change this one to computers, right? Then the category becomes computers and size become large. Well, we don't have a large computer, but you get what I mean. With this flexibility, there's some limitation here. So the limitation is that the default value can only be used as the last segment, right? So either you don't provide anything for the entire path, which is mapped to this root template, or you provide the first one, leaving the second one empty, so that the second one can use the default value. What you cannot do is to just provide the second one without providing the first one. So again, you don't have to provide anything, that's okay. But if you provide something, then you have to provide the first part. So imagine I change this to even more complicated. So category, size, and the last one is, let's say, ID, okay? And the default one is 0. So now the rule becomes this. You either provide the first parts, leaving the rest empty. And when you do that, the first segment is going to be whatever you provided, and medium is going to be used for the second one, and 0 is going to be used for the last one. Or you provide these two, right? Leaving the last one. So you always have to leave the last one or the last ones to use default values. You cannot provide these two segments and expect this to be populated with the default value. So let's give it a try. All right, so we have this, which corresponds to, so shirts, medium, and 0. We're not showing 0, but this is what it is. And you can do shirts, then the size uses the default value. And you can do large, then the ID uses the default value. So we better have to show ID as well so that we can see exactly what I mean. Okay, so here, and ID is ID, copy and paste this, and paste this over here, and this is ID. Okay, so we have some error here. It's to be removed, and try again. All right, so by default, everything uses the default value. So we have shirts, inside medium, ID is 0. So shirts, medium, and 0, they're all default values. So this is what I'm saying. You have to provide your value at the front. So I'm going to provide shirts, then use medium and 0 are the default value. Maybe we change to computers. Now computers is used, and going to remove this. We only provide it per computers, leaving the rest empty. And the rest will be taking the default value. Now you can also provide the second one and leaving the last one empty. So the last one is going to use the default value. Of course, you can provide all of the values. So here I'm going to provide 9, and the last one is also going to use the value that is provided here. But you can now say, okay, I'm going to only provide the size as well as the ID, and I expect the first root parameter to be using the default value. So when I do that, this is going to be mapped to the first segment. This is going to be mapped to the second segment and leaving the last one empty, which means the ID is going to be 0. So let's try. I'm going to hit enter, and now you can see category is large, size is 9, ID is 0, right? So you might be saying, okay, that's because you forgot about the slash. So what if I just put slash here? So that's the logic here, right? For the first segment, I didn't provide any value here. For the second segment, I provide large. And for the third segment, I provide number 9. And if I do this, guess what? Not found, 404 dummy page. So this is not valid, right? And if you just delete the slash here, then what you get is a wrong mapping. So that's what I'm saying. So if you have multiple segments like this, then you have to make sure that you provide your hard-coded value at the front, and you leave the segments that you want to use a default value at the end. And I hope that's clear. If any questions, please let me know. If not, I will see you in the next one. In this video, let's learn about optional parameters. So let's go to the previous lecture and copy this root template and paste it over here. So this root template that I just pasted, this is to specify that we have two different root parameters that have default values. Let's say that I want to make the last parameter segment to be optional. Then how do I specify that? I use curly braces. I specify the parameter name and then followed by a question mark. So this makes the root segment here, this root parameter here, optional. This is actually pretty similar to required parameter with default values. In this case, this segment is also optional. You don't have to provide it. However, there's a difference. In this case, if you don't provide it, then there is a default value for the parameter. But for optional parameters, in this case, if you don't provide this optional segment, then the root parameter doesn't get any value, as if the root parameter has never existed. So let me go into Visual Studio and show you exactly what I mean here. So this is the source code that we used in the previous video. Let's say that we keep the categories as default value, we keep the size at default value, but for ID, instead of use a default value, I turn it into an optional parameter. Now I'm going to set a breakpoint over here, and then I'm going to just run. And the default is the home page, right? The page that is just launched right here is the home page, and our breakpoint gets hit. Why our breakpoint gets hit? Because these first two segments get the default value and the last segment isn't actually required. Therefore, the ID root parameter doesn't get any value. So let's actually see what is happening inside the context object. Examine this and go into request, and then let's go into root values. And now you can see that instead of 3, we only have 2 root values, key value pair. So we have category, which is shirts, and we have size, which is media. And now notice that we don't have an ID, right? The ID doesn't have a default value, as if the ID root parameter doesn't actually exist. So this is what happens when you have an optional parameter and we don't specify that optional parameter when sending request, then that optional parameter doesn't exist to the server, right? You can see that in the context object, it doesn't exist. So that's the difference between optional parameter and a required root parameter with default value, right? The required root parameter with default value, when not provided, will always get the default value. Whereas for optional root parameters, if you don't provide the segment, it will behave like it never exists. So that's how it works. That's the difference between the optional root parameters and required root parameter with default values. And this is how you specify it. One thing I also need to emphasize is that optional parameters, just like the root parameters with default values, you have to specify it at the end. You cannot specify it when it's in the middle. So let's actually stop debugging and change the code a little bit, which is actually very similar to what we have gone through in the previous lecture. I just want to show you quickly. Okay, so if I run this, you can see that the category gets the default value, the size doesn't exist, the ID doesn't exist, therefore it's all blank here, right? And if you want to use optional values for size, then you have to make both of these optional. Right? So for example, I say computers here without specifying the rest of the parameters. Then I get the parameters here and size is empty and ID is empty. Actually, they don't exist, right? And if you want to leave out ID, then you have to specify size. Let's say a large computer, right? And then size get large and ID still doesn't exist. And of course, you can specify ID like this and then ID gets 0, okay? But if you don't want to specify the size segment, but want to specify the ID segment, that doesn't make sense. It doesn't exist. Okay, so if I just delete large, this is not a correct path, and you get HTTP error 404. And if you don't provide any of them, then size doesn't get it, ID doesn't get it either. If you put 0 here, then size will get 0. So this is the same logic as what we mentioned in the previous video. In one word, if you want to use optional parameter, which means you want to leave out that optional segment, then that segment has to be at the end of the path. Or you can leave out multiple segments at the end of the path. And that's what I want to talk about in this video. If any questions, please let me know. If not, I will see you in the next one. In this video, let's learn about parameter constraint. So instead of talking about theory first in this lecture, I actually want to jump into Visual Studio and directly show you some examples. And then we are going to come to the theory part. All right, so let's go to Visual Studio and let's copy, let's say we're going to copy the first one. We're going to use map get endpoint, and we are going to use parameter here. So the first one is going to be ID, and then I'm gonna say I'm getting employee. Which employee? I'm getting the employee with ID. And of course I cannot just use ID here. I have to use context request root values ID. So I'm going to paste this over here and change. Okay, so that's the first endpoint, and I'm going to copy this and paste it just below it, and I'm going to create another, and this time I'm going to say name. So here, I'm going to say get employee, and then I'm going to spell out the name of the employee. All right, and I'm going to run it right now and see what's going to happen. The default one goes to the categories, size, and ID. So let's go to use employees, and now I'm going to say 1, okay? Or whatever, you can say 10. Hit enter. Now we get an exception. An exception is ambiguous match exception. The request matched multiple endpoints, and it actually tells you which one is having a problem. So obviously here we have a root template with 2 segments. First one is a literal segment, and the second one is a root parameter segment. And we have this endpoint also has 2 segments. First one is literal, the second one is a root parameter. And then it just happened to be that the first segment, the literal segment, are exactly the same between the two. The second segment, although the root parameter name are different, but the root parameter happen to show up at the same place, which is the second segment. So to ASP.NET Core, these 2 segments are no different when it comes to matching root templates. /employees/ID is going to be mapped to this one and this one. /employee/ let's say /Frank is also going to be mapped to this one and this one, right? So let's actually give it a try here by specifying a name, let's say my name, and you're going to see that it says that this matches employee/ID and also employee/name, and also this one, right? Because it has an optional parameter at the end. So which one's supposed to be matched? We don't know. That's why we need a feature which is called parameter constraint. So here, this ID is supposed to be an integer. So how do I specify and say that this segment, although it is the second segment, has a parameter and it show up here, here, and also here, then I can say that this one has to be an integer. Okay, so I'm going to say integer. And with this simple change, we're going to run it and see what happens. Go over here, and you can see that with /employee/Frank, it goes over here, and there's no problem. And if I say 10 or 220, it goes to here, and no problem. So this is what we call root parameter constraint. We're using a parameter constraint here to say that this particular root parameter is only of the type. So we're constraining the data that is provided to the segment. And in doing so, we're helping the root templates to be distinct. Because previously, they are not distinct. They are basically considered as duplicates. We have duplicate root templates and cannot be matched. Now, because I specified a constraint, therefore, this root template and this root template are now distinct. Because this one has to be integer and this one is going to be just a string. So that's the purpose of parameter constraint. Parameter constraint is used for the purpose of making root templates distinct. That's the main purpose. The second purpose is sometimes with the help of model binding. We're going to talk about the model binding in the next lecture. With the help of model binding, developers will get a parameter that is already of the type that is specified right here. We don't have to manually convert from a string type, because without specifying the type, everything that we got is going to be of string type. So that's, or just object, right? So that's not very convenient. And if you specify it to be integer, and then in model binding, you also specify it as integer, then you automatically receive that variable as integer value. So that's just a convenience, but the main purpose of having parameter constraint is to make the root template distinct. However, I would argue that if you design your root templates better, you can make it distinct without having to use a root parameter constraint. For example, this one, /employees/ID is fine. Here, /employee/name, you would first of all argue that this doesn't have to exist, right? Why do you have to use a name to get the employee? A name can be duplicates. Someone called Frank Liu, another person could be called Frank Liu as well. So this, first of all, shouldn't exist. And if it does exist, then you can use some literal part, for example, /employee/names, just for example. This will make the two root templates distinct. You don't need to get the help from defining a constraint, right? Although this doesn't make much sense, but I'm just showing you that if you design your root templates better, you can avoid having to use parameter constraint. Okay, but since this lecture is about root templates constraint, we are going to jump into browser and let's search root parameter constraint in ASP.NET Core. Right, and you're gonna see this is C#. So let's go into routing, and this is a big article, and let's search constraint, and we get constraint, and click on this root parameter constraint, and we're coming over here, close this. So you can see that we have these constraints over here available for us. And the first few are types, right? Integer, boolean, date type, decimal, double, float, GUI, long. So all of these can be used exactly like what I showed you. Right? ID is integer, active is boolean, right? You just use your parameter name first, followed by a colon, and then the parameter constraint itself. So all of these first few, this is first 8, are of the type constraints. And then the later ones, and most of them are functions. So this is like to say that the string must be at least 4 characters when we do this. Maximum length, the length of the string again. So this is exactly, right? And you can actually apply multiple constraint. For example, if we say username, minimum length is 4, maximum length is 8, then you can say something like, let me bring up Notepad. Okay. So here, let me copy this and paste it here. So we can say minimum length 4, and then add another colon, and I'm going to say maximum length, right? So max length 8, like this. You can combine multiple different constraints, and also you can use regular expressions over here. These are the different constraints you can use. Okay, so multiple ones, they're actually showing you, right? So ID is integer, but it has a minimum value. They have regular expressions, so you can read this article. I'm not going to demonstrate every single one of these different things. It's very easy to apply. Just remember, we use ID with a colon and then the constraint. And if you want to have multiple, you add another colon and add a constraint. And that's it. But what I really want to emphasize is that the constraint is not really necessary unless you didn't design your root template good enough. Okay? If you design it well, you can actually avoid using root template. But sometimes I do like using something like this so that it helps me with a model binding. When I use model binding, I will automatically get ID as integer. Another thing, very important thing, is that if this is not satisfied, let me remove the second one. Let's focus on this single one. So if I provide /employee/ABC, which doesn't satisfy this, it isn't matched to any other endpoints, then guess what's going to happen? It's not going to throw you an error. It's going to route you to the 404. So let me show you. Let's run the application. All right. So let's do /employees/ABC. And I hit enter. This, of course, is mapped to the categories one. Categories. So let me comment out this first and then run it again. All right. Let's do /employee/ABC. Now You can see that it goes to error 404. Right? If I change it to 1, then it goes to the correct endpoint. So as you can see, the root constraint is really helping you to map the request to the endpoint. But if it doesn't find the map, if the constraint is not satisfied, then it considers this as a resource that cannot be found on the server. So therefore, you cannot use this to validate user input. If you expect user to enter this part of the segment and then use constraint to validate it, then what really should happen is to use spit out the error message saying, hey, this ID doesn't exist. But because this is part of the routing system, right? A routing system, when it doesn't find a match, what does it do? It gives you the 404 not found error. And this is confusing to the end user. The end user might be thinking, okay, I'm entering something wrong, or maybe I entered the URL wrong. It's just confusing. The user doesn't know which part is wrong. You should never use the constraint to validate user input. In fact, I would argue that you at least shouldn't allow the user to enter any information on the screen and then use that as part of the URL, because in that case, you really have to validate the user input. And if you validate the user input on the page itself, that's okay. But if you're relying on the constraint to validate, it doesn't make sense. Okay, that is what I want to talk about in this video. If any questions, please let me know. If not, I will see you in the next one. In this video, let's talk about custom parameter constraints. So let's take an example. So I'm going to write a root template for the purpose of getting all of the employees under a certain position. So there are different ways to write it. For example, if I am targeting the employees, then I can start with employees and can say /employees /positions and /a position. So the last part is a root variable, or root parameter here. Of course, you can write it differently. For example, if we're targeting position, you can say /positions and then the position parameter and then /employees. So let me write it differently. Okay. So /positions /position parameter /employees. So both ways make sense. It depends on from which angle you're looking at it. Are you looking at employees or are you looking at positions? To me, the second way makes more sense, but since we have been targeting employees in this course so far, so let's use the first one, /employees /positions, and then the last segment is the root parameter. Now, let's say that in the application that you are creating, you are only targeting two type of positions. So there's only two type of position makes sense. The first one is the manager, and the second one is developer. No other position makes sense. So which means that this position that is provided at the third segment here has to be either manager or developer. Of course, case insensitive. It doesn't have to be a uppercase M. So in this case, you can use a custom parameter constraint. Of course, you have to create it yourself. And in this video, I'm going to show you how to do that. But before we go ahead and working on creating a custom parameter constraint class, I want to emphasize that it is highly possible that you don't actually need to have this constraint. As long as you design your root template well. This is not necessary. You don't have to have a constraint here. Again, the constraint is mainly for the purpose of making your root template distinct. So as long as you have a good design with distinct literal part at the front, right? At the front, then you most likely don't need a custom parameter constraint. But for whatever reason, you just need it. Then here is how. First, let's go into Visual Studio here. And then let's create a class. You can come over here and create a folder, right? And then create a custom constraint under the folder if you have more than one constraint. But in this lesson, I'm going to just show you right here. I'm going to just create a class right here. I don't even need to create a public class because I'm going to just use it in this file. Right, so I'm going to call it position constraint. You can call it anything, but whatever you call it, the class has to implement the iRoot constraint interface. Now, to implement the interface, you do a control dot on your keyboard, or you can go over here and go to quick actions and then click on this. So control dot basically just opens the quick actions directly. So this is a shortcut, a keyboard shortcut. So I'm going to hit enter to implement the interface. And there's only one method that needs to be implemented, which returns a boolean, actually a function, not a method. And here, if the request matches the constraint, then you return true. Otherwise, you return false. So then how do you determine? In this function, you can see that the root key is passed in and the values dictionary is passed in. Of course, even the context object is passed in. So if you want to make more complex comparison, you can use this full HTTP context. But if you're just checking the root value, then you can use this and the values. Just these two are good enough for you. So let's try to use the root key and the values in this video. So we are using the requirement that the position has to be either manager or developer. So in order to do that, first of all, we need to check that we actually have the root key contained in the values dictionary. So if it's not there, we're going to say values dot contains key, right, and the root key. So if the values dictionary doesn't contain the root key, then we are going to just return false. Right? We're going to return false directly. Don't have to do anything else. Secondly, we want to see whether the root key, although it contains, it could be null, right? So if it's null, I'm going to also return false. Why it can be null? Because this values, if we look at this, you can see that why it can be null, because this is an object. It's not a string. So we want to be more careful. So we can use the second condition here. Now we can do string comparison. Right? Very simple string comparison. So if values root key toString object, you have to do toString equals manager, and I'm going to do string comparison ordinal ignore case. So if the root value that is passed in is manager, or if the root value that is passed in is developer, then we're going to return true. Okay, so the second one is developer. And in this case, what are we going to do? We are going to return true, not false. Otherwise, we're going to return false. Here's green squiggly line here. Actually, if we have done this, the green squiggly line shouldn't be showing here. And even though it's showing right now, I don't need to worry about it because, it's not null. So if this object is not null, it's going to have no problems to connect with dot to string. It's going to be converted to string. Whether it's equal to manager or developer, that's a different story. But our logic covers that. So I'm not worrying about the green squiggly line in this function. Okay, so now we have this class implemented. The next one is that we are going to try to use it. But before we use it, we need to register it ASP.NET Core. How do we do that? We use the builder object. So builder.services, and here we're going to add routing. And this one contains two different signatures. One, we're going to use the one with options in order to configure the routing. So here we're going to say options dot constraint map. I'm going to add a constraint to the map. And first of all, I'm going to give it a key, which is the name of the constraint. You can call it position. I'm going to just call it POS, which stands for position. And then here I need to provide the type of the custom constraint that I just created. So what did I call it? Let me scroll down here. So position constraint, that's what I call it. So I'm going to say position constraint. And that's basically it. By doing this, I just added my position constraint to the constraint map. and then I can just use it. I can reference it by name. Okay, so let's add a get endpoint. Let me just copy and paste this first, paste it over here. Let me also try to maybe delete this, and then coming over here, we are going to change this to say get employees under position, and we're going to change this root, so it's going to be employees slash positions slash, and the root parameter I'm going to call it position, and the constraint is POS. So this is the name that I just provided here, right? So I'm referencing this constraint by its name, or maybe it's called a key, right? Here it's called a key, but the key is actually the referring to the map. So you can just call it a name. I'm going to call it name. So this is the name of the constraint, and I'm using the name of the constraint to refer to that constraint. Then it's going to be used here. And here I'm going to say get employees and their position, and we are going to reference the position root parameter value here. I'm going to display that right here. Okay, I think we did everything, and we can give it a try. I'm going to copy this in my clipboard, and then I'm going to run it. Okay, so I'm going to paste whatever I have in the clipboard. And now here, I know that value should be manager or developer, but if I just type in dev, then what I'm going to get is 404. Remember, that's the correct response, right? So if the constraint is not satisfied, it is like it doesn't find the root template. Therefore, it goes to the not found 404 dummy page. So what if I go to developer? Now it got a match. So we're seeing this correct message here. And if I go to manager, of course, I see the correct response. But if I say manager of HR, hit enter, I go to 404, right? And if I just run it, right, with debug mode, and I'm going to do the same test. So go to manager. Now we can see that we have the root key position, and we have the root values, which contains only one, and that is for position, and the value is manager, right? So our logic and comparison here will definitely work here. Because it's manager, therefore it's going to satisfy this condition, and it's going to return true, exactly returning true right now. And we'll go running that, we'll get the correct response. And if we do anything else, let's go here, we are not going to satisfy this, it's going to return false. And therefore, we're seeing the 4. Again, like I said, if we can design this well enough, we don't need to really worry about validating this, the constraint, because the URL in your application is generated by yourself. Right? You are not going to put a URL in your application that doesn't actually exist, doesn't lead to any page. You as a developer have control over which URL the user is going to click on, unless the user wants to enter the URL by themselves. In that case, if they enter something like 000, which doesn't work, that's a user error, right? You don't actually need a constraint to check that. So that's why I'm saying that usually you don't need a constraint, especially custom constraint. It's really used. But in case you need to use it, you need to follow 3 steps. First of all, you need to create a class that implements the iRoot constraint. Secondly, you register it right here. Very simple stuff. Give it a name. And then you reference the name and use it as a normal constraint, just like integer, date time, or whatever. You use it, a constraint. And that's it. And that's everything I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one. This is a assignment video where you are required to implement CRUD operations with proper routing. Previously, in the chapter where we talk about HTTP protocol, we actually have implemented CRUD operations. So let me grab one of the source code files, and I apologize, this is in text format. This is what I attach to each lesson to provide source file to you. But in here, you can see that although this is in text format, it doesn't have color coding, but you can see that when we are targeting the employee's path, we are handling get, right? We are handling post, we're handling put, and as well as delete. So in this assignment, what I would like you to do is to implement similar CRUD operations for creating, loading, updating, and deleting employees. But the difference is that since that you have learned routing and route parameters, I would like you to use what you have learned in this chapter to re-implement it. In other words, you're going to use endpoint middleware, create multiple endpoint handlers, similar to what we have done in here, but with actual code, so that you can add to the in-memory database. Right? So let's go back to the source code again. We have this in-memory database, or I should call it data store here implemented, and we have the definition of the employee object implement right here. So reuse these two classes to provide the data store functionality, and then use in-memory data store to actually implement creating, reading, updating, and deleting employees. And for reading, I would like you to read all of the employees and have another endpoint handler to read just the employee like provided by the ID. Okay, that's everything you need to do in this assignment. I will see you in the next video where I show you my solution. I'll see you in the next one. Okay, in this video, we are going to implement the CRUD operations with proper routing. So let's jump into Visual Studio, and I'm going to clean up the code a little bit. We are not going to have these middlewares. Of course, we need the routing over here, so let's delete this one, and let's delete this one just to clean up. We don't need the custom constraint, so let's delete it, and then let's try to see. So this is by position, we don't need it either, and we have a actual, not actual, we have the get by ID, and we're going to move this to the top, so just below get all the employees. So we have to map get, and then post, put, and delete. Okay, so we have everything right here, and we don't need the custom constraint. Let's delete this class. What we need to copy from the source code. So let me show you the source code over here. So I'm going to copy the repository, which is the in-memory data store, over here. Paste it here. Okay. In fact, I actually want to implement it properly. So I am going to actually create a folder, and I'm going to call it data. And I'm going to create the employees repository class. First of all, the employee class. If we really want to implement everything properly, the employee class should be under the models folder. So maybe let's, instead of call it data, let's call it model. Let's call the folder models in case we're going to have some other models in the future. So for now, we're going to just implement the employee class here. So click on add, and then go over here and just basically cut this class right here. Now we are going to create another class, and this one is the employees repository. Okay, and go back to program.cs. We are going to cut this entire thing and paste it right here, because this is in a different file, so I'm going to put public over here to make sure we can access it. Go back to employees, make sure it also has public. All right, so we are good now. Now let's close these two files, and let's go to program.cs and try to implement all of these. All right, so let's actually copy from what we had before, just to save some time. So if we read the source code here, this one, we don't need it. But perhaps we need to handle the root path. Otherwise, every time we run the application, when it goes to the root path, because the root path is the default one, right? So it's going to show us 404 not found, the dummy page. So let's actually copy and paste this, just basically duplicate it and have it targeting our root path. And here we're going to just say that welcome to the home page. All right. Now we're going to implement this endpoint where we are going to get all of the employees. Okay. And this is going to be based on what we had here. This part, if ID exists in the query string, that's get employee by ID. We're going to, actually looks like we have some issues here. The status code is assigned at the bottom. That's kind of weird. We probably didn't test this before. It wouldn't work in that case. So anyways, I'm going to just paste it right here. So modifying the HTTP header should happen at the top. So let's put the status code right here. Actually, we can delete it. Okay. So by default, when there's no problems, it is always HTTP 200. Okay. So first of all, we get all of the employees, and then we set the header. Right. The content type header can be set this way, or can be set differently. Just say response.contentType because this is often used. Therefore, there's a separate property. Okay, so we show everything in an ordered list. Okay, we implement this and let's give it a try, actually. I don't want to implement everything and then try it at the end. Give it a try and our homepage works. Let's try to check employees and our employees page also work. What I want to do here is I want to give this page a title. So here I'm going to write something maybe H2, and then I'm going to say employees so that users know that this is the employees list page. And also perhaps we want to have a actual line break here, and let's run it again and go over here and try to go to employees page again. And we have the employees title display right here and also list of. All right, let's go to the next one, which is get employee by ID. And let's go to our source code here. And that one is right. Okay, let's copy this and paste it right here. Minimize the solution explorer and paste the code right here. Now we are not going to get the ID from the query string, right? Because as you can see, we have the ID right here as a root parameter. So where do we get the root parameter? The root parameter is in the request object dot root values. And when the code runs over here, the constraint, the root parameter constraint already passed. That means we're going to have an ID for sure, and we know the ID is definitely an integer, right? So we don't need to use try parse. What we can do is we can just say var employee ID equals parse. I'm going to parse ID to string, and I'm going to remove all of that, and we don't need the curly brace. And then okay. Now the employee ID is passed over here. We got all of the employees. The content type is this, and then we output name, position, salary. And if there's anything wrong here, right, employee is not loaded, then we display employee not found. Let's try again. All right, so let's go to employees /1. Okay, we're showing name, position, and salary. Perhaps we're going to give it a title again. So let's copy this. I'm going to actually remove this line break because after testing, I think we don't need it. Copy that and paste. So this is going to be the employee page. Okay, and let's rerun it. Make sure it still works very well. Go to /employees let's try /2, and we can see the employee information is listed right here. Okay, now let's go back and try to implement this map post. Okay, so we are going to go to the original code over here and then go to the post method. I'm going to copy this whole thing and come over here and paste it. Okay, so everything is very similar. I mean, actually, this is going to be exactly the same as before. We probably don't need to do anything. Yeah, we don't need to do anything. So let's hold on testing. Also implement map put endpoint. Go over here, copy this, and put it over here. And this should be also exactly the same. Now we have the map, and let's also copy and paste that. This over here. This one is similar to the get by ID method, right? So let's scroll up over here and let's copy this code. We're getting the ID and scroll down, and I'm gonna paste this code. So we don't need all of this code, and we don't need this curly brace. So let's delete it, reformat this code. Now we have the employee ID, but we don't need the try parse and this curly brace as well. And let's reformat it again. Okay, so we have this simple authorization that looks for the authorization header, and it's hard-coded as Frank. So you can change this, change to your own name, for example. And now we use our delete employee method, and everything should work in the same way as before. So let's give it a try, and I'm gonna try the delete endpoint, update endpoint, as well as post endpoint. Okay, so let's run the application, and let's bring up our postman. So let's go to get employees and on the send button. Now we see these 3 different employees, right, in HTML now, and these are the default employees. And we're going to add another one. Let's go to add employee. Make sure that you're targeting the correct port number because the port number has changed, right? And because we only have 3 by default, we're adding the 4th one. It's going to be Tom Anderson. And let's click on send button. And it says employee already added successfully. And let's run the get employees again. And we see Tom Anderson added as the 4th employee. Let's update the 4th one. So we're going to update Tom Anderson. And software developer, let's update the salary. So maybe let's update the manager, the position as well, and update it from developer to manager, and maybe raise the salary a little bit, by a lot, so that we can see the difference. And click on send, and you can see 204, no content. And that's exactly what we expect. And let's go to employees. Actually, we should be able to see the difference, right? So this is the previous one, which is software developer. Let's click on send button. And now you can see that it's updated to manager. Now let's go to delete employee. Again, the port number needs to correspond to this new application, right? And we are going to delete the 4th one. And let's try the authorization. Let's provide with the wrong name here. And it says you're not authorized to delete. So let's change it back. And let's say provide number 40 and click on send. It says employee not found, 404 not found, right? So that's correct. Now let's try to delete the 4th one and click on the send button. It says employee is deleted successfully. Let's go back to get employees and try to click on send. So this is the previous result, right? We have Tom Anderson as the 4th employee. Now let's click on the send button and we see 3 employees. And if we go to the home page over here and try to search for employees, we only see 3 employees now. So looks like our implementation works. And with this implementation, you can see everything is clearer, right? Because before, what we have is like this. We have everything with all of the logic in one middleware, this one. And that's not clean enough. So here, this is much better. We have the routing middleware. We have this endpoint middleware, and we created many endpoints inside the endpoint middleware. Later, we're going to learn how to organize the code, but so far, it's already much cleaner than before. Let me try to empty lines. All right, that's everything I want to show you in this video. You can definitely implement it in a different way as long as all of the functionalities are implemented. And thank you for watching. I will see you the next video. This is a new section. In this section, we are going to talk about model binding and model validation. And in this first video, we're going to talk about what is model binding. First of all, we need to know what kind of problem model binding is trying to resolve. So let's actually jump into Visual Studio and go into our previous code and try to figure out what kind of problem we are having. So if we go to any places where we're trying to extract value from HttpContext object here, you see this one, we're taking the ID from the root value, right, inside the request object. And there are other places where we're doing the similar thing. For example, from the delete, we're doing the same thing. We're going to the root value and take the ID from it. If we go into the HTTP put or HTTP post, we take a lot of efforts here reading the employee information from the body. So we as developers, instead of focusing our energy on implementing the business logic, we're taking a lot of energy trying to implement some technical details that should have been implemented by the framework. You see, the framework is there to eliminate this kind of work for us. The framework does the technical details, whereas developers focus our energy on implementation details of the business logic instead of the technical problems. So these technical problems where the data should be extracted from one data structure to a different data structure to provide to the developers to use, these type of work should be done by the ASP.NET Core framework. And indeed, ASP.NET Core framework offers such functionality, and this is what we call model. So let's try to define model binding. Here we are extracting data from the HTTP body. Here we're trying to extract data from the root value. And you can see a pattern here. When we try to extract data from the HTTP request into a .NET object here, we have ID here, and in the case when we post data, we have the employee object here. So these are all .NET types. And when this happens, we're trying to do model binding, but this is not exactly the model binding. What we refer to as model binding has something to do with the endpoint handler. You can see that we have the endpoint handler right over here. For the map get, we have the endpoint handler right over here. And for the post, we have the endpoint handler right here. So the best case scenario is we don't even need to do anything about the data. The data should be passed into the endpoint handler, because you know that endpoint handler in ASP.NET Core is a function or a method here, right? As you see here. So, which means that it has its own parameters. And best case scenario is that ASP.NET Core should take the responsibility to extract the information from the HTTP request and feed that information through the parameters of the endpoint handler function or the endpoint handler method. And this is what we call model binding. So that's the definition. So I'm putting it on the screen here. Again, the definition is to extract data from the HTTP request to .NET objects as parameters in the endpoint. So this is what we call model binding. So now let's go on to the next topic of what are the sources of the data, right, in the HTTP request. And we all know that we have already gone through this. We have root values from the HTTP request. We have query strings. We have headers and we have body. So those are the 4 different sources of the data where we extract data. So these 4 different sources where ASP.NET Core model binding extract data from. Now, how does ASP.NET Core actually implement the model binding process? It first look at the parameter. So let's actually try to do model binding. So let's take this as an example. Instead of using the HTTP context, we use a different signature here. So first of all, we need to provide a root template, which is the same thing as before. Let's paste this over here. Secondly, instead of using the HTTP context over here, we directly use the endpoint handler. So we expect the ID to be passed in through the handler here. So therefore, we're going to say int ID, and then I'm going to use a lambda expression, and then we're going to do whatever we need to do inside it. So by doing this, you can see that we basically skipped over the parsing here, right? The extracting and parsing here. We can do the rest of the things, and the rest of these are related to business logic. This part of the technical details is already covered by ASP.NET Core. So let's go over this again. We have a lambda expression which represents the endpoint handler, and the endpoint handler is a function or method here, and it has a parameter. So how does the ASP.NET Core work here? The ASP.NET Core looks at the endpoint handler, and it sees that it has a parameter, and then it goes into the HttpContext.request object, right? The HTTP request object, and try to find a corresponding data source. In this case, it goes into the root values and it sees it. Other places we have already talked about, if they don't see it in the root values, it could go into the query string or the headers or the body. So this is how ASP.NET Core model binding works. Again, it first look at the endpoint handler and take one parameter, and then it looks for the corresponding data inside the HTTP request object. And because of this sequence, right, it first look at the parameter and then goes to the HTTP context.request object. We are usually, when we talk about ASP.NET Core model binding, we're saying that we are binding, for example, this one. We're binding this parameter to the root value, right? Instead of the other way around. That's usually what we say. But it also makes sense, generally speaking, it makes sense to say that we're binding from the HTTP request object to the parameter, right? This is how data flows. Data flows from the HTTP request object to the lambda expression, the endpoint handler. But because how ASP.NET Core works here, it actually first look at the parameter and then looks for the source. So people usually say, you will look at many articles or documentations from Microsoft, they're saying that they're binding the parameter to the corresponding data inside the HTTP request. I just want you to be familiar with this way of expressing things. But personally, I think both ways make sense, and especially I think it makes sense to follow the flow of the data. But because this is what Microsoft and others out there are saying, they are saying that we're binding the parameter to HTTP context or HTTP request. So let's follow this approach. We're binding from the parameter to the HTTP request. Okay, so this is the terminology here. And last but not least, let's talk about when does model binding happen. Let's jump into a diagram here. Let's try to draw a diagram. So we talk about routing. Routing is the process to map a HTTP request to a particular handler and then record that endpoint handler information in the HTTP request object, actually the HTTP context object. After that, we execute the selected endpoint. Okay, so routing happens first, where it selects an endpoint, and then ASP.NET Core tries to execute the endpoint. But between these two, model binding happens. So model binding happens before the endpoint is executed. which makes sense because model binding is responsible to extract data from the HTTP request object, and only by doing so before executing the endpoint can it pass the data into the endpoint handlers as a parameter. Okay, so this is when model binding happens. All right, that's everything I want to cover. Let's just summarize very quickly. Definition of model binding, first of all, is to extract data from HTTP request to .NET objects as parameters in the endpoint handlers. Right? So as developers, we can focus our energy on implementing the business logic instead of the technical details. So ASP.NET Core take care of that. Secondly, what are the data sources? We have root values, query strings, headers, and thirdly, we clarified about a terminology, the direction of the binding, right? So we're saying that typically people are saying we're binding from parameter to the data source, which is the HTTP request, because that's how ASP.NET Core works. ASP.NET Core look at the parameter first and then try to find the data source to bind to. All right, lastly, when does model binding happens? It happens in between these two, right? Between the routing and execution of the endpoint. And that's everything I want to talk about in this video. If you have any questions, please let me know. If not, I will see you in the next one. In this video, let's learn about binding to root values. In the previous video, we have seen this. We created a map get, and we created a get endpoint handler here that maps to this particular root template. And we're using this parameter so that this parameter can be bound to the root value here. This is called implicit binding. In fact, you can be explicit in saying from root, just like this. So when you say this, you basically explicitly expressing that you want to bind this particular parameter to this particular parameter. And when ASP.NET Core sees this, it knows where to find the corresponding data source. But how does it know which root value to use? It uses the parameter name. So you have to have this parameter name corresponds to the root parameter name. Let's actually try to complete this coding here. We have the implementation about returning the employee information right here. We are going to actually just copy the code right here. Let's copy this comment as well. Okay, and instead of using employee ID, we need to use the ID here directly from the parameter. And now once we have the employee information, keep in mind that we are really dealing with minimal API right now. So we don't have access to the context object anymore. And we can directly actually return this employee. And because we are using minimal API, and usually APIs return JSON back to the client. So therefore, when we just try to return the .NET object like this, right? This is a .NET object. It's going to be serialized into JSON directly so that the client can use it. But because the client is actually a browser in this case, therefore, this JSON information is actually going to be displayed directly in the browser. So let's give it a try. Let's run the application and let's go to employees/1. You can slash anything, but it has to be within the in-memory data store. So let's take the first one, which is John Doe. And you can see that the JSON is directly displayed inside the browser, and I'm using Chrome, which has this pretty print. You can check it and you can see that everything is formatted. Okay, and if we go to F12, you will see, let's go to network and refresh it to rerun it and highlight this and go to response tab here, because if we go to header, you don't see the response body. Now this is the response body which contains a valid JSON, and that's why it's displayed in the browser like this. And if you check this, you can see it's formatted properly for you, just for display purpose. All right, so let's go back. Now you can see that we can specifically specify where the data source is for this particular endpoint handler parameter. but the name has to correspond to this. What if you have a different name? Let's say this is ID. We don't call it ID. We call it identity number. Let's just call it this for now and copy and paste it over here. Now let's try to execute and see what happens. All right. Now you can directly see that it throws an exception. It says that identity number is not a root parameter. So you can see ASP.NET Core really tries to find the root value parameter, like the root parameter, directly by following the name. So this has to exist in the root parameter. Otherwise, it throws exception. However, sometimes you may have a name, the root parameter name here, that you really don't want to use. For example, you name this as ID, but here you just want to use identity number, right? Because for some reason it makes more sense in your coding, but ID here makes more sense in the URL. So there must be a way to map these two together, and there is indeed a way. So in the from root, there is a parameter, and you can say name is, in this case, ID. So what it's trying to say is that although this is called identity number, now I'm looking for a root parameter based on the name right here in this attribute. So if I do it this way, then the identity number is different from this. That's not a problem anymore. So let's run it. And now let's go to /employee/1, and you can see we get the correct employee information. If I go /employee/3, I can also get Sam Brown. All right, so that's how you use the from root to explicitly bind a endpoint parameter to a root parameter. And if the name for some reason is different, then you can specifically specify the name like this. Now let's talk about what if the type doesn't correspond to each other. For example, this one is an integer in here, but this one you for some reason want it to be date time. Okay, so let's actually comment this out just to demonstrate this. Okay, so let's say this is a date time, and you just want to return identity number just like this. And if we run it this way, what's going to happen is different from routing. So let's go to employees/1. Now we get a bad HTTP request. So what is this HTTP status code? So let's go to F12 and run this again. And now you can see this is 400. This is client side error. HTTP 400, and the status description of this is bad request from the client side. Okay, so if you recall what happens in the constraint for ASP.NET Core routing, routing, if the constraint doesn't match, what happens is that it doesn't find the corresponding endpoint handler, therefore it goes to 404, not found. In this case, if the data type doesn't correspond to each other, the error that we get is HTTP 400 bad request. It indicates that the user provided the wrong information. So that's what I want to point out right here. So let's delete the code and recover. Now the last thing I want to talk about in this video is that if your root parameter here is optional, right? In this case, you add a question mark, indicates that you don't have to provide the ID here. Then what's going to happen if you don't provide? So let's run the application and observe what's going to happen here. Well, in this case, of course, it's going to actually map to this one, and it's perhaps it's going to throw exception. Let's temporarily comment out this endpoint here and run the application again. And let's go to /employees, and now we see HTTP request exception. This again is a bad request because it says this is a required parameter, right? So this one is required, but this one is optional. So in this case, what you need to do is to make this one also optional. So give it a question mark, then we can continue. But of course, if this is nullable, then this one we're having a problem here. The get employee, you can see the definition of this repository method here. It requires an ID here, right? So of course, in this case, you will have to do something like identity. If identity number is not null or it has value, then this is what we are going to do. We're going to do this. Otherwise, we're going to just return null. And in here, we can say identity number dot value. So we can do something like this. Just to remember that if you have optional root parameter, just make the endpoint handler parameter also optional. So let's run this and see what we get here. All right, so let's go to /employees, and now we see null. Why we see null? Because we didn't provide anything for the identity number, because we didn't provide the ID over here. It doesn't extract value from here to here anymore. Therefore, identity number has no value, and we're returning null, just like this. And that's everything I want to cover in this video. I think I will revert the code like this, and then this will become your source code for this lesson. Thank you very much for watching. If you have any questions, please let me know. If not, I will see you in the next one. In this video, we're going to learn about binding to query string. Let's jump into Visual Studio here. So previously, we have learned to bind from endpoint handler parameter to root values like this. And at that time, we mentioned that this from root attribute is not actually required. So as long as the name of the parameter here in the endpoint handler corresponds to the name of the parameter in the root. So let's change this to be identical. Okay, so this works for root value, and in the same way, it also works to bind the value query strings to query strings. So to demonstrate that, I have to comment out this, because otherwise the root template of this one is going to be the same as this one. So now that I commented out, I can remove this segment of the root template, and now I can go ahead and try to run it. All right, so if I go to here, of course it's going to throw exception because I didn't provide anything. I didn't provide the ID that is required in this endpoint handler here. So let's try. Hit enter. You can see I have the bad request. But if I provide, let's say /2, okay, and then I hit enter, this is going to 405 because I didn't provide the root template. Now, because I didn't provide the root template like that, I'm going to provide it through query string. So $ID equals to, and then I hit enter. You can see that the correct JSON is retrieved from the server side to the client in the browser. All right, so that means the same rule that we talk about for binding to root values applies for a query string. If the name of the query string is the same as the root parameter, I'm not the root parameter, the endpoint handler parameter, then we can use this implicit binding. Otherwise, if the name is different, then we can use explicit binding. So let's say we're going to change it back to identity number, and then copy and paste it over here. Now here we need to use explicit binding. We're going to say from query this time, from query, and then we specify the name. So name equals ID. This time it's also going to bind from the query string, the ID query string, the query string ID to identity number like this. So let's run it, and we will see. So /employees $ID number, let's change to 3 this time. Now we can see that we grabbed the correct JSON. All right. Now another thing I want to mention is that, remember we talked about optional root parameter should correspond to optional endpoint handler parameter. Okay. Remember we add a question mark over here if the root value, the root parameter is optional. Now For query string, because the nature of this URL here is that it's optional anyways, right? So this part, you don't have to provide it. It's a valid URL. Therefore, when you work with query string, it's better to add the question mark anyways, right? Better to add it anyways, and then you have to deal with this thing here to say if identity number has value, then we are going to move this inside. Otherwise, we're going to return null. And then here we're going to change to identity.value. Okay, so this would be recommended to have a optional endpoint handler parameter. So let's run it. What's going to happen here? So /employees, question mark, ID number 3. Then we're showing the correct employee information in JSON. What if I don't provide it? Then I return null instead of throwing HTTP 400 bat request. Okay, that's that. And last but not least, what if I have a root parameter just like this? Okay, I have a root parameter just like this. And I delete this explicit binding. I delete the question mark because it's required. And I just use ID to correspond it. And I delete this. And I delete this. Okay, recover back to normal. Okay, as you remember, at the beginning of this video, we mentioned that the implicit binding for this parameter can be bind to root parameter as long as the name corresponds to that. And this parameter can be also bound to query string as long as the name is the same. What if we're providing the root parameter and at the same time we're providing query string? So let's give it a try. All right, so we're going to /employees /1, and at the same time I'm going to do ID equals 3, and then I hit enter, and you can see that the one that is pulled from the backend data store is employee number 1, which corresponds to the ID in the root parameter. So therefore, the priority of binding is that the root value takes priority comparing with query string. If the information exists in the root parameter already, then the value in the query string is ignored. It's not going to bind to the query string anymore. And let's recover the code back to binding to query string, and this is going to be your source code. And this is the end of the video. If you have any questions, please let me know. If not, I will see you in the next one. In this video, we're going to learn about binding to HTTP headers. Binding to HTTP headers is slightly different from binding to query strings or binding to root values. The difference is that you will have to use explicit binding. Okay? So we talk about binding to query string here. You don't have to specify from query. You can just delete it and make sure that the endpoint handler parameter name is the same as the query string parameter name. Or if it comes from the root value, then make sure that this parameter name corresponds to the root parameter name. Then you don't have to use explicit binding. Now here in HTTP headers, if you want to pass any information from HTTP header to the endpoint handler parameter here, you will have to use explicit binding. So let's give it a try here. Let's change this to ID. And then make it non-optional, right? It's required. And let's just delete this. Let's simplify the code. We don't have to always check whether it's there or not because ID is required. Now let's change this one to ID, and that's it. Okay, here, if we want to bind from the HTTP headers to the endpoint handler like this, then we have to specify header. And now if we want to try it, we cannot just use browser because in browser you cannot specify a header. So let's actually use Postman. All right, our Postman is running. Make sure the port number still corresponds to each other. We have, let's run it. And we see the port number 5291. And in Postman we have 5291. And this one goes to employees. and we need to specify some headers. So let's go to headers and let's go over here. The header, again, the name has to correspond, right? So in this case, the key here has to correspond to the parameter name here. And then we specify, let's say number 3. And now if we send, we're going to get the correct response back, which is person number 3, right? Employee number 3. Now, what if I change the ID to identity? Now, if I send it, I'm going to get a bad request, which is 400, right? It should be 400 bad request as per normal. Now, how do we fix that problem? You already know that. We can specify the name here. We can say name is identity. This has to correspond to the key of the header. And if we run it this way, then we have no problem again. Let's go to Postman. Okay, so this key identity corresponds to the name here. Then we can use any parameter name as, and then click on send button. We get the correct employee back. We can change this one to 1, for example, and we can test again. And you can see we get John Doe, which is the first employee. Okay, so this is the difference. You can see that the difference here, we have to, in this case, use from header. And then everything else is the same as binding to query string or binding to root value. And that's everything I want to talk about in this video. Any questions, please let me know. If not, I will see you in the next one. In this video, let's learn about using AsParameters attributes to group parameters. So far, when we learned about the binding, the model binding, we have used only one parameter here. Okay, so get employee, and then we're getting the parameter from the header, or I can say binding this ID to the HTTP header. But what if you have different information from the HTTP request and they all need to be extracted and put into .NET objects? Okay, for example, let's delete this one, and then let's say that ID comes from the root parameter. Okay, so ID over here, I can provide a constraint, and also for some reason we require the user to provide name, which doesn't actually make sense in this case, but just for demonstration purpose, we require the user provide the name from the query string. So I can say from query, and name is, I need to specify the data type here. Okay, name from the query string. And also we need the user to provide the position from the header. So from header, string type, position. And over here, we can use the ID, name, position, any we want. So for example, I'm going to do some weird thing. I'm going to get the employee information directly from the repository, and then I'm going to actually update the name to match the name provided through the parameter here. And I'm going to update the position to use the position from the parameter. Okay, so this is no doubt going to work. We just need to make sure that everything comes from the correct place. So let's run the application. And because we're going to use header, so I have to use Postman here. So we're hitting the correct root template. The position comes from the header. So I'm going to provide position header over here. And then here, I'm going to just say developer. And the query, we can add it over here, or we can add it over here. So I'm going to directly add in the URL here. And I'm going to say name equals, let's say, James. Right? James, actually, it doesn't exist in our data store, but I'm just going to use James. And in this case, we also need to provide the ID. Let's say ID number 1. Okay, ID number 1, which is John Doe. But we're going to update John Doe to James Doe. And let's try to get the information. So click on send. All right, so names is James Doe, position is now developer. Remember, John Doe, I don't think John Doe is a developer. Let's actually go to take a look at the code here. So John Doe is an engineer. So because we provided in the header, we provided position as developer, and therefore the name is updated to James, position is developer, We didn't update the salary. Okay, so now you can see that we indeed can provide information from different parts of the HTTP request and bind them or extract them to our .NET objects. However, the only problem you see in our code here, let's go to program.cs and let's see, we have just so many different parameters, especially this is only 3, and sometimes you have 4, 5, 6, and each one of them come from different source. It doesn't actually matter whether each one of them come from a different source or the same source. It's just that there are too many parameters, and sometimes it's better to group them together. And how do we group them together? We can create a data structure, whether it's class or struct, doesn't really matter, or even C# record, doesn't really matter. You can just group them together. So for example, let's scroll down and let's try to group them together with a class here. So let's say class, and what do I say? Let's say get employee parameter, just call it this way, and then we're gonna say we have ID and we have name. Of course, we're gonna have our position. All right, ID, name, position, and over here we can specify the data source. So this one come from root, and this one come from the query. Of course, this one come from header. But you don't have to specify the data source from root or from query as long as the name corresponds, just as what we mentioned in the previous videos. But here for position, because it comes from header, we have to specify it. Okay, so once we have this structure, we can use this right here. So instead of using 3 parameters here, what we can do is we can use 1 parameter, which is get employee parameter, and we can just say param. Okay, and we need to specify AsParameters. And when we do this, ASP.NET Core sees this as parameters. It's actually going to replace this class with the properties over here. So when we are writing this, it is as if we're writing the 3 different parameters as before. So writing the class name like this is the same as this, right? So that's why this attribute is called AsParameters. It's basically saying that this looks like a class, but it's actually parameters, right? You're actually creating parameters that corresponds to different parts of the HTTP request. Now, you can use it right here, like this, ID, and then like this, name, and then you provide the position. So param.position. Okay, and let's give it a try again. Let's run it, and let's go to Postman and James. Let's actually call it James Bond. I don't know whether Bond is written like this, but I'm just going to use it. We can specify even the space here. So click on send. Now we get James Bond, position developer. Let's actually update the position. I have to change it to agent, otherwise it looks weird, very weird. Okay, James Bond agent, salary is too low. But anyways, you can see that AsParameters is an attribute that help us to simplify the parameters. Right? We're grouping all of the parameters inside a class here. And again, this doesn't have to be a class. You can even change this directly to struct like this. Right? Change this to struct and run it again. It's going to work exactly the same. So James Bond agent, let's update this agent from a lowercase a to a uppercase a, just to be more appropriate. All right, so you can see that this is updated. So this is how AsParameters works. Right? You're using a class or struct, but it is as if you're using parameters. And that's everything I want to talk about in this video. I will see you in the next one. You can actually pass an array from HTTP request to your endpoint handler parameter. So let's jump into Visual Studio and see how that's possible. Again, let's use map get to pass the information. So we're trying to get multiple employees in this case, because we're going to pass an array. With root parameters, it's not very appropriate because you don't want to have different segments that points to the same type of data, which is the employee ID. So we're going to delete it. What is possible is that you pass information from query string to an array in the parameter. So let's delete this and try to say int array, and then I'm going to say ID, right? And then over here, we will have to, instead of just getting one employee, we're getting multiple employees. So just for convenience, we're going to get all of the employees first from the employee repository without having to change the employee repository. So get it first, and then we're going to use link to grab all of the employees that corresponds to the ID array here. So employees dot where x goes to ID contains x dot ID. All right, and then we're gonna cast that to a list, and we're gonna use emps to represent that. And now let's delete this, and we're gonna just return all of the employees that corresponds to that array. All right, now let's run the application. Okay, and we need to go to /employees. Now we need to provide the array. Where do we do that? There are two choices. We can do that in query string, or we can do that in headers. Let's try query string first. We're going to say ID equals 1, and then we can provide it again. ID equals to 2. And if I hit enter, you can see if I format it, we get number 1 and number 2. So these two employees. What if I change this one to number 2 and this one to number 3? And I get number 2 and number 3, right? And if you just provide one employee, that's fine. We only get one employee. But as you can see, the result JSON is an array, right? It has a square bracket. So as you can see that if you have the query string, that the parameter name, like the query string name corresponds, or the key that corresponds to the parameter name here, then they are going to automatically bound. So I have to say it reverse way. So this parameter is going to be automatically bound to the query string. But what if you want to call this one IDS, right? So it's kind of weird to call this ID because this is an integer. So it's better to add an S in here to represent plural here. But then this problems happen there that this IDS doesn't correspond to the query string name anymore. Then what do we do here? Of course, you have learned about it. We just use from query, and then we specify a name as ID, and that will fix our problem. We can still run this, and it's going to still work in the same way as before. We're going to specify ID equals 3 and ID equals 1, and then we get number, I'm missing here an ID, and hit enter. So we're getting number 1 and number 3. And if you want to specify all of them, you can specify all of them. So add ID number 2 as well, and we hit enter, and we get number 1, all of the employees. Okay, so that's from query. And if you want to do it from header, you can do it from header. So from header, and this time let's go into, let's first of all run it, and then let's go into Postman here. Let's remove this, and header here. What is the name of the key? It's going to be ID, and we can specify 1, and then we add another 1 ID, and then we can specify 3, and then I click on the send button. I get my employee for ID number 1 and ID number 3 in a JSON array. Right? I can add another one, ID number 2, hit send. I get all of the employees in the JSON in the HTTP response body. All right, that's how you pass an array from HTTP request to endpoint handler as parameters. And the data source is either header or query string. That's everything I want to talk about in this video. I will see you in the next one. In this video, let's learn about binding to HTTP body, which means that we're going to have a parameter that binds to the HTTP body. And usually that parameter is going to be a complex type. So far in our examples, we have been using primitive types, right? Simple types. And for binding to the body, we usually always bind a complex type to the body. For example, for a map post, okay, for handling put or patch, we want to bind a parameter from the handler to the body. And that's why we're extracting complex type from here. So we get a stream reader, we read a body, and we use a JSON serializer to deserialize the JSON into a .NET object. All of these should be done by ASP.NET Core framework. And that's exactly what model binding here is for. We're going to bind a complex type, right? So let's remove all of this. So let's change all of this. So remove this async. We're going to not use the HttpContext signature. We are going to bind from the body. And if we provide a complex type, automatically or by default, ASP.NET Core would think that you're going to bind this parameter to the body. It's going to look for the information or the data in the HTTP body. So I'm going to say employee just like that. And then we don't need all of this anymore. Let's delete it. Delete this as well. Let's don't worry about returning status code in this lesson. So let's delete this line. We're going to talk about that later when we learn about returning results. So I'm going to delete this status code as well. Here we can just return this as a message. And if there's anything wrong with the information in the parameter here, we can also return and say employee is not provided or is not valid, something like this. Let's give it a try. All right, let's go to Postman because we're gonna trigger the post endpoint. And again, we're gonna add Tom Anderson, a software developer. Click on send button. And we're seeing this employee added successfully. What if I change this to -6, for example? Click on send. We get this employee is not provided or is not valid, although the status code is incorrect. We don't worry about the status code later. But you can see at least we are getting the model binding here correctly into the endpoint handler here. I'm gonna format this slightly better. All right. So this is binding to the body. Binding to the HTTP body in minimal API actually has some limitations. The first one is that it's going to assume that in the HTTP body here is always going to be JSON. But as you can see, you can use so many different formats in the body. However, for minimal API, the information in the HTTP body has to be JSON. Cannot be anything else, and you cannot configure it to use any other serializers. This is different from MVC or Razor Pages. With MVC or Razor Pages, you can actually specify to use a XML serializer, for example. So in those technologies, different formats are supported. In minimal API, only JSON is supported, and you cannot replace that, which is understandable because most of the APIs deal with JSON. That's the first limitation. The second limitation is that in the JSON, you cannot have multiple types of the data. For example, you have an employee, and then you want to add something else. Let's say you have another type that has ID and company name, right? So if this is a company information, and also another one that is a employee information, so this is not valid. Of course, in this case, it's not valid because it's not even a valid JSON. But anyways, I'm just trying to point out that you can only have one single complex type in the JSON in order to bind to it, right? So that's another limitation. And of course, you will have to specify a valid JSON as I mentioned. So something like this. Let's say that we're removing a comma here and then click on send button. What do we have? We're seeing that we have a bad request. Fail to read parameters from request body as JSON. Okay? And let's say you're providing something else, ABC. Right? This is not a valid JSON. And if you click on send button, now you also have a bad HTTP request. Let's say that you have XML. Let's say employee ID equals 3 or 4, name equals Anderson. So this is a valid XML, but if we send this, right, we also get bad request, 400 bad request. Right, let me revert back. So you have to have correct valid JSON in order to make this work. And also because JSON should be actually contained in the body. So attempting to use anything other than post, put, or patch. Right? For example, if you try to use get with a body, you can actually try that. You go over here and go to body, you put this one over here. This is not recommended. Don't try to do this. It's going to confuse the server. Right? Don't try to do this, or try to do head, or try to do body. Should be only contained in either a post request or a put request or a patch request. Don't try to use any other things. Of course, including delete. Don't try to put a body in there. It's going to confuse the server. Okay, that's what I want to show you. The main thing is that if you put a complex type in the endpoint handler as a parameter, it's going to look for the information from the body by default. And of course, it's possible to bind this to the headers or the query string or the root values. We're going to talk about that later. But by default, it's going to go to the body to look for information, right? So if you don't provide anything in the HTTP body here and then click on send, still couldn't find the employee information, and then it's going to give you 400 bad requests. All right, that's everything I want to show you in this video, and I will see you in the next one. In this video, we're going to learn about custom binding with the BuildAsync method. So previously, we have talked about binding a complex type to the body. And we mentioned that by default, it's going to bind to the body because we provided a complex type. But is it possible to bind this to, for example, to query string? It's actually possible. And if you do something like, let's say that you provide a URL like this, so /employees $ID equals 1 and name equals, let's say my name Frank. So you can actually expect this information, the ID and name, to be bound to a complex type or to be extracted into a complex type. So how do we do that? We can use custom binding. All right, let's jump into Visual Studio and try to implement something like this. So let's say that we are going to create a new object to bind to. I mean, a new class to bind to. So let's call it person. And I'm going to have a ID as suggested. And after that, I'm going to have name as well. Now, if inside this, I implement a special method, it's called BindAsync. Right? So this is actually by convention. It's a static method. you are not implementing an interface, you just implement a special method and it has a special signature. So value task is similar to task, but it's lightweight, has a better performance. But this is the signature of the method. So bind async, and then there is the HTTP context in here. Okay, so because it has HTTP context, it allows you to bind this type to any part of the HTTP context, right? So for example, inside here, if I say that I want to grab the ID, right, the ID from the query string, so request dot query, we do this, and then we do name string. Also, we get the name from the query string. And if int try parse ID string out to ID is successful, then I'm gonna return new value task person. I provide a new person over here. Name is our name string. If we don't have a valid ID over here, we just provide a dummy result. So new value task person, and then we're gonna say task from result person, a dummy result like that. All right. So because we implemented this, and when we try to bind, so let me scroll up and implement it so that it's easier for you to imagine. So if I go here and I'm gonna say map get, okay, and it's going to go to slash, maybe let's call it persons, or maybe people, okay, and then here I'm gonna say person question mark and p, right, goes to, and then I can, let's say we just return this with string interpolation, and then say ID is p question mark ID, name is p question mark name. Okay, we want to be safe, so we need to add the question mark here. So when we have this endpoint handler defined like this, you can see that although we provided a complex type, but because the definition of this complex type has a BuildAsync method with this specific signature here, then it's not going to do anything else. It's not going to go to a query string or go to root values by default, right? By default, it's going to take the root value first, right? It's not going to look for that. It's not going to look for query string. It's not going to look for the body. It's going to look for from whatever the logic that is defined here, right? In this case, it still goes into the query string, but that's defined inside this implementation of the method. So what I'm saying is that if you have a bind async defined in the type, and then you're trying to bind this type to HTTP context, it is going to consider the logic inside your bind async method first. Okay, so in this case, of course, it's going to use that, and then it's going to go to the query string to grab this value and that value, and then it's going to give me a result. So let's give it a try. All right, so let's go over here. ID equals 1 and name equals Frank, and I hit enter. And this is wrong URL, so it's going to be /people. It has to be /people. And ID equals 1, name equals Frank. And I get this result. ID is 1, name is Frank, right? Which means that our data binding here and model binding here really works, right? And let's say, for example, we want this name come from the header. Then we can just change this to header, right? Headers and name, right? We don't actually need to do anything else over here because this complex type already have the BuildAsync method. So let's go to, this time let's run debug mode. So let's set a breakpoint here. Let's run it. And then let's go to Postman where we can provide the header. And now let's add another one, request. This time it's get request. And let me copy this to this one over here, and I'm going to change this to get person, and this change to people. And then over here in the header, I'm going to specify name, and this time let's say this one is James, and in the query string I'm going to provide the ID of James, let's say 100, and then click on send. Now you can see that I have this triggered, and if I try to step over this, I get the ID, which is 100 from the query string, and then I probably press on the wrong button here on the taskbar. So let's give it a try again. Click on send and do this and that. So we have the name is James and ID is 100. So we got the value, and then we got this correct output. So you can see how this method actually worked, right? So that's how you implement a custom binding. By convention, implement a method like this, and then you can grab everything, anything you want from any part of the HttpContext object, and you bind to that, and then you do whatever you want here. You return it, right? You return the object, and that's it. That's what you need. At a place where you want to use it, just use it per normal, as if you're trying to bind this to the body. But then it's not going to go to the body. It's going to use your logic, right? And then inside it, you just implement your own business logic here. And that's everything I want to show you in this video. I will see you in the next one. In this video, we're going to learn about binding source priorities. What does this mean? We have talked about different binding source. There are headers, there are query strings, there are root parameters, there's HTTP body. All of these different source can be bound to. But when we have parameters that can be bound to any of those, what are the priorities? The first one is explicit. So if you have an endpoint handler parameter with explicit binding, which means that you specified the source. So for example, from query, right? So if you specify it, then that one takes priority. Let's take this for example. Previously, we have this person class defined right here with the bind async method. So it's supposed to just go into the HttpContext and grab the data from there. But if you specify this comes from the body, guess what's going to happen? Let's run it, and let's go to Postman, and let's go to get person, and you can see that in the body we don't specify anything, and in the header we already specified James, and the parameter we already specify 100. But if we click on send, what coming back is ID is empty and name is empty. What does that mean? It means that because the fact that you specified from body, it went to the body and didn't find anything. Therefore, this is null and this is null. So you get ID is empty, name is empty. So if you remove this, then it recovers back. So that's what I'm saying here, that if you do already have explicit binding specified as attribute, then that one takes the first priority. Okay. Secondly, if you're working with a complex type and the complex type has the BuildAsync method specified already, then it's going to use that. It doesn't even consider about anything else. It's going to just use that. And you already seen that once we remove this, right? You have seen that in the previous lesson, the bind async method takes priority. So let's actually give it a try again. This time we can do something funny. So let's go over here. And if we send this way, we get ID is 100, name is James. But what if over here, I provide the P parameter? We can do whatever here, right? Because it's not going to be used. So the P parameter has a value A, B, D. And then we click on send. We still get the same result, which means that the P parameter is ignored. But usually when you have this defined as P, and then you have the P parameter or the P query string specified in the query string, it's going to use the query string, right? That's the default behavior. But here, because in the class, person class, we have this bind async specified, this one takes priority. Okay, that's the second priority. Go back to our diagram here, and we have the third one, which is binding primitive type to root parameter. So if we have a primitive type, for example, this one, this is not a good example. This is array. So let's duplicate this. Let's say we change this to people, and then we just try to grab a specific person. So we don't need array, we just need the ID. Here, we can replace the logic to get a person, right? Get a person based on. So this, I'm gonna ignore the logic here. So if you have a parameter in your endpoint handler function here, this ID is going to be bound to the root parameter if there is one. So if I have a root parameter, this is definitely going to be bound to this. So that's the third priority. And the fourth one is bind the primitive type to query string. So if there is no root parameter, then this one by default can come from the query string as long as the query string's key is ID. Right? It's the same as this. It's case insensitive. Right? That's the fourth one. The fifth one is binding array to query string or header, which you have seen it right here. This is from header. You can remove this, which means that it's going to come from the query string. So that's the fifth one. And last but not least, the information can be bound to the body. So that means when all of this is not happening, then information comes from the body. So this is actually a pretty important lesson. So if you run into a problem with data binding just doesn't work, then come back to this lesson and look at the sequence here. This one takes the first priority and this one takes the last. So when you look at the sequence, you might be able to figure out why your model binding doesn't work. All right, that's everything I want to cover in this video. I will see you in the next one. In this video, let's talk about model validation. We have learned about model binding, which is the process to extract data from the HTTP request object into our .NET objects in our endpoint handler so that we can have the data to work with. So now that we have everything, are we ready to actually implement the business logic? No, we don't, because we need to validate the data. More than often, the data comes from the HTTP request. It's actually from the end user. So therefore, model validation here is very important, and model validation is the process of validating data within the endpoint handler parameter. So let me draw some picture again, grab some diagram here. So in this diagram, we have this. Let me copy this and paste it over here. So we have the routing and we have the model binding that happens before the endpoint is executed. Now that we have the model binding already, when the endpoint is executed, our function over here is bigger. All right. So when we execute so here we're executing the endpoint. We're executing an endpoint function. All right, let's imagine that our endpoint is just fx and the x is the .NET object. So because we have model binding so that we can extract data and put that into the x object. Now that we have the x object and this object contains the data that comes from the user, right, through the HTTP request, we can use this data. But before we use the data, we need to validate the data. Why? The data actually comes from the user. And when the user provides the data, first of all, the user might be a hacker, right? So some malicious attempt may be made here in order to break the system. Therefore, you need to validate it. Secondly, if it's just a regular user, the user might provide any information, any unimaginable information. So do not always assume that the user will choose to do the right thing. We as a developer need to make sure that we cover all possibilities. Therefore, we need a model validation. This, if we call this as a model object, then the model validation, of course, means that we need to validate the model. So how do we validate a model? We can use a C# technology. So this is not part of ASP.NET Core, it's just C#. It's something that is called data annotation. Let's create a new project. And let's again select the ASP.NET Core empty project template, select next. And we're going to call the solution Learn Model Validation. And the project name is going to be again web app. Click on the next button. And here we're going to select the .NET 11 preview, and we're going to uncheck the configure for HTTPS just as before, and then click on the create button. Now let's go to program.cs. Right, so let's have some model first of all. Let me grab source code and paste it over here. All right, so we have employee class defined here, and we have employee repository defined here. Feel free to extract this to separate class, but in this lesson, let's just use the class right inside the program.cs file. Right, this is not a good way to implement any production-ready project. This is just for demonstration purpose. You actually need to extract this into a different folder at least, and most likely in your production-ready project, you will have a separate class library C# class that contains this. Okay, so data annotation, which means that we're specifying how to validate the data right on the class itself. For example, we're saying that when you provide a new employee or update an employee, the name property is required. So the user has to specify the name property. We can use required. And automatically the namespace is imported, which is from the system.component model.data annotation. So this is not part of ASP.NET Core. This is just C#. All right. So name is required. And let's say a salary is also required. But salary has to be higher than 50,000. So we can use something else. It's called range. Inside range, we can specify the minimum value here. We can say 50,000. And maximum value, we can also provide, let's say maximum value is 200,000. All right, so this specifies the salary range. And with this too, then when we try to implement the post method, for example, let's try to implement the post method very quickly. Map post and post into the employees root template, and then we specify the employee model binding. So this is going to come from the body. This goes to a lambda expression like this, and then we're going to use employee repository here, add employee. We can do some validation, of course, over here inside the lambda expression. That's the most primitive type of validation. Developers can just directly validate the data, but with the help of ASP.NET Core framework, we can actually take advantage of the C# feature, which is data annotation. We specify how these things can be validated, and our logic inside our actual lambda expression, actual endpoint handling logic here, it's very simple. We don't have to do anything special. And here we can return the message. We can say employee is added successfully. Now that we have the data annotation added like this, we have required, we have range to different fields. In order to actually enable validation based on data annotation, we have to go to the top over here, and we're going to say builder.services.add validation. We have the validation services that is already built in, and by calling this extension method, we're adding that validation service to the service collection.
And when model binding is happening, it's going to look into the definition of the class that you specified, and it finds these data annotations. And then it's going to follow the instructions over here to validate the data by using the validation services that is added over here. So let's run the application and observe what happens. And because we're only having a post endpoint, therefore, when it goes to the home page of the application, it doesn't show anything. It only shows 404 not found. But we can go to our postman over here, and we can go to the add employee endpoint here. It's posting to the employee endpoint. Make sure the port number is correct, and because the port number has changed. And over here, you can specify ID as 0 because the ID doesn't really matter. This is adding employee. The ID doesn't really matter. And let's set this salary lower than the minimum. So I'm setting to 4,000 because if we go over here, you can see that in our program.cs, we have the employee data annotation. The minimum range for the salary is 50,000. So if I set it to 4,000, I expect it to fail. Let's try it. Click on send, and you can see we have the error message, and it says salary field. So it says the field salary must be between 50,000 and 200,000. The salary is too low. Now, if I change this one to 50,000, now if I click on send button, then I have employee is added successfully. And let's try to remove the name, because we said the name is required. Click on send. Now you can see that it's complaining that the name field is required. Bring the name field back and change to something else and click on send. Now we have the employee is added successfully. You can see that the data annotation validation is actually working very well. And it's actually pretty easy to implement this in Minimal API after .NET 10, because in the past, there's something else you need to do. You actually need to install a NuGet package. Now the validation service is already built in, I think, after .NET 10. So all you have to do is, first of all, you define the requirement for the field using data annotation. And then you go over here and add the validation service by calling the add validation method, the extension method. And then ASP.NET Core will automatically validate data before your endpoint delegate is executed. And there are many different types of data annotations that you can use. Let's take a look. Let's search C# data annotations. And then let's click on this validation with data annotation validator, and let's look at this. There's just so much information. This is an example. I believe there is another article regarding this. Maybe let's go to the namespace itself. All right, so if we come to the system.component model.data annotation namespace over here, you can see that we have so many different attributes. We have compare attribute, which is used to compare two different properties. Credit card, this is to specify the data has to be credit card number, right? Concurrency check, data type attribute, display attribute. Display attribute is to provide a different name for the property. And let's say length attribute. This is to specify minimum or maximum length of a string. Maximum length attribute, phone attribute, range attribute, we use this, and we have regular expression as well. We use required attribute over here, and timespace stamp, right? String length. And we are going to talk about validation attribute later in the next video. But if you want to play with these validation attributes, come to this learn.microsoft.com article and explore yourself. In this video, we're going to learn about custom model validation with the validation attribute. If you have slightly more complicated logic that requires to use multiple properties at the same time, then you might run into issues because data annotation is not enough to do that.
let's say you have a logic here that a position is actually required. That's fine. You can use the required attribute to do that. Let's do it right now. Okay. Now, if the position is manager, the salary has to be higher than 100,000. See, that's a logic that needs a combination of both the position property and the salary property. So how do we do this type of validation? We can still use data annotation, but the built-in attribute is not going to be enough. We need to create a custom validation attribute. So how do we do that? We can create a separate class. You can add a folder to include multiple this type of class, but in this video, I'm going to just create a class in the root folder here. And I'm going to say employee. I want to have this type of validation all starts from the class name that we are going to apply the validation attribute to. So I'm going to say employee, and then I'm going to say ensure salary. You can be more descriptive. You can say ensure salary for manager, something like that. I'm just going to say employee underscore ensure salary. Okay. And then over here, this employee underscore ensure salary has to derive from the validation attribute class. And this class is from the system.component model.data annotations namespace. Right? Don't do something like validate and then just go to this validate attribute. This is from the minimal APIs.extension that we just installed in the previous video. Spell the whole thing validation attribute. This is the class that you want to derive your class from. And then once you do that, go over here and do override. And then you see that you have two isValid method or function that you can override. Let's override the one with the second parameter, the validation context. And now let me minimize this solution explorer here, and we can delete this, and then let's try to use the validation context here. So from the validation context, you can access this object instance. So what do we mean by the object instance? The object instance refers to the object that the validation attribute is applied to. So for example, we are going to apply this attribute to the employee object. Therefore, this object instance refers to that specific instance that this one is applied to. Okay, so what we can do is we can say employee equals validation context dot object instance as employee. We are sure that this is going to exist as long as we apply this attribute toward an employee class. Okay, and then once we have the employee object, we can say if employee is not now. Right? You can use this, or you can say is not now. This is clearer if you're not very familiar with C#, or you hate C# syntax. Then you can do this. Now in this case, if the employee is not, well, let's fix the spelling error here. So employee. Okay, so string is null or white space. So if the employee is not null and at the same time the position is not empty, and at the same time if the employee's position equals to manager, and we can specify the string comparison or the no ignore case. So in this case, it's case insensitive comparison. In this case, we're gonna double check. I'm gonna double check the employee salary. So if the salary is lower than 100,000, what are we going to do? We're going to return an error. So we're going to say return new validation result, and then we specify the error message. So manager's salary, or maybe let's use proper English. So a manager's salary has to be greater or equal $100,000, something like that. Otherwise, we're going to say validation result dot success. Again, we have some spelling error here. Let's fix it. I'm sorry about that. Replace all of this with the correct word. Okay, so once we have this custom validation attribute, we can apply it as if we're applying any other built-in validation attribute. Okay, so let's go to program.cs. This is where we have our employee class here. And we're going to apply this to the salary property because we're actually validating the salary, right? Someone input a number in the salary and we say that, hey, this is wrong because the position is manager, so your salary cannot be lower than 100,000. Okay, so that's why we apply this over here. And then with this, let's run it and it should just work as any other built-in validation attribute. Okay, so obviously we need to use postman to post something to the body. The port number we already corrected. And here, if we add Tom Anderson as a developer and we specify, let's say salary is 80,000, we should be able to do it. And the return message is employee is added successfully. That's correct. And let's change the ID to 5. And here I'm going to say Tom Jerry Anderson. And if I change developer to manager and keep the salary at a low salary here at 80,000, we're going to see, oh, it says employee is added successfully. Let's actually debug. Okay, let's go over here, click on this debug button, and we have our application running. Go over here, click on send button. Now we have it over here. So this attribute is actually triggered. Now let's step over here. Do we have the employee? Yes, we do have employee. Okay, and if employee is not now, oh, I see. Something is wrong right here. If it's not null or white space, then we go over to the next. Okay, so there's something wrong. This time, I think we don't need this debug anymore. Let's run it again. So click on send. Now we see this status code 400, bad request. Error is a manager salary has to be greater or equal to $100,000. This is the correct message. So let's fix this. Let's say this guy makes 180,000 and click on send. Now we see employee is added successfully. So this is how you use validation attribute to combine different properties and have slightly more complex validations against a property. And if you have any questions, please let me know. If not, I will see you in the next one.
Now in this video, let's try to use a different way to validate the same logic, which is the salary of a manager shouldn't be lower than 100,000. But this time we are going to use a interface. So let's actually implement an interface, and that is called IValidatableObject. And over here we can do a control dot to implement the interface. And we can see this purple squiggly line. This is just because the application is still running. So if we don't want to see that purple squiggly line, we can close the application and you can see the squiggly line disappear. Now we can validate this without applying an attribute by just implementing this IValidatableObject. This is something new in .NET 10 for minimal API. So here we have this method that comes from the interface, and we can just implement the same logic over here, comparing with this. So basically what we can do is we can copy this part and paste it over here. The advantage of using the IValidatable interface is that we don't have to go to the validation context to get the object. We can directly access the position right here. So it will be, let's actually remove this one. So it will be simpler. And here we can remove this employee, remove this. So basically we're just validating against the properties right here within the employee class here. So if it's not null or white space, and if the position is manager, then we're validating the salary. If the salary is less than 100,000, then we're going to give it an error. But because the expected return type is INearable, so therefore we can use yield return. It's suggested by Visual Studio. And in order to target a specific property, we can use the second parameter here. So I'm going to do a comma here and then go to the next line. And then over here, provide an array of the name of the salary field, which is the field that we want to attach the error to, right? And you can see I grayed it out. And that's because we can actually use a simplified approach, square bracket like that, and then remove the curly braces, and then we write it like that. Okay, so here, this is the error message. And this one, we targets the salary property. And this yield return returns a array of validation. And if you have other things to validate within the validate method over here, you can feel free to validate the entire class to target different properties. And just make sure that you specify the correct property over here. And then with this implementation, it will validate all of the properties within the same class. Okay, so with this implemented, we can do the same validation as the attribute. So we don't have to decorate the salary with the employee insure salary attribute anymore. So I'm going to delete this one. And then we are going to see that the same validation is going to happen for salary property. Okay, let's run the application. And let's go to Postman over here. And we can try to add an employee over here and position. Let's use this as an example. So this is software developer and the salary is 50,000. So this should be successful. And you can see this is successful. But if I change this to manager and then I do it again, and now you can see the salary field has an error message. Manager salary has to be greater or equal to 100,000. And if we change this one to 100,000, let's do it again. And we have the employees added successfully. All right, so this is only possible when we add the validation service. So to be able to use IValidatableObject interface, we have to remember to add validation over here on the top. Okay, that's everything I want to cover in this video. I'll see you in the next one. This is assignment video for this section. And in this assignment, you're going to practice binding and validation registration information. So when I say registration information, it actually includes only 3 fields. The first one is email. The second one is password. The third one is confirm password. And here are the requirements. The email field is required field. The password field is also required field. And confirm password is definitely also required field. So all of the 3 fields are required, but at least the format has to be a valid email address format. And then the password must be at least 6 characters long. And also both the password and the confirmed password need to match. And additionally, you need to create 2 versions of endpoint handlers, namely 2 endpoint handlers. For the first one, the registration information comes from the query strings in the HTTP request. For the second version, the registration information need to come from the HTTP body. Of course, you don't need to contact any backend in the registration endpoint handlers. The only thing you need to do is to work with the model binding and model validation. And another thing, after you complete the 2 versions of these endpoints, try to figure out which version is more appropriate for user registrations. Okay, I hope you can work on that based on the requirement. And in the next video, I'm going to show you my solution. I'll see you in the next one. All right, in this video, we're going to work on this assignment number 4, binding and validating registration information. I have a new project created here following the usual steps. First of all, we are going to create a registration class. So go down to here and just try to create a class, and I'm going to call it registration. Okay, and it's going to have 3 different properties. The first one is going to be, I would think I'm going to call it email, right? And the second one is also a string, and I'm going to call it password.
And the third one, so what I did just there, talk to you about this is a prop, and I use my tab key on the keyboard. So tab, then it generates the property for me. So I can just use this template to complete my code writing more quickly. And this one, I'm going to call it confirm password. Now I'm going to use data annotations to satisfy the requirement here. Right. So first one is email is required. So I'm going to say required. This is going to come from data annotation namespace. When I do tab, annotation namespace is automatically added on the top. Okay, so all of the three fields are required fields. So I'm going to add the required attribute to all three of them. And then the email address has to be a valid email address in terms of the format. So I'm going to add email address. This also comes from the data annotation namespace. As I hover the mouse over it, you can see it comes from the data annotation namespace. Now, I need to specify the error message here. Okay, so if the email address is not valid, I'm going to say error message equals to invalid address. You can come up with any email address validation error message that you want. Okay, and then for this password, I need to specify the string length. So I can use the string length attribute. And the first parameter is maximum length. And this is actually a required parameter. So I'm going to say 100. I think that's big enough. But our requirement is that it's at least 6 characters long. So I'm going to populate the minimum length property here, and I'm going to say 6. And also, I'm going to have an error message. And this error message is going to be, I think we're going to use this. Just do a copy and paste. So it says password must be at least 4 characters long. All right. Now, we need to validate the confirm password, right? So we're going to use the compare attribute. As the first property is other property, which is the property to compare with. So here I'm going to just say password, which corresponds to the name of this property. Okay. Now I can specify a error message, and this error message, I'm going to just copy it from here. So when the password do not match, I'm going to say password do not match. So they have to match. So this is the behavior of this compare property here. Okay. Another thing I want to add to this is that the confirm password is also required, right? But when you don't provide the confirm password, it's going to say confirm password is required. The thing with this is that you're going to see confirm password as one word. So in order to show a better error message, I'm going to specify the error message. I'm going to say confirm password is required, like this, so that I don't see it together. I see them separately, right? This is proper English. All right, so that's my class here. I need to create 2 versions of this. The first version, as required, is registration information comes from query string. So that means I need to implement custom binding. This is a complex class, right? Complex type. Therefore, I need to implement the ASP.NET Core can use it to complete the binding from the query string to the complex type, right? So we have learned about that. So I'm going to say public static is a static method, and it's value task of the type registration, and we can use nullable. Okay, and then we're going to say bind async, and the parameter type here is HttpContext. Okay, and we can use whatever information that is in the context. In this case, we're going to grab all of the 3 fields from the request.query. So from the query string. So this one is from the email query string, and I'm going to call it email. And then the password also comes from password. It automatically generates the field for me. That's great. So confirm password come from confirm password. Maybe here I want to shorten it because this is query string. I don't want it to be too long. I'm going to call it PW, maybe call it PW1. And then this one, I'm going to call it PW2. So this is from query stream. So once I have these three fields, I'm going to just return it. So return new value task, and type is registration question mark, and I just initialize it. So registration with email, password. Let me minimize this. The third one is confirm password. So everything is generated for me. That's very good. All right, I think that's it. That's the implementation of this registration class. And then we can go ahead and try to create the two endpoints. Right, so we can use the top level, but in this exercise, I want to use the traditional way. I'm going to say use routing, and then I'm going to say app.Use endpoints, and endpoint goes to, I'm going to use this traditional way. And endpoints dot here, I'm going to do map get. Okay, why I say map get? Because it says for the first one, the registration information comes from the query string, right? So it makes sense that it comes from, the first one comes from get, the second one comes from the post method, right? And the URL would be similar. I'm going to say /register. And for this one, the type of the endpoint handler parameter is going to be a registration, as what we have defined underneath there. So here I'm going to say reg, and then define my lambda expression. And over here, it could be just very simple. Once I have the registration information, I'm going to say return, and then I specify, I'm going to say user reg.email, right, is registered successfully. All right, so I don't need to specify any extra validations to the email address because that's not required. Okay? So in the previous video, I mentioned that we only need to do the model validation, not the actual validation for the email to try to tell whether it already used or not. We just need to try to see whether the email address format is correct or not. So the email address attribute here will do the job for us. Okay, so here I'm just simply returning this. Another thing is that, do we need to check whether the registration object here is null or not? Well, you can see that here we're gonna use bind async, right? This is gonna come from the query string. And for any complex type that has a bind async, it's gonna use the bind async unless we specifically or explicitly specify where the data source is. Right here, I'm not going to say anything. Therefore, it's going to use the bind async method. And when we use the bind async method, we're going to create this registration object anyways. So it's not going to be null. All right. So the second endpoint I'm going to create is map post. And register is going to be the path. And for here, if I just let me just copy and paste this whole thing. Copy and paste this whole thing over here. And if I do it this way, okay, without doing anything special, the registration information will also come from the query string because it's going to use the bind async. So in order to skip that, I'm going to use explicit model binding. I'm going to say from body. All right, now we can give it a try. Let's click on the run button. And let's try to execute these two endpoints. All right, so we don't have anything specified on the root, therefore we receive HTTP error 404. So let's go to / and what is the path? It's register. Now we have two of them. The first one is from the query string. So we're going to provide the query string, and we're going to say email equals, let's say Frank, okay? And I'm just going to hit, and it says user Frank is registered successfully. Why it is happening like this? There's no validation. That's because we specify the annotations on it, but annotations don't work yet. Why they don't work yet? Well, in order to enable data annotation validations using these attributes, we need to go up over here and
between these two lines, I'm going to say builder.services.addValidation. Okay, this wasn't here before .NET 10, but now it's very convenient. You just need to add the validation, and then that enables the data annotation type of model validation. Okay, now let's give it a try again. Let's run the application. Okay, and here is our previous tab. Let's close this. We can still use this tab. I'm going to hit enter on this. Now we can see some error message here. Okay, email field, invalid email address, password, confirm password is also required. Okay, now let's change this to like frank@abc.com. So this is a proper email address. Let's hit enter. And now the email address actually passed the validation, right? So if I don't provide anything, I'm going to receive all three fields validation. So email field is also required here, right? So let's go back. So now we have the email properly provided. Now let's provide the password. For password, I think it's pwd1. And then if I say ABC, I hit enter, I'm going to receive this error message. Password must be at least 6 characters long, and confirm password is also required. Okay, so I'm going to say ABCDEF, and then I hit enter. Now the second validation also passed, right? We provided the correct password. I mean, not the correct password, but password with the correct format. Now I need to provide the second password, and I'm going to just say DDD, and then I hit enter. Now you can see that it doesn't pass the last validation, which is password need to match. So let's match the password. So ABC DEF, and then I hit enter. Now I get the user registered successfully. All right. So this is the whole process for the first version, the whole testing process. Okay. For the second one, it needs to go from the body. So let's go in here, and then let's create another request. Okay. And then this is going to be post. And then let's go back to our browser here and copy this path. I mean, the whole URL here. And then let's go to body. So we need to post a JSON to represent the user that needs to register. And the first field is email. So I'm gonna say ABC, and then is it still running? I hope it's still running. Let's click on the send button. Now it's indeed still running, but it says invalid email address. We're gonna do the same set of testing. Okay, so I'm gonna add this back, frank.com, and click on send. Now the email validation passed. Right, so if I don't do anything, if I take away all of this and click on send, so while registration was not provided from the body, this is 400 bad requests, so this is different. So what if I just leave curly brace empty and then click on send button? Now I have a different error message here. All right, let's put the email address back. Now let's go to the next one, which is password. So here, this is not the PWB because we're not using the bind async method anymore, right? We're not using the bind async method. We are directly binding to this from the body. So it's not PWD, it has to be password because it needs to correspond to the name of the property here. So let's use password, and then I'm going to say ABC. I'm going to do the same set of testing, click on send. So we see password must be at least 6 characters. So I'm going to say DEF, okay, and click on send. And that one passed the validation. Now it's just the last one. And I'm going to say confirm password. And here I'm going to say AAA and click on send. So passwords do not match. Now let's match the password. So ABCDEF. And that should register the user. So we received the proper message, which is 200 OK. That's the status code, and the message is back. So we completed the 2 versions of the endpoint handlers. Now we need to answer the final question. So the final question is, which one of this version is better? Should we use the GET request, or should we use the POST request?
should we pass registration information through query string, or should we pass registration information in the HTTP body? The answer is the post request is better, because for the GET request, the registration information is within the query string. So when the registration information is within the query string, that means you can see the password in clear text. You can see the email address left right here. So the browser actually remembers the URL as browsing history. Anyone who has access to the computer will be able to see your URL. For example, if you create an application and someone use it in public library and forgot to clear the browser history, then the next person will be able to see it from the URL. So the browsing history cannot remember what's in the body. Therefore, it's better to use the second version, which is from security perspective, the second one. All right, that's everything I want to talk about in this video. I hope you had fun implementing this little exercise. In this new section, we're going to talk about producing results with minimal API in ASP.NET Core. And in this first video, we're going to learn about minimal API return type. So far, in our examples, we have been returning strings and object directly from our minimal API endpoint handlers. So let's jump into Visual Studio. Let's see some examples. I have created this new solution and I call it Learn Minimal API Results. And I have added the employee class here and the employees repository. So this is the same as the one that used in the previous section. All right, so here, basically I just copy code from the previous section here. So we actually have 3 different endpoint handler here, and we're using top level endpoint registration without explicitly using the routing middleware and the endpoint middleware, but implicitly they're being used. So we have this one corresponds to the root. This one returns a string, right? A pure text directly. This means that in the body of the HTTP response, the format or the data type of the body is pure text, right? Text/plain. And then this one returns an object. And in ASP.NET Core minimal API, if we just return an object directly, a JSON serializer will be used and the body will actually contain JSON. This one, of course, returns plain text. This one returns plain text. And you can see that these 2 data types, right, the pure text and JSON are being returned, but we only covered the sunny pass. What if there are errors? For example, this one, the employee information is passed into the endpoint handler. However, there's some issues and we're saying that employee is not provided or is not valid. But the problem with returning this is that although we're spitting out an error message, but the status code of the HTTP response is still 200 OK. So that's not OK. We have to have correct HTTP status code that corresponds to the situation. So how do we solve this problem? Well, minimal API also gives you another return type, which is IResult. So if I put it right here, this is what it looks like. Returning IResult. You don't have to explicitly put the IResult here, but you can actually return the IResult. And the IResult, if we go to the definition of this, let's pick definition, you will see that it's a very simple interface that has only one method defined in it, which basically returns a task, and that means return nothing. Right? And it has this execute async function in it, and the only parameter it takes is HttpContext. So if you create a class that implements the IResult interface, you will have to implement this method. And with this method implemented, it just means that you can do anything to the HttpContext object. And that means you prepare the response inside this particular method. That's when you want to customize the response. In most cases, you don't need to create your own class that implements this interface. ASP.NET Core framework provides you with a lot of helper functions to help you to return IResult, and those helper functions is mainly to provide the status code. For example, this one, you want to return the employees as the body, that's fine, but where do you specify the result, the status code. Well, with this one, we don't have to, because if this is successful, by default, the status code is HTTP 200. OK. But if we want to explicitly specify HTTP 200 OK, what we can do is we can use results dot, so this is a helper function here. We can say results dot OK, and then inside it, we can provide the object. And what this is trying to do is it's going to provide the status code in the HttpContext dot response. Right? It's going to specify the status code there, and also it's going to serialize the object into JSON and put it in the HTTP body. So that's the implementation of that execute async interface in this particular case. If we pick the definition of OK, you can see that it actually returns IResult. So this is a function that it returns this IResult. And internally, it's actually used the typed result. We're going to talk about typed result in a moment. We pick definition of the typed result.OK, and now you can see that it returns results cache.OK. And if we continue to pick definition, you can see this. Finally, we have a sealed class that implements the IResult interface. And because it implements that interface, it actually implement this method, and inside it, of course, it's going to do everything about the HTTP context and use that to specify the status code. And that's what I'm saying here. With this results.OK, we're doing two things. One is that we specify the status code. The other one is that we are serializing this employee's object into JSON, put it into the HTTP body. Okay, now with this knowledge, we can deal with this error code, right? So we need to specify, in this case, HTTP 400. So we can still use the results with helper functions. For HTTP 400, that's bad request. So if we just type the description of the status code, the helper function will show up here. And then we can just wrap the message inside it if we need to do it. And then over here, we will say results.OK. And this is all. And if we run this and come to Postman, make sure we're using the correct port number, which is this one, 5124. So let's change this to 5124. And here, all right, so this is the wrong request. We need to go to here, add employee, and change this one to 5124. And if we provide ID, but change to this one to -4 and click on send. So here you can see that position field is required. Okay, so let's add a position field. This position field is required comes from the data annotation validation. So let's add the position back, and this guy is manager, let's say. And now let's click on send. Now we receive this error message, employee is not provided or is not valid, and we get this 400 bad request. This comes from the validation over here. And this validation is using results.batRequest. This is the helper function that we talked about. And there's many different results helper function here we can use. We have OK, we have bad request, we have not found, we have no content, we have just about any status code that you can find. They're all included in the results.bat request. Another type that we can use directly. Remember that when we check the definition of the helper function, underneath it is actually use another one that is called typed results. So we can use type results here, and we can use type results here. Right? When we use the type results, this lambda expression returns. You can see that it returns OK with list an employee. Same over here, it returns bad request but has a string in it. So it indicates what is actually returned as part of the body, right? Whereas if we just use results, and if you hover the mouse over it, you can see that it only just returns an IResult. So with type results, in some cases, it's better because ASP.NET Core framework is aware what is actually in the body. Whereas when we return IResult, the ASP.NET Core only knows that the return type is IResult. It doesn't really know what is in the body. Right? So if you can use type results, it's definitely suggested. In some other cases, like documentation of the web API here, if you use type results, the documentation will be automatically extracting the type from the type results. So it's going to help the documentation to document it better. So that's the difference here. But same as results, you will have all the helper functions to return all types of status code. And of course, if none of these results work for you, you can always result back to use the HTTP context here, right? So HTTP context and then context. And with this version, you can modify the response in however way you want. But typically using the helper functions along with the default functionalities of serializing objects into the body, it's already enough. And that's all I want to cover in this video. I'll see you in the next one. In this video, let's talk about mix and match results and type results. So we have learned about using results or type results, and there are many helper functions inside those classes. And in the previous video, we used type results for the first endpoint, and we use results in the second endpoint. But we have also talked about that whenever possible, it's recommended to use type results. But if you try to use type results, in this case, when we implement this post endpoint, when we try to use type results, let's replace this. Immediately you'll see this error, and it's kind of confusing why it says parameter 1 is declared as employee, but should be HttpContext. It's not very clear why this happens. So let's comment out the return type. And then let's try to return 1. Okay, and then return 2. Now you can see immediately the red squiggly line is gone, which means that if we're returning something that has the same type, right? So this one is an integer, this one is an integer, then there's no problem. But if you change this one to a different type, let's say this one returns string and this one returns an integer, then you get this error. It's the same error that complains that it should be HttpContext, right? So this tells us that, of course, you need to have a consistent return type, but it doesn't actually consider the type results.ok is the same return type of type results.byterequest. They're different types. They're different types. So therefore, using type results, you need to be aware of this limitation here, right? It's usually a practice when you're dealing with OK, then you use type results. And usually in here, you don't just return a message, you're returning something meaningful, right? So let's try to implement this post request in a proper way. So typically for a post request, the purpose of the post request, what we have learned is to create resource. So therefore, the return type, when it is successful, it is not HTTP 200 OK. It should be created. So created is status 201. Okay. And then this helper function, if we look at the, actually, let's comment this out for now so that we can see the parameter here. Okay. So we have the string and it's supposed to be URL, right? So this is to tell the client when the resource is created, from which URL the client can access the newly created resource, right? So in this particular case, we are adding a new employee into the memory repository. So the new employee can be accessed from employees / and then we use a string interpolation. We just provide the ID, the employee. So employee dot. Let me double check the implementation of this employee repository here, right? So when we add employee to the employee list, we need to give it a new ID. Therefore, what we need to do to fix this small issue here is to first of all get the max ID from the list. So I'm going to say employees dot max of the ID, and then we need to change the employee ID to use the max ID. Only after that, we add the employee to the employee list. Okay, so we fix that issue and we'll come back and we know that the employee actually has a proper ID after this function is executed. And then the second parameter is the value. What is the value? It is the type. And what is the type? It is the employee itself. So let's copy and paste this over here. So this is the proper way to return a post endpoint handler. Okay, and of course, if there's anything goes wrong here, we can say bad request, but because this is typed results, so bad request and created, they're not exactly the same. Therefore, we're having issue. And this is when we need to mix and match results and type results. So over here, if we change this to results, then you can see the rest squiggly line is gone. So here, ASP.NET Core considers the return results is of the IResult. So this is IResult, this is IResult, therefore they match. So why this is IResult? Let's go over here. And let's go to the definition, and then let's go to the definition of this. And you can see that it implements IResult. And of course, results.batRequest also implements IResult. So it considers they are the same. But when we use type results, it kind of explicitly compare the types, and ASP.NET Core considers they are different types. So here we need to remember that if everything goes well, we try to use type results. And this way, we have talked about the benefits of using type results in the previous video, right? And when things went wrong, then we can use results so that they actually match, right? And there's no issues. And let's give it a try and see what's the result. So let's go to Postman over here, and let's try to run. First of all, let's change this one to -4, and then click on the send button. And you can see that it says employee is not provided or is not valid. That's because the ID is less than 0. So let's change it to 4 and click on send. All right, so we get a 201 created, and we can see that the returned results, right? So this is a newly created employee here. The only problem is this ID is 3. We're going to solve this problem later. But for now, let's go to headers, and then we can see the location header contains /employees/3, and that comes from the URL that we just provided. So what is the reason why we have the employee ID number 3 that is returned in the body? Well, that must be because we implemented this wrong. So let's go to here, and this is the max ID +1. It is not max ID. So this is the issue. So let's fix it, and then click on the run button again and try to test it again. So let's click on send. Now we see the ID becomes number 4. Okay, and I believe ID is not required. So let's go over here, make sure. Okay, ID is not required. So in fact, when we create new employees, we don't need to provide ID. So let's delete this, and let's create another one. And this time we're going to call it just Jerry. Maybe Jerry Anderson, and developer. Okay, and the salary maybe 150,000, and click on send again. Now employee is not valid because ID is not provided. Well, that's fine. ID doesn't have to be provided because we already has a functionality that takes care of this, which means that I have to delete this. Maybe let's do this. Let's do this way. This, and this becomes a correct logic. So if the employee is null, then we return 400 bad request. Otherwise, we return 201 created. Okay, let's run it again. And now let's click on the send button. So we created employee number 4 because we rerun the app. That's why the newly created employee is number 4. Right, and if I change this one to Tom Anderson, this time he is a manager, and the salary is, let's say it's even a lower salary, and click on the send button. Now we have ID number 5. So our repository is working correctly. Our status code is also working correctly. And that's everything I want to show you in this video. I will see you in the next one. In this video, let's try to learn about this problem details standard. So what is a problem details standard? Let's actually try to trigger this problem so that you can see why. And so let's go into Visual Studio. And here, remember that we removed one of the validation here. Let's actually add it back. So if employee is null, or if employee.id is less than 0, then we trigger this. So run the application. Okay, application is running. Now let's try to remove this position field, okay, and then try to click on the send button. So what we have here is this. I have type, title, status, errors, and position, and it says the position field is required. So this returned results in the HTTP response body is from the data annotation validation here. But what if we change it back? Okay, change it back, and then we're gonna add ID back. I'm gonna give it -5, and now click on send button again. Now we see this error message: the employee is not provided or is not valid. Where does this come from? It comes from my own message right here. So you can see that the returned results, when there are errors, they are different. So if you are the consumer, right? So for example, you create an application and try to consume this web API, and then in different cases, it returns different type of results when there are errors. Then you wouldn't be able to know what to do. Your code wouldn't be able to know what to do and how to understand the result, right? That's why there is a standard that is created for standardizing the results when there are problems. And what is that standard? That is standard RFC 7807. So if you search that online, get over here and go over here and just paste this. I know the URL because I prepared it. So this is a standard. This is problem details for HTTP APIs. And if you read the abstract, the purpose is to standardizing the returned message or the returned response when there are problems. And why it needs to do that? You already can see that by the demo that I did. This one returns a different response from the data annotation. Data annotation is actually following the standard. So the standard, the RFC 7807 standard, basically says whenever you have an error, you need to construct this JSON structure. There must be type, there has to be title and status. Under errors, it shows you which field has which error. It can be multiple of them inside here. So this is the standard, and we need to follow this standard. So in that case, so if you have a application that you created internally, then it's fine. I mean, it's fine to have this because you know how to handle every single scenario. But if you create an API that is publicly available for some other people to use, then you really need to follow the standard. And if you really want to follow the standard, how do you follow the standard? Do you have to manually construct that JSON? No. The framework, remember, we are learning about ASP.NET Core, and ASP.NET Core should provide you this type of functionality, especially so already a standard, right? So how do we do? Results, remember, results has many helper functions. And one of them here is called problem details. And the other one is validation detail. They would return you the same type of structure, but this one, validation problem. This one is specifically correct in this situation because here we're validating the object here. So how do we construct this? So let me remove this, and then let's check the signature of this. So it has many different parameters. What we can do is that we provide a dictionary, and then we can say this is of string and string array, and now we basically just provide also which field is having issues. In this case, it is ID is having an issue, right? And then we provide the message here. So message is employee is not provided or it's not valid. Okay, so if we have this and try to run this again, and then we go over here and we put this back, and ID changed to -number, an active number, and we see this. See type, title, status, and then we have this ID, and it says employee is not provided or is not valid. Well, of course, here maybe we shouldn't have this ID. We can change to anything appropriate here for the key. That is the standard and how to follow the problem details when we have validations that we need to do inside our endpoint handler logic here. That's everything I want to show you. I will see you in the next one. In this video, let's try to learn about standardizing API results. In the previous video, we have already learned about the problem details, but this is actually not enough. Even with the change that we added in the previous video, where we use validation problems to follow the standard, we are still not covering all of the scenarios. And there are some cases where the result from API endpoints will not be following the standard. So for example, if I run the application, and then if I go to Postman over here, if I just type in a URL, for example, DDD, and then like any URL that doesn't exist in our system, I click on the set button. Now I get a 404 not found. Apparently it's not actually following the standard. So there's nothing actually in the body. Okay, so let's revert this back to employees. Another problem that we can find is, let's say that I removed the body in the post request and set it to null, and then I click on the send button. Now you can see that we're receiving this exception. This is actually a bad request exception that returned back to us, and this is not following the standard either. The first problem that we experienced is the status code problem, right? It returned us 404 status code, but without the body. The second one is it's returning us a exception. We're getting exception from the request, and this is not following the standard. We have to cover both of the scenarios. So how do we cover those scenarios? Let's go back to our Visual Studio over here. Let's first cover the exception scenario. The exception scenario can be actually handled with the exception handler, but it's going to be used in a specific way. So let's go below the builder.build. Let's go over here, and then I'm going to say if the app.environment, if it's development, actually we should say if it's not development, meaning if it's QA environment or something else like UAT environment or production environment, we are going to handle this exception in a specific way, not in this way, because here we're specifying a URL that usually spit up a user-friendly error message. We're going to remove this and just keep it like this. And when we keep it like this, it's going to help us to spit out a problem details result. And this is not enough. We have to go to the line over here. I'm going to say builder.services.add.problem.details. Okay, so this is going to add the problem details services into the service collection. And then when we use this exception handler middleware here, when it sees that it has the problem details services here, it's going to spit out the problem details according to the standard. Now here is a red squiggly line. This is actually a method. We have to call it this way. So apparently there are two things that we have to pay attention here. For the exception handler middleware here, this has to be the first middleware in the middleware pipeline. Therefore, it can actually cover all of the middlewares below it. It has to be the first one. And the second thing we need to pay attention is we need to add this problem details services into the services collection. Otherwise, it wouldn't actually work. Actually, another one that we need to pay attention is that we don't specify any URL over here. And then we see that we have the problem details services that is going to use that. Okay, so this handles the exception. And the other one is the status code. And for that, we can go below this and use another middleware. And this is the status code pages. And again, we're using this version that doesn't have any parameter. And as long as we have the problem details in the service collection, it's going to again give us the problem details. So let's try that again by running the application again. Okay, so the application is running. Let's go to Postman and let's test this first. Okay, so this is the exception scenario. Let's click on the send button. And now you can see that we have this familiar structure here. This is following the standard. Now we can try, actually roll back this, make sure it still works. We're going to cover the sending pass as well. Click on the send button, and then now we get a proper result. And the other one is, let's change this to a URL that doesn't exist and click on the send button. Now you can see that we have the type, title, status, and trace ID. So this is also following the standard. Let's roll this back to the proper URL. And this is the way that we can cover all of the cases, right? Both the status code problems and the exceptions. So with these two changes, status code and exception handler middleware, we're covering all of the scenarios. And so in all cases, now our URL endpoint always returns the JSON that follows the problem details standard. Okay, that's everything I want to cover in this video. I'll see you in the next one. In this video, let's learn about customizing results by implementing the IResult interface. Let's go to our project. You can see that what we have done so far is we're using TypedResults to return the actual results, and then we're using results to actually return problems. And with this type of results, we are getting the JSON only, and this is good for API endpoints. But because both results and results class, they actually implement the IResult interface. So as long as we can implement the IResult interface, we can return something else. For example, if we want to have an actual homepage that supports the HTML, then we can do that by just extending or implementing the IResult interface. So let's try to do that in this lesson. And first of all, let's create a result folder because we may have multiple custom results. So we create a results folder for that purpose. And then we can add a class and we can call it HTML result because we are creating a result type for displaying HTML purpose. Click on add. Now we can implement the IResult interface. All right, and here we do a control dot and then hit enter to implement the interface. All we need to do is to implement this interface. But in order to help us to create the results, remember, we need to feed HTML string into this class. So one of the best way to do it is to feed through the constructor here. So here I'm going to have a string parameter and then let the user pass in the HTML. And here I'm going to do a control dot again to use Visual Studio to help us to create this. So I'm going to say create an assign field HTML. So it's automatically going to do the work for me. I don't have to manually type these lines. Okay, so now inside the class, we have a field, and this field is going to store the HTML. And then we can implement this method. So when we implement this method, we need to change the response to reflect the HTML. But first of all, remember to specify the content type. So because we have access to the context object, so we can do anything about it. Here, we can use response and then content type and then specify text/HTML. This will create the body that with the HTML media type. And then we can say response content length. Yes, we need to specify the content length. What we can do about it is we can say encoding.utf8 and then bytes, and then provide the HTML in it. Then it will return, well, not get byte, but get byte count. Okay, so this works. Now, finally, we will need to say HttpContext.response, and then we write the HTML to it. So we're going to say write async, and then we provide the HTML field to it. And then now we use the async keyword to enable the await keyword over here. All right, so we have the HTML result class created. Now let's use it. Let's go to program.cs, and then over here, this delegate actually returns IResult. As long as it returns IResult, then it's good. It's not going to complain. So I'm going to specify this delegate returns the HTML result, and then it doesn't recognize it. I'm going to do a control dot to import namespace. So it imports the web API.results. Now this, I'm going to use curly braces. We're going to implement that. First of all, we're going to provide HTML. And here I'm going to just have a h2 field, and then I'm going to write my own message. I'm going to say welcome to our API, and then I'm going to finish the h2. And after that, I'm going to accept this, but
I'm going to change this. I'm not going to use the paragraph. I'm just going to say our API is used to learn ASP.NET Core. That's it. Simple message. And once we have that HTML, then we can use the HTML result. So as it suggests, we're going to return a new HTML result object with the HTML variable as the parameter. So this should work. Let's give it a try. So you can see it's right here. Welcome to our API. Our API is used to learn ASP.NET Core. If you go to F12 developer tool and refresh it, you can see that the result comes back is indeed HTML here. And then in the headers, the response headers, you can see the content type is text/HTML. Server is Castro server, which is ASP.NET Core. All right, that's everything I want to show you. This video is an assignment video again. We are going to implement the CRUD operations for employees. We have already implemented two endpoints here. One is to get all of the employees. The other one is to add an employee. So we have the other endpoints that we covered in the middleware pipeline when we learned middleware pipeline. But now, since you have learned the proper way to implement these endpoints, I would like you to re-implement these endpoints and with the correct way, with the correct status code. So what are we missing? We're missing the get employees by ID endpoint, we're missing the put endpoint, and we're missing the delete endpoint. And when you implement it, remember to use TypedResults when everything is okay. And remember to use results.validation problem if you encounter any issues. This way, we will have consistent results when we're dealing with errors. In this video, I will present you my solution. So let's jump into Visual Studio and try to implement the rest of the CRUD operations. So we have implemented this get and the post. We are going to implement the get by employees first. So let's go ahead and do that. app.Map, map to get. And this root template is going to be slightly different. So we are going to allow user to enter the ID, and we can add a constraint over here so that the ID will always be integer. And now we need to provide corresponding parameter to accept the ID into our endpoint handler. And then over here, we can write it in one line or write it in two lines, but let's choose to write it in one line. We're going to get the employee from the employee repository. We'll have a get employee by ID. And let's double check the definition. The implementation of this is just going to use link to return the employee. So there's a possibility that this is null. So when it's null, so let's try to do this. Return employee. If employee is not null, then this is the sending pass. We're going to use the TypedResults.OK to return the employee. Otherwise, we are going to use the problem details, just like this. So what we can do is we can copy and paste it over here. Maybe we can format it slightly better. So break it from here, and then perhaps break it from here. And we need to specify the correct error message now. And we can say employee with the ID doesn't exist. And we need to use string interpolation. So just add a $sign at the beginning. All right, that implements our get by ID endpoint. Let's jump over to the next one, which is the put endpoint. So app.Map put. And for this one, we are going to hit the employees /ID. So what we're saying here is that we're updating the employee with this ID specified in the path, right? In the root template. In the root. So here, of course, we need to receive that from the parameter. We need to allow the ASP.NET Core framework to pass that employee JSON over to the parameter. So this is the model binding. So I'm going to say employee. So here we allow the framework to pass the employee information from the HTTP body to the endpoint handler
as a parameter. So we can call employee and then we close this bracket. Now remember the definition of the employee repository. So if we're trying to update it, and if it's not null, and if the employee exists, then it's going to return true. Otherwise, it's going to return false. Okay, so you can change this logic if you want to be very specific. Otherwise, you can just use it. And what I'm going to do is I'm going to just say return employee's repository and update employee. And now before we pass the employee to the update employee method here, we need to validate like the ID that is passed in. So if ID is not equal to employee dot ID, then we need to return a validation error, right? Just like this one. So return validation problem. And then we are going to say here is that employee ID is not the same as ID. Some kind of message like this would be okay. So after this validation, we know that the ID is definitely equal to employee.id. Then we can pass the employee object to the employee repository. So if this is returned true, then we should return type results no content. This is the proper response here. And then if there is an error, then we can return validation problem, just like this one. So change it over here. And then again, go to employee's repository. And so when do we return false? So employee doesn't exist would be the main cause here. So we're going to say employee doesn't exist. Okay, so we have some problem over here. We're gonna do the lambda expression properly. Okay, so now we don't have the problem anymore. So for this validation, we're returning validation problem employee ID is not the same as ID. Here, this one, if everything goes well, we're gonna return HTTP 204 no content. Otherwise, we are returning the validation problem again, and this is employee doesn't exist. Okay, so this is the HTTP put. And the next one is going to be for deleting. We're going to do map delete, and this also goes to the same path here. And now we need to map it to the ID parameter, and this time we need to implement the lambda expression properly. Okay, and over here we're gonna have the same validation as the get by ID. So, and perhaps we already implemented the validation in the delete method here. Okay, so if it exists, if the ID exists, then I'm gonna remove the employee. So I want to just use that directly. We can say return employee repository dot delete employee by ID. And if it's successful, we're going to return TypedResults dot OK. Otherwise, usually the object that is deleted should be passed into this OK helper function. But because the way that we implemented this delete function, we get it from here. So it looks like this implementation is not appropriate. So we can change it to have it pass in the employee object. So employee, employee, and then here, if the employee is not now, then it's going to remove it. Otherwise, it's going to return false. So we can then use this. But first of all, we need to get the employee. So employee equals employee repository get by ID. And then we can use this employee object right here. And if everything goes well, so it has a green squiggly line here because it's saying that this could be null. So let's go over here and make sure that we have a question mark over here. All right, that should solve the problem. Coming back. Okay, the green squiggly line is gone. And now if this returns true, then we're going to return TypedResults.OK, and then we pass in the employee object. All right, so that's the proper way to implement a delete API here. And otherwise, we are going to return the error message here with validation problem. And that is the same as this. So let's copy this one and paste it over here. Okay, and then let's format it properly. I like it to be broken like this. All right, so this looks like it's implemented properly already. The problem with the validation problem that is implemented this way is that the status code is missing. So we gotta provide a status code, especially for the endpoint like this. So we are looking for the employee, but we can't find it. Usually we return not found. But there's heat arguments that not found should only be returned when we're trying to do routing. But other people say that not found should be a standard way if we can't find the object that we're looking for. So it's really up to you how you would interpret it when you work on your own project. If your whole team agrees with one approach, then go with that approach. Otherwise, you have two options, right? You can return the HTTP 400, which is bad request, or you can try to agree on with the not found. In this course, I'm going to use not found. So over here, as the second parameter, I can say status code equals 404. Okay, so this is not found. And then for this one, if the employee is not provided, then I'm going to specify status code as 400. Let me also break this down like this. And then for this one, it says employee ID is not the same as ID. I'm going to provide status code 400. So this is bad request. And for this one, it's going to be 404. Last but not least, this one is also 404. It's time to give it a try. Let's run the application. All right, our application is running. We have the home page as HTML, which is pretty weird for a web application. This is only for demonstration purpose. And then get over here, we're trying to get our employees. So first of all, we get all of the employees, and we got all of the employees. And secondly, we're trying to get, let's say, the first employee, and we got the first employee. And what if I enter number 4, which doesn't exist, and I get the proper response with the status code 404, and that is the correct status code, right? And then let's try to use Postman to test the other endpoints. So let's copy the port number and go to Postman. We're going to test the add. If we provide null and click on send, we get not found. That's because the path is wrong. So let's change to correct path and click on send again. So this is 400 bad request. This is correct. And let's change this to proper way. So change this to actually remove the ID. This is proper JSON, and then click on send again. Now we have Tom Anderson added. So this is okay. And if we try to get a employee by ID, that one we already tested. So let's test the update employee. We're going to update number 4 manager, and we are basically just changing the salary. And here we need to specify the ID to make them the same ID. So what if I just put in a different ID and click on send button? So now it says could not send request. It's probably because the port number is wrong. So let's go to the correct one. Copy the port number. Let's go to put request and paste it over here and click on send button. All right, so we have 400. That is correct because the employee ID is not the same as ID. Right, so let's go over here and update it to 4. And now let's click on send, and we have 204 no content. All right, so let's get all of the employees over here. Make sure the port number is correct. Click on send, and let's check the number 4. Okay, the salary is updated. So our previous update was working correctly. Now the last one is delete. So if authorization header isn't being used right now, so it doesn't really matter. So here we're trying to delete number 4. What if I put 5 and click on send? Then, well, again, port number needs to be changed. So try again, click on send. Now I get employee with ID 5 doesn't exist, and it gives me 404, so everything looks correct. So I'm going to change it to number 4 and click on send again, and it says that 200, right? And it returns this. Basically, the employee is deleted correctly. Let's go to employees endpoint and try to get all of the employees again. And now I have only 3 employees. So the delete endpoint also works. So everything passed testing and everything seems to be working as we expected. And that's my answer for the assignment. In this new section, we're going to talk about code organization and dependency injection. In this first video, we're going to cover code organizations for minimal API endpoints. So far in our program.cs file, we have defined many endpoints, and as they are growing, you have already seen that this looks quite messy, especially currently we only have employees, but later when we have more and more models created, you are going to be CRUDing this one program.cs file, right? So it's impossible to maintain code properly with everything within one file. So there must be a way to organize the code. So one of the most popular way to organize minimal API endpoints is to use extension methods. So let's create a folder, try to organize our employees endpoint. So first create a folder, and we're going to call that folder Endpoints. And inside it, we're going to create our employee endpoints. So let's go ahead and create a new class, just a plain C# class. And we are going to call it employee endpoints. And for this class, we're going to use static methods. So we're going to make this class a static class as well. And then what we are going to do here is we're going to create a static method, and we're going to call it map employee endpoints. And here we're going to extend the web application class like this. I'm going to call it app. Why do we extend the web application here? So if we go back to program.cs over here, and you can see this app is of the type web application. So if we extend the web app class with this extension method, then what we can do is we can come over here and basically cut and paste, right? So we're going to cut everything that is related to our minimal API endpoints, and we're going to paste it over here. Okay. And now this app is again web application there. So everything's supposed to work, except that we need to import some namespace. So if we do control dot, we don't see the namespace import. So let's actually go to program.cs file and then hover the mouse over it. We can see that this comes from Microsoft.ASP.NET Core.HTTP. So if we go back and try to import that namespace, actually I have tried, it doesn't actually work. So what we probably have to do is to come over here and directly import it. Microsoft ASP.NET Core.HTTP.Results. So you can see that it actually works here, but it doesn't work with the using clause here. So we're going to paste this to every single one of this. So I'm going to do this as well and format this a little better. Okay, and then come over here and do this one as well. So every single one has been replaced, and here is a spelling error. So let's change that, spelling error. Okay, so now we have this method. All we need to do is then go to program.cs file. I didn't cut it properly, and then over here we just need to say map employee endpoints, and that's it. So this is calling the extension method that is defined right here in the endpoints. And all of the endpoints are organized under this endpoints folder. So for example, eventually, if we are creating more classes, for example, department has multiple employees and one employee always belong to one department. In that case, we're going to create a department's endpoints class. So we have this employee endpoints properly organized. I just need to make sure everything still works. So let's run the application. And as you can see that the first one works properly. Let's try about the second one, which gets all of the employees for us. And then we're going to try the third one, which gets one employee for us. And then we have the other ones that we can only test with Postman. So let's quickly go through all of them. All right, we are going to update employee as well. Oh no, actually add employee first. So I'm going to add the fourth one, which is Tom Anderson. And then we're going to update Tom Anderson to have a higher salary, let's say 250 or 2 million. Is it 2 million? Even higher than that. That's fine. Let's go to get employees, make sure it's updated. All right, it's updated properly here. And then let's delete the fourth employee, which is Tom Anderson. So let's delete it. Come back to get employees, run it again, make sure the fourth one is deleted. And it is indeed deleted. That means our organization didn't break the code, and it actually indeed made the program.cs file cleaner. Program.cs file is where we configure the application and Castro server. It shouldn't include any logic. Therefore, this kind of extension methods hides all of the logic in an extension in a static class here, and I like. All right, that's everything I want to cover in this video.